Stream started. Good evening, good evening, good evening, good evening. I'm sorry. Good evening, Black Mystery. Good evening, Vittal Kumar. Yes, beta. Today we are going to start the revision marathon, and yes, I hope I'm audible. Actually, the 2 minutes delay is because I was just resetting my mic. Yeah, hi beta, hi APH, hi Sham. Hello everybody. Now, we have been the mic has been creating problem for us, so we are delayed by 3 minutes. But nevertheless, it is going to be a very in-depth marathon, and today we are going to start with first. See, yeah. Good evening, Black. Good evening, Black Mystery. Yeah. So today we are going to start from physical chemistry basics. Now, why I have taken these physical chemistry chapters as in three basic chapters: the mole concept, the atomic structure, and along with that mole concept, they always couple it with redox reaction, because while we are focusing on the concentration terms, then we get scared by the term of normality, and normality can only be understood if we know the redox reactions basics. So yeah, okay, so no issues, fine. So actually, first we'll be discussing all the in-depth analysis of the physical chemistry basics, these three chapters: mole, atomic structure, and redox reaction. And post doing those chapters, we'll then be going with the periodic table, chemical bonding, and d block element and coordination compounds. So our job for today is, the topic that we'll be discussing today is, first we'll be starting with mole concept, redox reaction, atomic structure. Then post atomic structure, we'll be very comfortable with the electronic configurations and the Aufbau principle, the rule by which electrons are filled. So then we'll be very comfortable with doing the periodic table. After that, we'll do chemical bonding, then DNF, and then coordination compound. So yes, definitely 12, it is definitely going to take around 8 hours. We'll be taking breaks in between. Chai pani will be done in Sir, how many hours? Beta, see, 12 is the minimum which I feel should be reached, but we'll try not to extend it. But yes, one thing is for sure: the way I'm going to, yeah, so I'm the guy, thank you very much. The way I have made these presentations for you is, first what we'll be focusing on the most is, you do not have to read any theory if you're paying full attention over here. For example, if you're not comfortable with, let's say, any of the theoretical concept, then you need not go to the detailed one shot, although those one shots are already there. But you have, for your April attempt, you have very less amount of time. So I'll be discussing all the complete and relevant theory, and with that theory we'll be discussing questions also. So what is your job after today's live? Your job is to revise with these notes. Do not take any other notes, these notes, and then practice as many questions as you can, especially the previous year question, the PYQs. And the way you have to attempt those PYQs is, first attempt the January PYQs, then 2025, then 2024, and then whatever and how much you can. Obviously, more and more practice will help you to do the same question with higher efficient. That is, you will be taking lesser amount of time to do the same question as compared to other students. So that will be increasing a percentile as well. I hope we are clear with it. Sir, nevertheless, time, please take. Haan beta, Black Mystery, matlab, I'm not saying I'll be doing any short tricks over here. I'll be discussing the complete theory, no matter what is the time. So thank you for the confirmation. Sir, please give the notes. Beta, notes, whatever notes we teach over here, those notes are for you only. But yes, for that, what you have to do, go to the link in the description section and join the WhatsApp channel, PWJ English WhatsApp channel. All the notes, all the lecture notes which we teach over here are periodically and regularly updated in that group. So with that group, you can definitely download these lecture notes. So I hope we are clear. Yes, Dubey ji, hello, Radhe Krishna beta. So with that awesome note, with that awesome blessing, so let us start. Okay guys, so we are starting with हाँ, perfect. Beta, take out your pen and copies for each question and for each theory. The theory also, although these notes you will be getting, but I would rather suggest you should take these, start making short notes in your copy itself. So, yeah, perfect, perfect, perfect. Thank you for that response, and we shall start now. So, starting with the the first chapter, basic concepts of chemistry, the mole concept. So, let us start with mole concept. If we discuss about mole concept, the first thing that comes to our mind is relative atomic mass. What is relative atomic mass? Sir, atom is so small. Because atom is so small, sir, ready with pen and paper. Yeah. So because atom is so small, you cannot easily, although atom in nature is existing in form of molecules. So how do you weigh an atom? Atom is weighed with respect to the simplest atom. The simplest atom was hydrogen, but because hydrogen do not react with everybody, so a reference was chosen, and reference was C12 isotope. But to mathematically make it equal to mass of hydrogen, we divide mass of C12 isotope by a factor of, we multiply by a factor of 1 by 12. So this denominator becomes 1 Dalton. It was known as 1 Dalton initially. Later it was known as 1 atomic mass unit, and at this point of time in today's world it is called 1 U. So you can weigh any atom with respect to this. And to this denominator, we will now refer as 1U. Now, what is this 1U in terms of gram? This is nothing but mass of one hydrogen atom. So, mass of one hydrogen atom is approximately 1.66, 1.67 into 10 raised to power minus 24 gram. So, 1U is 1.67 into 10 raised to power minus 24 gram. And what is relative atomic mass? Mass of any atom with respect to this denominator. Now, so ultimately, we now know what is an atomic mass. So, for simplification, we can say that atomic mass is nothing but it is relative atomic mass. Now this relative atomic mass will have no unit into this denominator, and this denominator we have recently seen it can be written as U. Now if you measure an atom, sir, atom is constituted of nucleus having proton and neutrons and the revolving electron. Mass of electron is negligible in front of this mass of proton and neutron. Therefore, together protons and neutrons are also known as nucleons. So, actually in an atom, who is the dominant species which is creating the mass? This nucleus. So, therefore, we can also say atomic mass can be approximately equal to the mass of the nucleons. And with that, we definitely know how to measure an atomic mass. But in nature of that atom, one isotope will not exist. Many of the isotopes will exist. So what we rather do, we take their average atomic mass. Now what is this average? For example, the best example is chlorine. In nature, chlorine has isotope 35 also. Chlorine has isotope 37 also. 35 isotope has a percentage occurrence of 75% in nature, and this guy has an occurrence of 25% in nature. Now we definitely know how to calculate the average. Your weight into your percentage existence plus your weight into your percentage existence. If you add them, you will get the mass, which is the average atomic mass. So if I'm referring as average atomic mass, then average atomic mass will be equal to the relative atomic mass, which is 35.5 for chlorine. Now this does not mean that chlorine has fractions of protons and neutrons. It is the average. And sir, but for all atoms we do not write the average. For all and every atom and molecules we take the average only. In nature, one of the isotope is existing in such a higher percentage that the average is equal to an integer only. But ultimately, each of these atomic and molecular masses are nothing but the average. So atomic mass will be equal to what will be their average mass into U. Now, sir, but U is a very small quantity. So what we rather do practically is, because we cannot measure mass in terms of 10 raised to power minus 24 gram, that precision machine is not existing in nature. So what we rather do is, we take the value which is mole. Now mole is a very beautiful unit. How does it help us? Actually, if you say that what is mass of one water molecule, ultimately molecules exist in nature. So we all have seen water. So what is mass of one molecule of water? 18 U. So what will be the mass of two molecules of water into 2? What will be the mass of 3 molecules of water? Into 3. What will be the mass of 1 mole molecules of water? Now this 1 mole is represented by Avogadro's number Na, and its value is 6.022 into 10 raised to the power 23. Everybody knows it. Now what is it? What does it? How does it helping us? Actually, 1 U into Na is mathematically equal to 1 gram only. So U and Na can be replaced with 1 gram. So whatever you have over here, that becomes your mass, but mass of not one species, mass of 1 mole species. So whatever mass you have, whether it is atomic mass, whether it is molecular mass, if you take 1 mole of those species, that mass automatically becomes the molar mass, because molar mass is nothing, it is the atomic or molecular mass but taken in gram, and gram we can very well measure using, gram can be very well measured using the measuring devices we have around us. So that is the significance of 1 mole. Now, because 1 mole is so significant, so what comes later is the calculation of number of moles, and now this is the topic where we are finding our interest in, because this is the topic which is asked in your JEE examination. Now, what is this number of moles? Number of moles can be calculated via 3 processes. It depends upon how the question is asking you the question. If in the question number of substances are given, it may be an atom, it may be a molecule. So in terms of number of moles can be written as number of species upon Avogadro's number. So the formula becomes N upon Na. I hope we are clear with this. Now, if we are given weight of the substance, then how to calculate number of moles? Sir, put the weight of the substance in the numerator. And what is mass of 1 mole substance? Sir, we have recently seen it is molar mass, and molar mass is nothing but molecular mass in gram. Therefore, whatever weight you supply in the numerator, whatever weight of substance you supply in the numerator, that weight has to be placed in gram. That's why in the formula also I have written weight of substance in gram upon molar mass. Now, sometimes for substance, volume of substance is given in the question. So if volume is given, then what we do? We put the volume of substance upon volume occupied by 1 mole of substance. That will be termed as molar volume. So that will give us number of moles of that substance. But sir, how to calculate molar volume? For molar mass, you have given us the direction. Actually, molar volume is not constant, obviously. Plus, if we have to calculate this volume, then we can apply a formula. What is that formula? Formula is PV equal to nRT, which is nothing but ideal gas equation. That means we can only apply that volume formula for a gas. Now, sir, actually the questions, the NCRT, they take a standard temperature and pressure. What is that standard temperature? 273.15 Kelvin, that is 0 degrees Celsius. What is the standard pressure? The pressure which atmosphere exerts on us, that is atmospheric pressure. So if we take pressure as 1 atm and temperature as 0 degrees Celsius, our value of R, we definitely know that in terms of atm liter, it is equal to 0.0821. Now, these things you should learn, although states of matter has been removed from advance, but these things you have to learn, these things you have to know. So, what is value of R when pressure is in bar? It is 0.83. What is, because PV is also a factor of work, so if you put that PV factor in terms of joule, then the value of R becomes 8.314 joule per Kelvin per mole. Now, if we use this value, we can calculate this volume. Now, this volume will be volume of the substance that is occupied by 1 mole of that particular species, and that particular species has to be a gas, because PV equal to nRT, you can only apply for a gas. Sir, so this volume we can learn also? Yes, because all the time if you calculate that, then obviously it will be a waste of time. Now, if you calculate at 1 atm and 273 Kelvin, the molar volume will come out to be 22.4 liters. But JEE, especially advanced, plays with it. Advanced started taking the standard temperature and pressure as 1 bar and 0 degrees Celsius. Sir, 1 atm and 1 bar are not equal. Yes, definitely not equal. What is the relation? Sir, we know 1 atm is equal to 1.013 bar. Therefore, yes, almost approximately both are 1. But if you go till 3 places of decimal, there is a problem. Therefore, if you take 1 bar as the pressure, then the molar volume becomes 22.7. Now, I definitely feel that for mains also, you should at least know this value, this fact, that when pressure is 1 atm, then molar volume is 22.4 liter. When external pressure, when the given pressure of the gas is 1 bar, then the molar volume becomes not 22.4 but rather 22.7. Now, this is how we can calculate number of moles using the powerful 3 formulas in terms of number, in terms of mass, and in terms of volume. One important thing with the January attempt, you must have seen they have started playing with the theory. The way they are giving you the way they are serving you the questions, the way has been tremendously evolved. Actually, they plays with the way, with the statement, with the English, and once we are attempting our question paper, the interpretation of English becomes very crucial. So you should make a note of this point, that you should attempt your PYQs with a frame of mind that start at least read the question. Do not have a prerequisite, do not have a prejudice that no, the question is asking this only. Many of the times we read the question, but we have a prejudice in our mind. nahi, question to yahi pooch raha hai. Read the question and see what it is asking. At least it will require 10-15 seconds more. But many of you will see that while reading a question, you misread the question, and the misreading happens just because of the prejudice. You think that I have seen this question, and you read the question as you want to read it, not as the question is served to you. So going to that statement, one thing with JEE plays with is 1 gram atom is not actually 1 gram of atom, because 1 gram atom is also a scientific way of representing 1 mole of atom. There is no preposition. This is not 1 gram of atom. This is 1 gram atom. So 1 gram atom implies 1 mole of atom. Similarly, 1 gram molecule implies 1 mole of molecule. This is not 1 gram of molecule. So that of plays a very crucial role. Whenever 1 gram atom or 1 gram molecule is given, you should always remember that it is given the moles of atom or molecule. I hope we are clear with it. So please last test का PDF बैच में अपलोड कर दो, आया नहीं अभी तक. अच्छा पीयूष, इज इट सो? आई विल डेफिनेटली लुक इनटू इट. थैंक यू पीयूष फॉर दिस. लास्ट टेस्ट एज इन मॉक टेस्ट 3, मॉक टेस्ट 8 now of the rank booster batch. I'll definitely look into it beta. By today it will be posted in the group. Moving forward now, sir, now number of moles, maybe you will get questions from number of moles also, that calculate number of moles of this, that can be a JEE Mains question. Now, but to make it a better question, what NTA do is they mix it with the concept of stoichiometry. Now, what is stoichiometry? It is nothing but unitary method. Now, what is this unitary method? In Latin, stoichio means element and metry means measurement. So when you do elemental measurement, that is your balancing, that makes the stoichiometric coefficient. For example, I know benzene on combustion produces CO2 and H2O. Once we balance the reaction, we get this stoichiometric coefficient, and they help us to actually read the reaction. Now, how to read the reaction? 1 mole of benzene reacts with 15/2 moles of oxygen to produce 6 moles of CO2 and 3 moles of water. You can also always read the reaction as 1 molecule of this reacts with 15/2 molecules of this to produce 6 molecules of this and 3 molecules of this. You can never say that 1 gram of this. You can even not say that 1 liter of this, because you do not know that what is the weight and volume of this box. So the stoichiometry can only and only be applied for number of moles 1 and number of molecules 2. I hope we are clear with it. Now, let us apply that stoichiometry, and remember this point, that we can only apply the stoichiometry in number of moles and number of molecules, not in weight, not in volume. So if weight and volume are given, then what to do? Apply those number of moles formula. For example, this is a JEE Mains question, 2021 question. The question was asking us that methylation of 10 gram of benzene. Now I have benzene. Now benzene when reacted with okay, I am the question is just telling me methylation. So what does methylation mean? Let's say I'm reacting it with CH3Cl in presence of AlCl3 anhydrous. This is classic Friedel-Crafts alkylation. The organic reaction we'll be covering, but because we are practicing, so telling you everything. And we definitely know that in presence of this Lewis acid, Cl is removed in form of Cl minus. We get a carbocation over here, and because benzene is electron rich, so it attacks the carbocation and produces a substituted compound. The substituted compound over here will be toluene. Now, this is the organic that the examiner wanted you to know previously, and now apply stoichiometry. This is how they couple the reaction. This is how they couple the chapters. That's why I said these physical chemistry basics are important for organic also, for inorganic also. Now, so this benzene is producing toluene. Now let us go to the stoichiometry. It is saying that you are using 10 gram, sir, but stoichiometry we can only use for moles or molecules. So let us find number of moles. So number of moles will be 10 upon molar mass. What will be molar mass of benzene, which is C6H6? So 6 is 72 plus 6, that is 78 gram. So these are the number of moles of benzene given. So sir, 1 mole of benzene will definitely create 1 mole of this. I have not written the byproduct because this benzene structure is here only. This is also principle of atom conservation, that whatever carbon atoms are here, it will be here. So now whatever moles I'll be having of this reactant, the same moles will be produced for the product. Now, so if 1 gives 1, therefore n moles will give n moles of product also. So we know how much product should be produced, but the question is saying the product produced is whatever moles it may be. The actual product produced is this much. So this is weight of actual product produced, and therefore the question is asking us percentage yield, because 1 will give 1, n will give n when percentage efficiency is 100%. Sir, if it is not, then percentage yield will be less than 100%. So whatever it will be, let us calculate. So percentage will be weight actually formed upon weight formed theoretically into 100. So this is nothing but weight actually formed, and let us now estimate what should be the weight formed theoretically. So sir, n produces n, so n moles should be produced theoretically. So what should be the weight? Again, use that number of moles formula. So weight will be equal to number of moles, which is 10 upon 78 into the this is number of moles into weight of this upon molar mass of this. So what should be the molar mass of this? This is C6H5 because 1 hydrogen has been removed from here. So this becomes 77 plus carbon and hydrogen is 15. So 7 5 is 2, and this becomes 7 8 9 92. So this is weight upon molar mass. So 92 will come in the numerator. So this will be the weight that should be produced theoretically. So what will be the percentage? Let me take another pen to calculate percentage. So percentage will be actual rate produced, which is 9.2 grams, upon theoretically how much it should produce. So 92 into 10 upon 78. So 78 come in the numerator into 100. Now the calculation is quite easy. Let me remove 1 0, so it will be cancelled. The 0 will also go. So answer is simply 78. So answer will be 78%. I hope we are clear with this. Now, any doubt? Anuj is saying, sir, always state board exam are always state board exam are great than CBSE exam. Yes, beta. Obviously, if you are belonging to a state board, then whatever you are doing is the greatest. I mean, no doubt with that. But everybody, whatever they have has to be great for themselves, beta. Then only the universe will prevail, because wherever you are, whatever you have should be the best possible thing for you, and it is the best possible thing for you. So do not worry with that. Moving to the next topic now. Sir, you said that stoichiometry can only be applied in number of moles and number of molecules. Yes. But sir, sometimes we can apply that stoichiometry in volume also. Not always, sometimes. And what is that sometimes? That sometimes is governed by Gay-Lussac's law of gaseous volume. Now, what does Gay-Lussac's law of gaseous volume tell us? It says that whatever stoichiometry you use for number of moles, or rather for number of molecules, you can do the same stoichiometry for volume as well. But when participating species are all gases and the temperature and pressure for all the participating gases are same. So question must mention that all the participating species are gases and they are taken under similar condition of temperature and pressure. So if at all, when gases combine or produced in a chemical reaction, they do so in ratio of volume, provided all gases are same at same temperature and pressure. Logically speaking, PV is equal to nRT. So when pressure and temperature are constant, volume becomes proportional to number of moles, and therefore whatever stoichiometry you apply for moles, you do that for volume as well. And NTA plays with such questions also. So let us practice this question. I sip some water. By the time some of you can give me the answer, please. Sir, complete physical chemistry detail in gunshot within 2 days, sir, including more problems. Yes, yes, Asif beta, today we are dealing with these basics physical chemistry. Post that IOC will be done today. The next live for chemistry that we'll be meeting, I guess on the 3rd day from today. So on that day we'll be doing complete organic, and on the the 3rd live of chemistry that will be coming post 3 days from that day. I mean, with all in these consecutive days, you are going to have your live. The lives are in the order: first physics, then second today's chemistry, then maths. This is live day 1. After that, live day 2 of the 3: physics, chemistry, maths, the same sequence, and then live day 3: physics, chemistry, maths. So the last day 3 of chemistry will be physical chemistry. So don't worry, I'll be coming with everything. You do not have to even read those one shots which are there, because obviously they are good. Actually, we have put in loads of effort to make those gunshots also, but we understand you're having short of time. So these live are your lecture notes also. So attempt this question. By the time let me sip some water. All physical chemistry beta day 3. Thermodynamics also day 3. Alan, so please don't get demotivated by views. No beta, see, I'll tell you one thing. Even if we are having 10 views, see, we get full salary because ultimately we are here for serving whoever student is in need, for a teacher who shall give him whatever is best possible for the student. So we are getting full salary. Do not worry. So why we will get bothered by views? So don't worry. Moving to the question. Sir, take 2026 PYQs and organic session. Sure, beta. Actually, beta, why I take previous year's PYQs more? Because 2026 we have done separate session for the discussion of all important chapters, also the lives also we were doing. So yes, but definitely if the question is related to the context and it is offering a better version of the question, then obviously we'll be taking that only. So don't worry. Mainly statement based questions. Okay, Asif, I got your point. The theory I have deliberately included over here, and the reason I'm including this theory is because to allow you to read the theory also and practice questions also. So moving to the next question. lesser the number of participants, lesser will be distraction. Beta, matlab, ultimately, I'm saying that the number doesn't matter. I mean, but yes, obviously they do after some point of time. But this is the first year of PWJ English. So for first year, obviously, there is a profit also. After that, obviously, we'll also be having more love and more affection by more students, because we also want to cater as many lives as possible. So moving forward now, that personalized talk we'll have in the batches. So come to the batches. PWJ English Vishwas Divas has been extended till 15th. You still have 2 more days, so please do join us. After your, if you feel that you need a drop or something like that, then Prayas, Laksh, Arjuna J English, all are there, so we can obviously come now. So please talk in Hindi. I can, obviously I can, but this is a platform provided by our organization for all those students who are not comfortable in Hindi or maybe English. That's why we are supposed to always speak in English. Baki, haan, Hindi, Punjabi, I'm a Punjabi. So obviously that though we can definitely speak anytime. Now, but here we are specially appointed to cater the crowd who specifically wants to learn in English. So Brahmacharya ji, I'm sorry to disappoint you, but I have to, because that is why I'm being paid for. So moving to the next question. Acha, sorry, the nobody has given me answer. Everybody is doing bachit, nobody is solving. So please solve, beta. Now let us see the question. 10 ml of gaseous hydrocarbon on combustion gives 40 ml of CO2. Okay, that means it's an hydrocarbon, so it is CXHY on combustion, as in reaction with oxygen. So hydrocarbon on combustion always produces CO2 and H2O. Now let us balance it. So let me make 1 over here. So X will come over here. Carbon is balanced. This is Y. So Y by 2 come over here. Hydrogen is balanced. Let me go to oxygen. Oxygen is 2x and y by 2. So 2x divided by 2 is x, plus y by 2 divided by 2 is y by 4, because 2 is there in the oxygen. So this is how you balance the reaction. And recently we have seen that whatever stoichiometry we have obtained, you can do that stoichiometry for moles also, but you can do that for volume also if participating species are gases. And question is specially mentioning you that it's a gaseous hydrocarbon, and on combustion it produces CO2 gas and water vapors. So because all these components are gases, so we can use these stoichiometric pressure, all are gases, and pressure, temperature, because all the reaction is happening in the similar dabba, in the same box, in the same enclosure. So obviously the temperature and pressure of the enclosure will be same. So because temperature, pressure is same, all participating species are gases, so rather we directly go to the stoichiometry of volume. So we can also say that 1 ml of this will produce x ml of this and y by 2 ml of this. Now how much ml of actual hydrocarbon I'm using? 10. So 1 produces x, so 10 will produce 10x. 1 produces y by 2, so 10 will produce 10 by y by 2 into 10, as in 5y. So 5y of water is produced and 10x of CO2 is produced. And what is the volume actually getting produced is already given to us. That means 10x is given out to be 40. So x is simply 4. 5y is given out to be 50. So y is nothing but 10. And what we have to calculate, total number of carbon and hydrogen atom in the hydrocarbon. So what will be your hydrocarbon? CXHY. So what is the total? 10 plus 4 is 14. So what will be your answer? 14. I hope we are clear. Yeah, Dubeji, thank you. 14 is the answer. Yeah. Allanite. Perfect, 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 Mr. Schrodinger. Moving to the next question. Now, next logic. Next concept is, sir, many a times the question is not supplying us with density. Rather, it supplies us with specific gravity or vapor density. Now what is it? Let us do the theory. Absolute density is what density you know. That is, density is mass of substance upon volume of substance. Like for example, density of water is 1 gram per liter, 1 gram per ml, or 1 kg per liter. Make sure that you remember this unit also, 1 gram per ml or 1 kg per liter. Now, what is specific gravity? Specific gravity is a definition just like relative atomic mass, so it will be dimensionless because it is ratio of density upon density. But we say specific gravity, then we mean specific gravity of a solvent. So specific gravity is nothing but density of that particular liquid, that particular solvent upon density of the universal solvent, which is water. So I hope you should remember what is specific density. And similarly, when you do this for gas, the specific gravity is termed as vapor density. That means vapor density will also be dimensionless. And the formula is the mathematical definition. Because water is the universal solvent, the simplest solvent. Similarly, who is the simplest gas? Hydrogen. So if we take vapor, if we say vapor density, then this is density of any gas upon density of hydrogen gas. We have recently seen for gases we can apply gas law, that is PV equal to nRT. So for moles, just write weight upon molecular mass. So you can definitely calculate that density of any gas is equal to pressure of gas into molar mass of gas upon RT. Now use this in the formula. So density of any gas becomes pressure molar mass upon RT. Now obviously if you are calculating vapor density of any gas with respect to hydrogen, so all that gas and hydrogen must be present in the same container. That means temperature and the overall pressure will be same. So this P and T will be getting cancelled. R is definitely a universal gas constant. So what will be the variable? This molar mass. What is the molar mass of hydrogen? 2. So what is ultimately remained in the RHS? Sir, m by 2. So formula of vapor density becomes molar mass of gas upon 2, but this vapor density is dimensionless, remember. I hope we are good. Yeah, perfect. Now, after doing this definition, now let us see if you can do the question. So let us do the question. The question says, it is JEE Mains 2019 question. So attempt this also. I sip more water. Let us keep ourselves hydrated. Actually, today I was trying to get this AC fitted in my studio, but I failed. By next class it will be. Santosh beta, how do you practice maths? You don't have to memorize anything in maths, na? Is what you feel. Actually, it is not the truth. How do you practice maths, Santosh? I tell you. 5x square minus 3x plus 2 is equal to 0. Do by part, or else apply the formula minus b plus minus under root b square minus 4ac upon 2a. Either way you will get. What is this? You have practiced such questions. The another question will become 6x square. I mean, this is a class 10 basic I'm talking, but actually you practice the similar question with different values again and again. So while you are practicing, actually what you are doing, you are writing and memorizing the process. I hope we are clear with this. Remember when you were there as a nursery student, you were given this in your copy and you used to write it 10 times. Isn't it the same process? So actually my point is everything requires practice. So if you say, sir, if we are memorizing, then ultimately if you are writing and memorizing the process, that is also a way of memorizing things only. Now why? Actually, once we are in class 10, you are in class 10, people say, IOC is full of theories, sir. Yes, definitely. Santosh, I agree to the fact. But if you feel that you are going to crack JEE and sit in a position where you will be paid to, like, there are two people. One people is paid, let's say, 1 rupee for a job, and the other person is paid maybe 1000 rupee for the same job. Why? Because maybe that 1000 rupee getting person is a manager. Now manager does what? Manager manages. In order to manage, you also have to think of 10,000 things at the same point of time. So ultimately your memorization power, your analysis is largely dependent on how much hard disk you have over here, because that amount of processing, even AI can't be trained for that. AIs can be trained for a particular specific object, but for a smart decision making, for a variable decision making, you always require a human. And for, in order to be that human, you need a hard and strong hard disk over here. So how this hard disk is going to evolve? So I'm nobody is going to ask you number of moles is equal to weight upon molar mass when you go down the lane in your professional career. So why is it asked over here? Because with the same amount of time, if 12 lakh 15 lakh people are studying and analyzing the same thing, some people are memorizing and segregating thing to a better extent. That means they are a better processor, that means they are a better handler of loads of stuff. So they are indicating that they can be a better managers, they can be a better problem solvers. So it is a process, it is a way of segregating few from a crowd of lakhs. So obviously that has to be done. Thank you for the answer, Mr. Dubey and Mr. Strodinger. Now let us decode the question. People are saying answer is A, so let us check. Let me check, because some people have given us the answer. So let me check that whether, yeah, answer is A only. Perfect. So let us decode this question. The question says a mixture of NO2 and N2O4 has a vapor density of this much. So that means definitely this NO2 is becoming maybe twice of NO2 when combined. It can become the dimer, which is N2O4. So these two gases are interconvertible in each, obviously can be converted within each other. I mean, every reaction is reversible. So rather, let me make it like this. Now, the question is saying I have mixture of this, and the vapor density of mixture is this much is the vapor density of mixture. So mixture will have at equilibrium, the mixture which is at equilibrium, let's say I have to calculate moles of NO2. So let's say I have n moles of NO2. So I'll be having some let's say this is the mixture, this is the vapor density of mixture. So can you tell me what will be the molar mass of mixture? Yes, because they are gases, I can say vapor density is molar mass upon 2. So molar mass of mixture will be vapor density into 2. So what is this? Molar mass is mass of 1 mole of mixture. So let's say this is mass of 1 mole mixture. Let's say I have 1 mole mixture. So in that 1 mole mixture, if number of moles of NO2 is n, then what will be number of moles of N2O4? Sir, 1 minus n. And mass of this plus this is nothing but this. So ultimately what I have to calculate, I have to calculate the number of moles of this N2 in 100 gram of mixture. Okay, it is giving me 100 gram of mixture. So this is the molar mass of mixture. So can you tell, if this is the molar mass of mixture, so what will be the number of moles present of the mixture? So number of moles is equal to given weight. So what is the weight of the mixture? So weight of the mixture is given. So weight of the mixture is 100 upon what is molar mass? We have recently calculated, it is 38.3 into 2. So this becomes number of moles of mixture. Now, if number of moles of mixture is n, yes, then this will rather change. Why? Because total moles are this. Total moles is this. Total moles is this. If this component is n, then what will be N2O4? It will be number of moles of mixture minus n. I hope we are clear with this. Now, we have to calculate this n. So what to do to calculate this n? Sir, number of moles of mixture we know. So we know this moles of mixture is equal to weight of this plus weight of this. So let me do weight only. Let me say this is 100 gram, because or else we'll be introducing variable. So this is 100 minus W, and we definitely know what is total mole. So let us equate moles. Therefore, equating moles So what will be the number of moles of NO2? Sir, it will be W. That I do not know. Upon molar mass of NO2 will be 14 plus 16, 2 is 32. So this is 46 plus 100 minus W upon. What is molar mass of this? Sir, 14 into 2 and 16 into 4 is 64. So this is 4, 4, 16, 1, 4, 1, 4, 5 and 64. So this is nothing but 120. And what are the total moles, by the way? Sir, it is 100 upon 38.3 into 2. This is how you can calculate W. Once you get W upon 46 will be your answer. Into divide for such questions you have to do. So if you do that into divide, you will find your number of moles will be 0.437. I hope we are clear with this. Now, moving to the concentration terms. Now, concentration terms. Sorry, sir, I am feeling very bad. Huh? Why? I did not study till now as a dropper, okay, and now I do not know what should I do in 20 days. Study. Prince, it's perfectly okay, beta. Many of us makes mistake. Many of us make that mistake. Do not worry. But many of us, most of us will be doing that this feeling of left out. So why leave your brain to have that feeling? Rather invest your brain in the work. Thank you for coming over here. If you have 20 days, the 9 coming days, 1 day of physics we have already spent. So the coming 8 days, including today, read the theory from here and practice these questions and the PYQs. What is the order of attempting those PYQ? January 26, then 25, then 24. The same process. Then you'll have no time to regret, beta, because we have time to work. This is not the time to regret. So don't worry, start working, my friend. Please start working. Everything will be good. Moving to the next topic. Sir, concentration term. This will help you in solution and colligative property chapter also. So what is concentration term of a solution? If we have a solution is always obtained of solute and solvent. Solute, for mathematical ease, whenever I will write concentration terms, I will mention 2 as solute and 1 as solvent. Solute and solvent are mixed to form solution. Now, what type of solution we have? Solute and solvent can have whatever physical state, solid, liquid or gas. Whatever is the solvent, they get dissolved in that particular solvent, and these are the varieties of solutions which you can have. Obviously, you know them through solution and colligative property. We'll be doing physical chemistry separately in the day 3 of chemistry live. So this is how we get different types of solution, and concentration terms of solutions are therefore important because we need not write all the theory that this much is the amount of solute I have dissolved in this much amount of solvent. If we do that for all the type of solution, obviously the theory will become huge. So rather what scientists have done, they have defined concentration terms of solutions. With the first concentration term is percentage composition. Now what is this percentage composition? Percentage composition can further be described and divided into 3 parts. Let's say the question is supplying you weight of solute with respect to solution. That means percentage by weight is given, which is nothing but whatever percentage is given will be equal to weight of solute upon weight of solution into 100. Because ultimately, if you are calculating percentage, then what to do? Whatever marks you have got upon total marks. So who is total over here? Solution. So weight of solute upon weight of solution into 100. Rather, if volume is given, so volume percent will be volume of solute upon volume of solution. There is no problem of the unit. Whatever unit you put for solute, the same unit you take for solution. But if question is supplying you mass by volume percentage, then you should know the definition also and the unit also. Mass by volume percentage is defined as mass of solute in gram upon volume of solution in ml into 100. This is your mass by weight percentage definition. Please make note of the unit. It is gram of solute dissolved in 1 ml of solution. What is the weight in gram of solute dissolved in 1 ml of solution? So obviously you can learn these formula using the symbol which we have recently indicated, that for solute I will write 2 and for solution I will write solution only. For solvent I will rather write 1. Moving to the other concentration terms. The similar percentage for a dilute solution is also given in questions as parts per million, because when solute is very less with respect to solution, then very less is estimated in terms of parts per million or maybe parts per billion. So what is 1 million? 10 lakh. 10 lakh is 10 raised power 6. So use the same formula, mass by mass percent, mass by volume percent, or mass by volume. But again, the definition will have to be remembered by you for mass by volume. Mass by volume definition is mass of solute in gram upon volume of solution in ml into 10 raised to the power 6, because we are calculating parts per million. 1 million is 10 lakh. 10 lakh is 10 raised power 6. Moving to the next part. Now, next definition for concentration term is mole fraction. Now this is also quite easy, so memorizing and revising everything. So how you define mole fraction of solute? Sir, because of we are talking of solute, so number of moles of solute upon number of moles of solution. What is number of moles of solution? Solvent plus solute. Similarly, what will be mole fraction of solvent? Moles of solvent upon total moles. If you rather add mole fraction of solute and solvent, you will always find for a binary solution which is having only one solute and one solvent, so mole fraction of solute and solvent will definitely be equal to 1. Never forget this. Now, after moving forward to the other concentration term. Next concentration term is strength of solution. So what is strength of solution? Now, strength is weight of solute in gram upon volume of solution in liters. Now here we are taking weight of solute in gram upon volume of solution in liters, not ml. In percentage and in parts per million, the volume was in ml, but after strength, the volume of the solution is taken in liters. So in terms of symbol, it is weight of solute in gram upon volume of solution in liters. Its unit will definitely be gram per liter. So people make this mistake a lot of time, that they mistakenly take volume in ml. So for concentration terms like strength, volume of solution is in liters. And because we are talking of strength, so the big brother of strength, the most famous concentration term is capital M, which is nothing but molarity. So what does this molarity theoretically is defined as? It is not weight of solute, it is number of moles of solute upon volume of solution in liters, and molarity is very much asked in JEE. So this is a question. Let us practice this question. Can anybody give me answer to this problem? The definition which we have just studied. Let's solve it. Answer I need. Prince, perfect. And you will do it. And you will do it. I am with you. Yes, black mystery. It is temperature dependent. I'll be discussing about that once I'll discuss molality. First, let us apply. Yes, Prince Bhai, no talk, only study. Dubey ji, perfect. Now, let us, do we have answer? Answer, friends? Yeah. So I have volume of 3 molar NaOH. So molarity is given to be 3. Molar mass of NaOH is already given. Molar solute, NaOH is solute, so I'm marking it as 2. So molar mass is M2 is 40, which can be prepared from 84 gram of NaOH. So weight of solute is given out to be 84 gram. This is 40 grams. Okay, simple. We have to calculate volume, but we have to calculate volume in decimeter cube. What is 1 decimeter cube? 1 decimeter cube is nothing but 1 liter. This unit and unit conversions you should know. 1 decimeter cube is nothing but 1 liter. So applying the formula of molarity, we know molarity is equal to number of moles of solute upon volume of solution in liters. Number of moles of solute is weight of solute upon molar mass of solute into volume of solution in liters. Molarity is already given to us. How much? 3. Weight of solute is given out to be 84 upon molar mass of solute is 40 into volume. This volume of solution I need to find. Now, this is 410, okay, this can be cancelled by 3. So let me not do with 4 first. 3, 2 is 6, 3, 8 is 24. Now this is easy. 4, 7. Acha, this is 8.4 or what? 84 gram. So this is 7 by 40. So volume of solution becomes 0.7. Okay. So this is our answer. Okay. We have to represent answer in 10 raised power minus 1 format. So 0.7 becomes 7 into 10 raised power minus 1. So our answer will be 7. Yeah. Answer will be 7. See, this is how NTA plays. This was an easy question of molarity. This is a 2024 question. Easy question of molarity, but how NTA tricks us in such ways, playing with unit, playing with your mathematical sense, that answer is 0.7. So in 10 raised power minus 1, it will be 7. So I hope we are clear. I hope we are clear, guys. 7. Yeah, black mystery. Yeah, perfect. Moving to the next one. Next concentration term is molality. Molality is represented as small m. Definition of molality is number of moles of solute, but in the denominator this is not solution, this is solvent, but not volume, weight. So sir, now somebody was saying memorization. Now this is a power which you should use, that what is the definition of molality? It is number of moles of solute upon weight of solvent in kg. Rather, if you write number of moles of solute as weight of solute upon molar mass of solute, and in the question generally weight of solvent is given in grams, so in order to convert it into kg, we multiply it by 1000. What will be the unit? Unit will be moles per kg. So moles per kg. And one of the student was saying, sir, molarity is dependent on temperature. Why? Because all the concentration term which has volume factor in them, volume changes with temperature. Even if you go out in your town, you will definitely have a small nadi, small river. I mean, one river per district will definitely be there, whatever condition it may be. But at least you can observe that in the month of May, all the water is gone, and then in winters the water is definitely there. So volume of water is tremendously is dependent on temperature. As temperature increases, volume gets changed. Volume, as you increase temperature, volume will definitely increase. So all concentration term which have volume factor, they change with temperature. But molality per se essentially has no volume in its definition, and hence molality is considered as a better concentration term, because if you have labeled a solution in the month of winters, in the time of winters, even if summer comes, the molality is not going to change, although other concentration term like molarity will definitely change. So you again redo those stickers if you have pasted a sticker of molarity. So rather, what is a preferable concentration term? Molality. Why? Because molality is independent of change of temperature. I hope we are clear with it. Now, moving to some very specific problems where we have to relate these molality, molarity and various concentration terms. So all the conversions I'm not taking over here, but there are certain relationships which are very important for according to mains type of questions. For advanced, you should know all those relationships, but here we are specially working for the April attempt. So this relation for mains also you should learn. What is the relation? The relation is percentage of mass percent of solute, that is weight of solute with respect to weight of solution, it may be given. Density of the solution may be given. Now the density of solution is given in gram per ml most of the time. So if it is not given in gram per ml, then you cannot use this formula, else convert it into gram per ml and then use this formula. Then you have to relate with molar mass of solute M2 and molarity. So what is the relation? Molarity is equal to percentage into density into 10 upon molar mass of solute. We'll derive it over here, but I want you to learn these results because they are very important and will be saving your time like anything. So let us derive it. Sir, we know molarity is nothing but number of moles of solute upon volume of solution. Now, if this volume is taken in ml, then I have to multiply 1000 in the numerator. Now, volume of the solution can be written as mass equals volume into density. So, volume equals mass of solution upon density of solution, and density of the solution we have represented as small d, because weight will be in gram and volume we have recently converted in ml. So, this is definitely gram per ml. Now, if we know this formula, what else is given to us? That number of moles can also be written as weight of solute upon molar mass of solute into weight of solution we already have into 1000 into d. Now we have recently seen the definition of mass percent, which is weight of solute upon weight of solution into 100. So this yellow bubble is nothing but percentage, which we have seen, into there. This 1 0 is remaining, so 10 is still remaining over there. Upon, you have only molar mass of solute in the denominator, and this is nothing but molarity. So a very easy relationship, but rather learn this relationship to be time effective in your examination. Moving to the next important relationship, which says that you have to relate relationship between density of solution, molarity of solution, molality of solution, molar mass of solute. Now what? Obviously the relationship is already written. I want you to learn this relationship by heart, but let me derive this for you for the case of learning. But learn this result, my friends, please. So let us derive this. We definitely know molarity, we have already seen, as weight of solute in gram upon molar mass of solute into volume of solution. If we write volume of solution, then volume equal to mass upon density. So I can either write mass of solution and density will come over here, and because volume I've taken in ml, so this is 1000. Now this is what I have already done previously, so I have written that format over here. This is molarity that we already know. Now also we know that molarity can also be written as number of moles of solute upon okay, rather let me leave this much I know. Also, what do I know? Because I have to rate molality also. So molality is equal to number of moles of solute upon weight of solvent. If this is taken in grams, so I'll have 1000 over here. Now let me replace this N2 with this, because this is also N2. This is also N2. Weight of solute upon molar mass of solute is nothing but N2. So I can replace this in the relationship of molarity. So I can say, or molarity is equal to, instead of this pink bubble, I'm writing molality into weight of solvent into 1000. 1000 will come in the denominator. This I'm replacing N2 over here. Rest everything is as it is, which is density into 1000 upon weight of solution. Now weight of solution is nothing but weight of solute plus weight of solvent. Now this will be getting cancelled, but let us take in the left hand side. So this is W1 plus W2 upon W1 is nothing but this 1000 is definitely gone. So here I have molality upon molarity into, yes, this density is also remaining. Now this, it is taking a picture like this. So what this is 1 plus this is W2 by W1 whole into molality, and here I'm having density, and let me put molality also here because I am giving it a picture like this. So density, this density term we have obtained. Now we have to work on this LHS. Now we have to make it whole M molarity capital M whole into. So I have to work in this whole into. So I can say we are very much satisfied with this D. We are very much satisfied with this capital M whole into 1 upon molality. This I'm multiplying, so this part also I've got. Now this is W2 upon W1 into molality. Now this is the only part where we are just left with some work. This part. So for this part, let us elaborate molality again. So molality can be written as weight of solute upon molar mass of solute into weight of solvent into 1000. I guess you can clearly see this pink bubble. I need W2 upon W1 into this molality. So W2 upon W1 into this molality is nothing but M2 upon 1000. This is nothing but M2 upon 1000. But see, if you do such, I mean, this is not a difficult task, but obviously it is a time taking task, and time is money. So rather, that's why I'm saying you should learn these relationship. If you are doing question, you can obviously do these stuff. But if you are doing this stuff with this lot of, I mean, you, sometime even I will do this derivation, I can do this in 2 lines. But ultimately writing those 2 lines will also take time. So why investing that time when we know that such conclusions are very important? So rather learn them. Moving to the problem, the actual application of that relationship, a JEE Mains 2025 question. So let us practice this one. Can I get an answer from you? Give me an answer. Stucking in 150 in mocks. Sir, I am waiting for Laksh batch classes. Parnika, beta, even I am waiting for those classes. I am crossing my fingers. See, meeting every day is out of this world, beta. See, today, like in such day, we are on so much. You are on so much of pressure. Why? Okay, I'll take this 8 and 9 hours of class. I can do my practice work tomorrow, day after. You again have your classes for mathematics, the 8 and 9 hours of lecture. So it is very difficult for you. So working daily is like a blessing in disguise, that you just eat 1 chapati a day. In 365 days, you'll eat 365 chapatis. If you are asked to eat 365 pizza on a single day, it will be the blessing will become a punishment for you. So similarly, I'm eagerly waiting for those batches to start. So thank you, Parnika, for joining us, for letting us create an history, create a long visioned history with all you people. I need answer for this. I hope we have already seen the relationship. So we know density is equal to capital M whole into 1 upon molality plus molar mass of solute upon 1000. Density of the solution is given to be 1.25. It is in gram per ml only. Molarity is 3. Molality we have to find. Solute is NaCl. So this is NaCl is 23 and 35.5. So this is rather 0.58, 58.5 upon 1000. Now into divide is your job, and if you do some approximation also, you will easily reach somewhere around 3, less than 3. So which option is less than 3? Slightly less than 3, obviously option 2. once you are given options, you do not have to do the complete introduct also. Approximation will definitely help you a great. So see how much time we have taken to do such a good question. Moving to the next. Aha, it's done. Mole concept, these are the topics which you should know for atomic structure, for mole concept, that is basic concepts of chemistry. Yes, moving to redox reactions. Now redox, we already know what is a redox reaction, sir. When simultaneous oxidation and reduction takes place. What is oxidation? Increase of oxidation state. What is reduction? Decrease of oxidation state. Sir, will you be covering p block? Yes beta. Actually, see, P block, S block, hydrogen is removed from NCRT also, is removed from JEE Main's syllabus also. But NTA plays with us. How they play with us? Whatever concepts of block chemistry like P block, S block, whatever concepts is related to chemical bonding and periodic table, they still ask those topics. So what I have done for you is I have specially created these lecture notes that will be helping you. Don't read periodicity if you have less amount of time from the complete one shot. Don't read chemical bonding, but revise these notes. Chemical bonding and periodic table, I'll be covering those P block logics also. I am the guy. Beta, limiting reagent, the stoichiometry thing I was doing na, the limiting reagent is nothing but that only. The problem which we have done in percentage composition, you do the stoichiometry. 1 mole of this will require 1 mole of this. Therefore, see if reactants are sufficient for each other or not. If not, then product is always produced in accordance with limiting reagent. So intentionally, I have not included those questions because I have to cover everything. So I've taken the most probable things first, and limiting reagent problems, yes, the logic has to be known. So, but the logic I have already covered in the theory section of stoichiometry. So some adjustment in the theory we have to do to be time efficient. Okay, I hope we are clear. I'm the guy. Now, my Jan shift had like 3 questions from P block, sir. That's what I'm saying, beta. Arya, that is what I'm saying. That chemical bonding periodicity, I will be discussing in that much of detail, where I'll be covering those P block important logics. Also, I'm the guy is saying, sir, you left. So obviously that some portions I'll be covering in theory, but the extrapolation of those theory can obviously be dealt in questions. So I hope we are clear. Yeah. No, beta, double titration, iodometric titration. If you go to my redox one shots, we have done it properly, and we have many questions in the one shots also, in the practice sheets attached with it also. But if you say for I have those redox law of equivalence questions here, but as per if you ask me double titration using phenolphthalein and methyl orange, the iodometric titration where you use hypo, those questions are not as such valid for JEE Mains. Yes, some of the questions have been asked, and therefore I'm saying they are already there in the redox one shot, but I have not taken them over here. Reason being, they are, less probable, and they are more inclined for an advanced type of paper. So ultimately we have to focus on those area which has high frequency of coming for your April attempt. I hope we are clear. Now, moving to the first type of problem for redox reactions. So ultimately, for initially you should know what is a redox reaction. So the question says, which of the following can't function as an oxidizing agent? So as I said, in redox, oxidation and reduction takes place simultaneously. Oxidation means increase of oxidation state. Reduction means decrease of oxidation state. What is an oxidizing agent, which is also known as oxidant? Oxidizing agent oxidizes you. Therefore, if I'm an oxidizing agent, so I'll oxidize you. Therefore, I will reduce myself. So if I'm reducing myself, so my oxidation state will decrease. So whose oxidation state can decrease? Because you are acting as an oxidizing agent, so you'll oxidize other and you will reduce yourself. So reduce itself. And what does reduction mean? Reduction mean decrease of oxidation number or oxidation state. But sir, here only now we have to know the inorganic knowledge of it. No, go to oxidation state. Nitrogen is an oxidation state of -3 because it is a ion, so its oxidation state will be the net charge. For sulfur, we do the algebraic sum. For sulfur, I do not know its oxidation state, so let's say it is X. Oxygen always compound in -2 oxidation state, so there are 4 oxygens, so -8. What is the overall or charge? -2. So for sulfur, what is the oxidation state? +6. Similarly, for bromine, X -6 becomes -1, so this is +5. For manganese, X -8 becomes -1, so this is +7. Now, if I want to decrease my oxidation state, then obviously manganese in its maximum oxidation state, so plus can attract minus, so this can definitely undergo reduction. Plus can definitely undergo reduction. Plus can obviously undergo reduction. Nitrogen, which is already in -3 oxidation state, can't take more electrons because it do not have any empty orbital. So this guy cannot take any electrons, therefore it can only give electron, therefore it can only oxidize itself. Why? Because when your oxidation state will increase, when you will give electrons, because it is having maximum number of electrons, so it can only give, so it can't get it can't reduce itself, so it cannot act as an oxidizing agent, and this becomes our odd one out question. I hope we are clear with this. So yeah, perfect. So such questions are very, very probable for your JEE paper. Now moving, these are all JEE questions only. Now next question says, which of the following reaction are disproportionation reaction? So redox, with what is a redox reaction, we have understood and done a question also. Now types of redox reaction. So the very famous type of redox reaction is a disproportionation redox reaction. Now what is a disproportionation redox reaction? Disproportionation mean when the same element get oxidized also and reduced also. So let us check. This is copper in +1 state. So +1 to +2, that means it is getting oxidized. +1 to 0, that means it is getting reduced. So yes, this is a disproportionation reaction. So 1 is a disproportionation reaction. Now second one, manganese, X -8 equals -2, that means this is +6. X -8 becomes this, that means this is +7, so this is oxidation. This is simply oxygen is -2, so this is +4, so this is nothing but reduction. So yes, this is also increase also, decrease also, so this is also disproportionation. Next, here this is KMnO4, so manganese is again in +7 state. Now gives K2MnO4, this is +6. This is MnO2, this is +4. So from +7 to +6, this is also reduction. This is also reduction, so it is not getting an increase. This is just a reduction reaction, so this is not a redox reaction. So 3 is not a redox reaction, this is gone. Now this, what about fourth one? From +7, okay, and it is +2. It is becoming +4. So from +7 to +4, this is a reduction. From +2 to +4, this is oxidation. But disproportionation is the same has to get oxidized also and reduce also. So the reverse reaction will be a disproportionation redox reaction because it is given in this fashion. So this becomes the opposite of disproportionation, not the disproportionation rather. So 4 is also not a disproportionation reaction. So what are the disproportionation reactions? Option 1 will be your answer. I hope we are clear with this. See, okay. The answer is saying 1. Jealous. Let me check. Answer is C. 1, 2, and 4. Which of the following reaction are disproportionation reactions? But ultimately, this is the opposite reaction will be a disproportionation reaction. So I am having 1 and 2 in option. Yes, on option 1 I am having. This is saying 1, 2, and 4. The opposite will definitely be a disproportionation reaction. But for this reaction, you can't say it is a disproportionation. So this is an answer correction. The answer should be option number 1. I hope we are clear. The opposite is called comproportionation. So this is not disproportionation. I hope we are clear with this. Sir, some people find a lot of problem in calculating the oxidation state. So how to calculate these oxidation state? There are methods. So let me also revive. I was actually using those methods only, but let me list those methods for you also, because they are good. Actually, oxidation state is nothing but whenever an atom can be whenever an atom is forming a compound, then whether it is forming a covalent bond, it will have some partial electron transfer, and because of that partial electron transfer, it will create a hypothetical charge. The overall molecule may be neutral, but what is the hypothetical charge on that particular atom to form a molecule is known as its sthiti, is known as its situation, is known as its oxidation state. So this oxidation state can very well be defined using those mathematical calculations, but the best possible way to decide the oxidation state of any species is through its structure. Because let's say this is water. Now water is formed of oxygen with 2 hydrogens. Now what is the overall charge on the molecule? Sir, it is neutral, but there will be some partial charge, because when oxygen and hydrogen has made a bond, how many electrons they have made? They have shared 1 1, so contribution will be 1 1. The atom which is more electronegative will withdraw the electron and attains a partial charge, so this becomes -1 and this becomes +1. In the similar fashion, the oxygen is making another bond, so contribution will again be 1 1. Oxygen being more electronegative will attain a partial charge of -1 and force a +1 charge on hydrogen. So overall oxidation state of hydrogen will be +1. Overall oxidation state of this hydrogen will also be +1. Now overall oxidation state of oxygen will be -1 -1. That means it will become -2. I hope we are clear with this. Now what about the second option, sir? This one, sir. Sir, contribution 1 1, oxygen is more electronegative, so -1. Contribution 1 1, oxygen is more electronegative, so -1. When bond is formed between similar atom, what is the contribution? Because sir, both have same electronegativity, so no one will withdraw more electron towards themselves, so contribution will be 0 0 because of this bond. So what is the overall status of oxygen? Sir, this oxygen has a partial charge of -1. This one also has a partial charge of -1. So whenever oxygen is in -2 oxidation state as a compound, it is termed as an oxide. But whenever oxygen attains a oxidation state of -1, it is termed as a peroxide. So this is your peroxide. Now similarly, if somebody is asking you to calculate oxidation state of sulfur, now we already know, so let us focus only on the sulfur. From top oxygen, sulfur will attain +2 charge. From bottom oxygen, it will attain +2. Why +2? Because 2 bonds are formed, so 2 bond contribution will be 2 2. Oxygen is more electronegative, so -2. Sulfur will be +2. So from left and right also, sulfur will attain +1 and +1. So overall oxidation state of sulfur will be +6. I hope we are clear with this. Now moving to this, moving to this. Now this is perchlorate ion. The name also, somebody was saying it's a p block. Now I'm including those p block logics like this. So what is a perchlorate ion? So this is whenever you have HClO4, HClO4 is perchloric acid, and whenever perchloric acid gives H plus, the ion formed is perchlorate ion. What is perchlorate ion? H plus gone, so this is ClO4 minus. The shape of ClO4 minus, what is the oxidation state of chlorine? From oxygen +2, here also +2, here also +2, because here you only have 1 bond, so it is +1. So oxidation state of chlorine will be +7. Although you can do this with the algebraic formula also, but this is the best possible way to calculate oxidation state, where good questions can also be decoded. Now let us calculate for this nitrite ion. Let us calculate oxidation state on nitrogen. Now because it is forming 2 bond, oxygen is more electronegative, so this will attain -2, force +2 in nitrogen. Here also force +1 in nitrogen, so net oxidation state on nitrogen will be rather +3. I hope we are clear. I hope we are clear. I hope we are clear. Now Moving to another examples like carbon suboxide. Now, what is carbon suboxide? It is C3O2, a very important block chemistry logic also, that you should know the name of some oxides along with its molecular formula, and let us try to find the oxidation state of carbon. Now, if we just see this carbon, it is having 2 oxygen will be -2, forcing +2 over here. This bond is carbon carbon, so contribution will be 0. So for this carbon, overall oxidation state is +2. This carbon is getting 0 from here also and here also, because carbon making bond with carbon, no one is more electronegative, so no one is taking or giving electron. So because I'm not taking any electron, because I'm not neither electronegative nor electropositive, so center of mass of the electron cloud will be in between only. So partial electron transfer will not take place, so a contribution will be 0 from both the sides, so its oxidation state will be 0. Similarly, for this carbon, it will again be +2. So out of these 3 carbon, 2 carbons are having +2 oxidation state and 1 carbon is having 0 oxidation state. If you rather do just that algebraic sum, like if I'm having the C3O2, if we just do the algebraic sum, so we'll say that 3x minus 4 equals 0. So what will be the oxidation state of carbon? Sir, it will be 4/3. Actually, you will say, sir, how come fractional charge is coming? Fractional charge is not coming. That is the average oxidation state. You speak for yourself. You judge by yourself. In a family, 3 members are there. 2 members are attaining +2+2. 1 member is not bringing any money. Let's say this is bringing 2 lakh, this is bringing 2 lakh, and this guy is bringing no money in the family. So if someone asks how much your 3 sons earn, the parent will say the complete amount divided by number of the sons. So, but what is the actual each individual oxidation state, you can only know once you write the structure of those compounds and do the oxidation number analysis by this method. Now, similarly, now this is just block chemistry. One of the students was asking what about block chemistry. Now I have included those block chemistry logic and coupled it with redox also. Like for example, you should know what is a Carrot's acid, although it is a block chemistry logic. What is Carrot's acid? H2SO5. What is H2SO5? Obviously, if you draw H2SO4, that you know how to draw, include a peroxide linkage. So sir, these structures we should know. Yes. So this is the block chemistry logic that you should know, and I'm including all those important block chemistry logic in each and every chapters of like chemical bonding, periodic table, and redox also. So this is Carrot's acid, and obviously if someone asks you what is the oxidation state of sulfur, so this is clearly +6, but here I have 2 oxygen in -1 oxidation state and 3 oxygens in -2 oxidation state. I hope we are clear. That means it has oxide also and peroxide also. Now, what is this? This is tetrathionic acid. What is tetrathionic acid? H2S2O6. Very important. And if it gives H plus, it will give 2H plus. What is the ion it will form? Tetrathionate ion. Block chemistry logic, very famous. Now, let us draw the structure. So the structure is already drawn, and you should remember this, that it has sulfur linkages. Now let us find oxidation state of each sulfur. So obviously when sulfur has bonded with themselves, there will be no partial electron transfer. So oxidation state of this sulfur will also be 0. This sulfur will also be 0. This sulfur will attain oxidation state of +5, and this will also attain oxidation state of +5. So overall charge is +10. So fractional average it is 10/4, but individually 2 are in +5 oxidation state and 2 are in 0 oxidation state. The next is Marshall's acid. What is Marshall's acid? This is H2S2O8. This is Carrot's acid, H2SO5. This is Marshall's acid. Marshall's acid is also known as peroxodisulfuric acid because this also has this peroxide linkage. If someone asks you what is the oxidation state of sulfur, that is also quite visible to us, evident to us. Now, these are some block chemistry logics which you should know. So revise these notes as your final lecture notes. Not anywhere, any other place as else. Like do not watch that complete one shots also, obviously, because we are falling short of time. Now, very famous compound CrO5. Now this CrO5 is a beautiful butterfly structure. This is the titli, I mean this is the wings and this is the soon of the titli. So can you tell what is the oxidation state? Yes sir, definitely. Chromium is having 2 from upside, so +2, +1, +1, +1, +1. So it will have a oxidation state of, add all the pluses, you will get +6. Why? Because one oxygen is in -2 oxidation state, while the 4 oxygens are not oxide, they are peroxide. I hope we are clear with this. So these block chemistry logics are very, very, very important for good type of question in even in JEE Mains. Moving to some two more block chemistry logics you should know. Hypo, very important. What is a hypo solution? Hypo is nothing but Na2H2 Na2S2O3. Na2S2O3. What is the active ion? S2O3 2 minus. What is the structure? This is the structure, and therefore you should know that the one minus is on sulfur and the other minus is on oxygen. Both the minus is not in oxygen because this is its structure from its property and a block chemistry logic also. So if someone is asking you what are the actual oxidation state of both the sulfur, then from here contribution will be 0, here contribution will be 1 1, but sodium is electropositive, so it will attain +1 and force -1 on this sulfur. So this sulfur will have a overall oxidation state of -1. What about this one? From here it has got 0, but these 5 Y bond will give an oxidation state of +5 to this sulfur. So this guy is getting +5, this sulfur is getting -1. So overall charge on sulfur will be +4. So +4 by 2 will be 2. Although if you apply the algebraic sum formula over here, you will not get a fractional number, but no sulfur is present in +2 oxidation state C. But with the formula, you will say that the oxidation state of sulfur is +2. The average oxidation state on sulfurs are +2. Individually, one is in +5 state, another one is -1 oxidation state. A very beautiful example, a very beautiful block chemistry logic as well. Other example is tribromo octa oxide. Now, tribromo as in 3 bromine, octa oxide as in 8 oxygen atoms. The beautiful structure, how can you draw it? You know bromine has 7 electrons, so make all those electrons, include a bromine in between. The end structures will be symmetrical and these bromines will be having 2 oxygens. That means for this bromine, for the central bromine, this is 1, 2, 3, 4, 5, 6. I hope the structure is clear to you. Now, can you tell me the oxidation state on each bromine? Let us find. Sir, this bromine will have 2, 2, 2. That means +6. Why? Because this is bromine-bromine bond will have no contribution, so 0, 0. What about this bromine? It will have oxidation state of +4 and similarly it will have an oxidation state of +6. I hope we are clear with this. Moving to the other logic of redox reaction, which is also pertaining to mole concept, which is the concentration term. One of the very famous concentration term which JEE Mains also asks, but those questions are considered as good questions and students fear it. It is normality. Normality is nothing but a bigger brother of molarity. Because what is its definition? Normality is, instead of number of moles of solute which you have in the formula or in the definition of molarity, normality is number of gram equivalent of solute upon volume of solution in liters. Now, some people will say, sir, what is this number of gram equivalent? So, number of gram equivalent is defined as weight of solute upon equivalent weight of solute. Again, there's a problem, sir. What is equivalent weight? Equivalent weight of solute is defined as molecular weight of the solute, which we know upon valency factor. So ultimately, if you just take this valency factor aside and put all these formula in the definition of normality, you will get normality is nothing but weight of solute upon molar mass of solute into weight of solution in liter into valency factor. And obviously it is quite visible to each and every one of us that this normality is nothing but molarity into valency factor. Now, sir, tell me what is this valency factor. So let us now decode this valency factor. So valency factor is defined for each specific type of compounds you have. Like for example, if you have an acid, so for an acid, valency factor is defined as number of replaceable H plus ion. You may have whatever number of H plus ion, but if you are doing a reaction, and in that particular reaction, what is the number of H plus ion you are furnishing, that will be your valency factor. Some acids, when they are reacting, sometimes because of the restricted condition of the specific reaction, they can't release all the H pluses that they have. So whatever the H plus you are replacing in a particular case, that will be your valency factor. Speaking in general, so HCl when present always gives 1 H plus, so its valency factor will definitely be 1. H2SO4 valency factor will be 2. Phosphoric acid valency factor will be 3. Phosphoric acid is technically also known as orthophosphoric acid. H3PO3 is actually phosphorus acid, also known as orthophosphorus acid, whose valency factor is 2. Why? Because I hope I'll be having the structures also. Yes. Orthophosphoric acid has valency factor 3 because it is having 3 replaceable H plus, because every hydrogen is connected with electronegative oxygen. So electronegative oxygen can extract electron of hydrogen and kick it out in form of H plus. But if that hydrogen is not attached with an electronegative oxygen, like in case of orthophosphorus acid with formula H3PO3. So if you draw from structure of H3PO3, you will find one hydrogen is not attached with oxygen, one is attached with phosphorus. So because it is attached with phosphorus, so this hydrogen becomes a reducing hydrogen. It can be given to any species as nascent H. So it can act as a reducing agent, but not an acidic. This hydrogen is not acidic. Yes, these two hydrogens are acidic. So its valency factor therefore will be, okay, I'm sorry, it is replaced. Here acidic H should be 2. So valency factor will be 2 and one hydrogen is reducing. Similarly, the very famous example. So now again, I'm again and again telling you, but I'll not be repeating things all the time. Somebody asks, sir, block chemistry, sir, S block, P block, important or not? See, P block. So I am taking all the important observations of block chemistry also over and where they are necessary. So obviously we will not study S block and P block, they are removed from JEE syllabus, but because NTA has a habit of asking them, but asking those details of block chemistry which are used in the topic which are already there in the syllabus of NCERT. So if you are supposed to give valency factor, then you should know such structures. Now what is orthoboric acid? Sir, H3BO3. So by the formula it is having 3 hydrogens, so it should give 3H plus. Sir, here hydrogens are also connected with electrons, so it should give 3H plus. Why it is not giving 3H plus? Because once orthoboric acid, which is HbOH whole thrice, it goes out for reaction, boron dominates the reaction because boron has vacant orbital. Its octet is not complete, and because second period elements are highly electronegative because they are small also, so they will try to complete its octet, and whatever species who tries to gain electron is termed as an acid, is the definition of Lewis acid. So what is a Lewis acid? Which has a capacity of accepting electron. So why will it accept electron of hydrogen? Because the central atom is hungry over here. So when orthoboric acid goes to water, it demands lone pair of electrons from oxygen of water, and obviously on its demand oxygen give those electrons. As oxygen give the electron, it will snatch away electron of its hydrogen, so H plus is going to be released. But that one H plus also is not released by boric acid unit. Boric acid is forcing water molecule to release H plus and forming BOH4 minus and releasing 1 H plus. So actually in water, if you put boric acid, what is the number of replaceable H plus? 1. So for orthoboric acid, although it has 3 hydrogens, but its valency factor is 1. A very beautiful logic. Moving to The valency factor calculation for bases. For bases, it is quite easy because thanks to Mother Nature, there is no such technical conceptual observations. I would rather not say exceptions. They are explanations, logical conceptual explanations. For bases, no such explanations exist, and therefore for bases, valency factor is simply number of replaceable OH minus or whatever OH minus and bases have, they simply give them. So NaOH gives 1 OH, so valency factor becomes 1. Cesium hydroxide 1, calcium hydroxide 2, aluminum hydroxide 3. So thanks to Mother Nature, for bases, valency factor is their OH present in their molecular formula. Now, what is the same what we use in Faraday law? Yes, beta. Yes, Mr. Mystery. Now, how to calculate sir valency factor for a salt? For a normal salt, valency factor is actually the total charge. Sir, salt is neutral. Then how come total charge? Array, total charge of either cation or either anion, because ultimately it will be neutral, but you can calculate total charge of either cation or either anion. Do not add them. Some people do, sir, they use a charge. So plus also minus also, both are charges. Plus will be neutralized by minus. So whatever charge you have on either ion, either calculate for cation or either calculate for anion. So valency factor, let us calculate that valency factor. So for NaCl, it will be 1 because cation also has total charge plus 1, anion also. For CaCl2, 2. For AlCl3, 3. Now, here ions are stoichiometrically more. So, aluminium having charge of plus 3. But how many aluminium we have? 2. So, 2 into 3 is 6. You can do for sulfate also. Sulfate has charge of minus 2. But you have 3 sulfates. So, 3 into 2 is 6. So, minus 6 plus 6. So, ultimately, what is the charge? 6. I hope we are clear. Yeah, black mystery. Perfect. So this is the valency factor for a normal salt. Now why I'm saying normal salt? Because sometimes when you take salt in a solution, they do not remain in their own oxidation state. Rather, they change their oxidation state. So that means if you change your oxidation state, then you are either getting oxidized or reduced. So when a salt is subjected to a redox reaction, then the valency factor is not its charge. Then the valency factor is number of electrons transacted during that particular oxidation or reduction, half of that particular ion. So for salt undergoing electron exchange during a redox reaction, for those salts, valency factor is not their charge. Valency factor is total number of electron transferred, but per unit. So whatever specific ion is undergoing the electronic transaction, take 1 mole of that ion, 1 unit of that ion, and then calculate total charge transfer. Like for example, the very famous active ion which is also an oxidizing agent is potassium dichromate. Now potassium dichromate formula is K2Cr2O7. Who is the active ion? Sir, alkali and alkaline earth metal never changes their oxidation state. So potassium K plus is a spectator ion, not involved in redox reaction and electron transactions. So active ion becomes Cr2O7 2 minus. So for this Cr2O7 2 minus, what is the charge transfer? So ultimately, what you have to do is what we have already seen and learned. Can we calculate oxidation state of chromium? Yes, sir. 2x minus 14 equals minus 2. That means this is plus 6. For this chromium, it is simply plus 3. So if I was in, go to the number line, from plus 6, you are coming back to plus 3. So how many electrons you are eating? You are eating 3 electrons. 1 electron, so plus 6 plus 5 plus 4 plus 3. So how much electron you ate? 3 electrons. But this one family is having how many chromium who are desperately in need of eating 3 electrons? So there are 2 chromium in this one unit. So into 2. So one family, one ion will eat how many electrons? Because this one ion is having 2 members who will be eating 3 electrons. So ultimately this one family needs 6 electrons. I hope. What does this one family mean? You have to calculate valency factor by calculating 1 unit of the ion, and this unit, whatever oxidation state you have, multiply with number of species in that particular oxidation state it is having. So valency factor of Cr2O7 will become 6. I hope we are clear with this. Now, yeah, not 3. Black mystery. I hope we are clear. Yeah. Now, sir, why you are teaching this valency factor, law of equivalence? Actually, it helps for good type of questions. What happens is, suppose you are doing stoichiometry, but theoretically, as per P block, you do not know the complete reaction, or even if you know the reaction, it is a redox reaction, and balancing a redox reaction, which we'll do in the later slides, but balancing of redox reaction is a task in itself. So sir, when balancing of redox becomes a task, then how to do it easily? Once you are, if in the specific question you are only supposed to calculate the stoichiometry, and for stoichiometry you are not always supposed to balance the reaction when once you know law of equivalence. So what is law of equivalence? Law of equivalence says that normally if you have a balanced reaction, then how moles of a balanced reactions are equated using moles of a reaction. What is moles of a reaction? It is a relationship between moles of a reaction. What is it, the relationship? Let's say this is the reaction. So moles of A reacted upon stoichiometric coefficient of A, that is small a. These moles will be equal to moles of B reacted upon stoichiometric coefficient of B. This will also be equal to moles of C produced upon stoichiometric coefficient of C. This will also be equal to moles of D produced upon stoichiometric coefficient of D. But for equating moles of reaction, you should know the complete balanced reaction. What if from a P block chemistry logic you don't even know the complete reaction, you just know that half? So for those cases you do not have to balance the complete reaction. Rather, for any chemical reaction, whether it is balanced or not balanced, instead of writing moles of reaction, how you can equate them? You can't equate moles now, but you can equate their number of gram equivalent. Why? Because whatever is the stoichiometry is because of the electronic transaction, and that electronic transaction you are taking in itself. What considers those electron transaction in itself, in its definition? Sir, number of gram equivalent, because number of gram equivalent has that valency factor contribution in itself. So number of moles can't be equal. They can or they cannot be equal, depends on the reaction, but one thing is always equal, which is number of gram equivalent. So whenever you have a reaction, you even do not know A is reacting with B, maybe it will be reacting with C and D as well. Whatever it is, let it be. It is producing C, D, whatever product more it is producing, let it be. You can always say, you have no need to balance the complete reaction. You can always say that number of gram equivalent of A that has been reacted will be equal to number of gram equivalent of B, and it will also be equal to number of gram equivalent of this produced and number of gram equivalent of this produced. So you do not have to balance the reaction. You can easily equate the number of gram equivalent. But while you are equating their number of gram equivalent, what you should know, how to calculate the valency factor for those particular species. Now, sir, if we are equating the number of gram equivalent, then we should let us revise what are the different formulas to calculate number of gram equivalent. We have already seen in the definition of normality, but let me list, because students forget. Number of gram equivalent can be written as weight upon equivalent weight, that we have written. It can also be written as moles into valency factor. It can also be written as, because this is the definition of normality, so normality into volume of solution in liters. It can also be written as, because we know normality is nothing but molarity into valency factor, so it can also be written as molarity into valency factor into volume of solution in liters. So sir, which formula we should use for equating number of gram equivalent? Let's say you are in the question, you are supplied with number of gram equivalent of one species, and you are asked something about the another species. So make number of gram equivalent equal for both of them. Use whatever formula is given, and use whatever formula what you have to calculate in the product. So these four formulas can help you to ultimately equate number of gram equivalent and get the desired answer. I hope we are clear with this. Now, let me put all that theory in some useful and interesting applications also. So sometimes in questions you are directly asked how to calculate equivalent weight. Sir, equivalent weight we know, it is molecular weight upon valency factor, but let us practically see what are those valency factors. Now, so equivalent weight we know, it is molecular weight upon valency factor. Now, valency factor for some redox participating species, again a block chemistry logic. So this is all inorganic use in physical side of chemistry. One student was saying, sir, statement based questions are always coupled. So these are the coupled topics which will be definitely helping you for your good questions of JEE Mains. Easy questions you can obviously do by just putting those formulas. Now, how to calculate a valency factor, sir? For example, I have KMnO4. KMnO4 is potassium permanganate. Now, like K2Cr2O7, potassium permanganate is also a strong oxidizing agent. Oxidizes other, reduces itself. But it reduces itself to what species depends on the medium. What is the active ion of KMnO4? Sir, it is MnO4 minus, known as the permanganate ion. In acidic medium, permanganate ion changes to Mn plus 2. In neutral or weakly basic medium, it changes to MnO2. And in strongly basic medium, when pH exceeds more than 9, it transforms into manganate ion having formula MnO4 2 minus. Obviously, if in acidic medium it is acting as an oxidizing agent, so it will oxidize as a reduce itself, but reduces to form this, therefore its valency factor will be going from +7 to +2, so its valency factor will be 5. So in such cases, what will be the equivalent weight of KMnO4? Molecular weight upon 5. In neutral medium, it will be molecular weight upon 3, because going from +7 to +4, so transaction is 3. And in strongly basic medium, it is going from +7 to +6, so valency factor will be 1. So its equivalent weight will be equal to molecular weight upon 1 in strongly basic medium. Now, so these facts we should know. Yes, these are the block chemistry logics which you should know for your physical chemistry level of good questions. Now, learn them by heart. Now, yeah, perfect mystery. Learn them by heart. Now, another example, ferrous oxalate. If someone is asking you calculate molecular equivalent weight of ferrous oxalate, how to do it? Or maybe if you're doing law of equivalence with ferrous oxalate, so what will be its valency factor? Now, actually, ferrous oxalate reacts how is a knowledge, inorganic knowledge. Ferrous oxalate quickly changes itself to ferric ion, and the oxalate ion, which is C2O4 2 minus, it changes itself to CO2, because the complete molecule is a strong reducing agent. Sir, we should know that. Yes, it is an NCRT and it is a block chemistry knowledge. Ferrous becomes ferric, oxalate ion becomes CO2. So the complete molecule, both the cation and anion, behave as a reducing agent. So they will reduce others and they will oxidize themselves. Iron goes from +2 to +3, so valency factor is 1. It is getting oxidized. C2O4 2 minus. What is oxidation state of carbon in C2O4 2 minus? Sir, I do not know. So let's say this is x. So 2x minus 8 equals 0. So this is 8 by 2. Okay. 2x minus 8. Oh no, not 0, na? I'm sorry. Because if it is +2, so that will be -2. So +6, so carbon is +3. And in CO2, carbon is +4. So what is the transfer? 3 to 4 is 1. But what 1 unit of C2O2 minus is having how many carbon? 2. So into 2. So here from iron, there was a factor of 1. But it was getting oxidized only. And +3 to +4 is also oxidation. How much electron? How much electron it is giving? 2. So this is also giving, this is also giving. So how much electron you are giving? Because you are giving from this side also, this side also. So as a molecule, as a family, when one molecule of this will be coming, it will be giving how many electrons in total? Because total transaction you have to take, because we both are giving, so you have to add them. So 2 plus 1 becomes 3. So valency factor will be 3. So what will be its equivalent weight? Molar mass upon 3. Perfect. Sir, explain again. Okay. Tarun, this one. This ferrous oxalate. Okay, I'm going again. The block chemistry logic sometimes you should know. So I am discussing a property of ferrous oxalate. Ferrous oxalate is a strong reducing agent. Reducing agent means reductant. Reductant as in reducing agent reduces other, therefore it will oxidize itself. You should know ferrous gets oxidized to ferric, oxalate gets oxidized to CO2. Because this is also oxidation, that means it will give electron. For oxalate also it is oxidation, that means that will also give electron. So one molecule of ferrous oxalate in total will give how many electrons? 2 plus 1, 3. So valency factor for ferrous oxalate will be 3. I hope we are clear. Tarun. Now, valency factor is 3. That means for ferrous oxalate, equivalent weight will be molecular mass upon 3. Now, what about hypo, sir? We have seen the formula. What is hypo, sir? Na2S2O3. Now, a very beautiful property about hypo is hypo also takes part in a redox reaction. How? It also do electron transactions, but how it is doing electron transactions again depends upon the medium, just like KMnO4. Now, if saying for acidic medium, S2O32 minus changes to S4O62 minus, it becomes a dimer. And in basic medium, it rather changes to sulfate ion. So let us calculate the valency factor now. Sir, we definitely know over here, because this is ultimate electron transfer, overall electron transfer we'll calculate, so we need not worry about the actual oxidation state. So we obviously know that one was in +5, one was in -1. So overall oxidation state will be +2. Yes, I know no sulfur is in +2 oxidation state, but for overall transfer we can do that approximation because average transaction will be taking place. So from +2 it is going to, this is 4x minus 6 2 ja 12 equals -2. So 4x equals 10. So x equals 2.5. So this is 2.5. So from 2 to 2.5, how much transaction is taking place? 0.5. But it is having 2. So this is 2. So what is valency factor? 1. So if hypo is getting oxidized from +2, that means hypo, that means Na2S2O3 is also acting as a reducing agent, reduces other and oxidizing itself. But oxidizes in form of this tetrathionate ion, this dimer of this thionate ion, this hypo solution. The valency factor becomes 1 in acidic medium, but in basic medium it converts itself to sulfate ion, where oxidation state of sulfur is +6. So from +2 to +6, there is a transaction of 4 electrons. And how many sulfur you are having over here? 2. So here valency factor will be 8. So equivalent weight of the same species getting changed once it is doing the same action. It is acting as a reducing agent. But in reducing agent, that means it is reducing other, oxidizing itself, but still, although it is getting oxidized, but in acidic medium, it is oxidized as tetrathionate ion. In basic medium, it is oxidized as sulfate ion. Sir, shall we learn this result? Yes, beta. This is the block chemistry logic that you should definitely learn. Sir, ek din mein to nahi hoga. That's why I'm saying take these notes and revise them as your lecture notes. If you are writing by your hand, it is good. But ultimately, because I'm trying to complete all those theory also, which already I have done in the one shots. But obviously, I can feel that you cannot watch the 3, 4, 5 hour one shot. So that's why we are coming up with this live sessions. I hope we are clear now. Their calculation of valency factor also becomes important for such type whenever you have intramolecular redox reaction. Like for example, you have ammonium nitride. Now this is also a very famous block chemistry logic, because ammonium nitride salt, whenever decomposed, produces nitrogen gas. So it is also a method to prepare nitrogen gas. So a very important reaction. Now, if we check ammonium ion, which is nothing but nitrogen having 4 hydrogens and a positive charge. So let us calculate oxidation state of this nitrogen. Sir, it is having 4 bonds, so plus nitrogen is more electronegative, so -1 from each side, and because it is already having +1 charge, so -4 plus 1 becomes -3. So in ammonium ion cation, nitrogen is in -3 oxidation state. Okay, sir. What about NO2 minus? NO2 minus, let us again do separately. I guess we have already done it, but let me do it again for you. That this is x minus 4 equals -1. That means this nitrogen in +3 oxidation state, and both the nitrogens are changing to nitrogen gas, which is in 0 oxidation state. What does this mean, sir? This means, sir, from -3 to 0, this is oxidation half. from +3 to 0, this is reduction half. But this is not a redox reaction because this nitrogen belongs to cation. This nitrogen belongs to anion. This is a redox reaction, oxidation and reduction both of different species. But sir, both the species are present in the same molecule. So therefore some people, some theory also says that this is a redox. But what type of redox? Intramolecular redox, when redox is taking place within the molecule. What will be the valency factor? Sir, we will add? No. We have to add the electrons per transaction. Per transaction as in if we are giving, calculate total electron that you are giving. Because if you are giving 10, somebody will be taking 10. So it is giving 3 and it is taking 3. So shall we add over here? No sir, because giving, taking, whatever packet given, taken, that is the valency factor. So 3 given, 3 taken, so valency factor is 3. So for such cases you don't add. Here we were adding because it was giving 2, it was giving 1. So how much given in total? What is the total packet given? 3 rupees. Here 3 rupee given, 3 rupee taken. Ultimately transaction is of 3 rupees. So valency factor will be 3. People misrepresent it and write it as 6. I hope I'm making sense over here, because valency factor is electron transacted. I hope we are clear with this. Sir, I keep solving test questions repeatedly. Will this help me? Beta, this is only going to help you, because question discussion we were doing in the rank booster mocks also, in the live sessions also. So question practicing we have always been doing. Wow, what I have done specially over here is whatever theory where people fall back, I have taken that theory and came up with these 3 day 1, day 2, day 3 of chemistry sessions. So I'll be in the physical side of chemistry, while discussing D block and coordination, I'll be discussing many questions, because there in D block I'll be covering the theory, and in coordination we'll be applying all the logics. So coordination we'll do questions. For such topics I have deliberately taken more of the time in theory discussion, because these things people miss a lot. And what is the best place to revise with the short amount of time? These lecture notes of just these 8 hours, 9 hours live session, whatever we have, will be more than sufficient for the 3 chapters: atomic structure, mole concept, redox, and whole of the inorganic chemistry. I hope we are clear. Please tell. Piyush, kya beta? Haan beta, obviously. Fine, Piyush. I hope I answered. Now, okay, Black Mystery saying, take a Black Mystery, I answered your question also, beta. I'll be taking questions also, but things require time, and I have answered your question. Now, moving to some more type of problems now. These are questions only. Questions. These are questions only, beta. The top, if I write, calculate equivalent rate of Br2 in disproportionation reaction, give you option. This is question only, but this way I am going to do and cover more of the important topics. Now, let us solve this one, that what is the equivalent rate of Br2? Black Mystery, now you tell me, beta. What is the equivalent weight? You take it as a question. What is the equivalent rate of Br2 for such reaction? Sir, Br2 is undergoing disproportionation. Disproportionation as in Br2 from 0 oxidation state going to -1 oxidation state. That means it is getting reduced. So Br2 from 0 oxidation state going to +5 oxidation state. That means it is getting oxidized. Yes, sir, this is a redox reaction. So what will be its valency factor? Remember, so you will say, now, sir, we have done that, because this is giving, this is taking. So we'll take the packet, whatever transaction. No. But sir, you said that in the previous case, when we had taken the value of the packet, it was not a disproportionation reaction. One molecule of this had one this ion, one this ion. I mean, you take it like one family is having 2 people. One family is having 2, for example, 2 brothers, Mukesh Anil types. They are fighting each other. I mean, I'm sorry, just an example. One family, 2 brothers. One brother giving 3 punches, another brother taking 3 punches. Ultimately, what is the transaction? 3 punches. But here, the same molecule is undergoing oxidation also. The same molecule is getting reduction also. So how much molecules you need for the transaction? Sir, I will call you, but how many you give? So I'll call more of you to at least take that one. because I am giving also, I am taking also. So for the one transaction to take place, I need more of Br2. So you can't do that simply. So how to do it? We shall do it statistically. So statistics say that equivalent weight for such cases is molar mass upon N1 plus molar mass upon N2. Most of the students miss this. If they know the previous concept, they always miss this. So you have to call more number of molecules, because some of the molecules will give electron and some of the molecules will take electron. So for the transaction to be taking place, we calculate equivalent weight statistically, and the statistical analysis says molar mass upon N1 plus molar mass upon N2. Now what is this N1 and N2? N1 and N2 are the electron transacted for each half, for oxidation half and for reduction half. So let us calculate for oxidation half. Bromine from 0 to -1, that means 1 electron is getting transacted, but 1 molecule of this is having 2 bromine. So I'll multiply this by 2. So this N1 becomes 2. Now what about N2? 0 to 5. So change of 5, but 1 molecule having 2. So into 2, that means this is 5 into 2 is 10. So what will be the equivalent weight? So 20 will come as LCM, 10 plus 2 as in 12. I hope we are clear with this. So actually its valency factor will be M 20 by 12, as in 4 5 ja 20, 4 3 ja 12. So valency factor for such cases will be 5 by 3. I hope we are clear. I hope we are clear. These are some very important topics which students miss now. Again, sir, equivalent weight of once you are supposed to do that law of equivalence, what disturbs you is you should know that once you know the complete formula, you can find the molecular formula. But how to calculate equivalent formula? Like for example, I have this metal oxide. So oxygen valency factor, we know it is -2, but metal I do not know. So let's say it's X. So be it whatever be the valency factor, you can again use the logic of equivalent weight by saying that equivalent weight of metal oxide will be equal to equivalent weight of metal plus equivalent weight of oxygen. Equivalent weight of metal you do not know, because this X you do not know, but you always know this equivalent weight of oxygen. How? This equivalent weight of oxygen is known to us because, like for example, metal plus oxygen forming metal oxide, because metal oxide can be formed when metal and oxygen will combine with each other. So if metal and oxygen are combining with each other, then we can say this is a reaction not balanced, be it number of gram equivalent of metal will be equal to number of gram equivalent of oxygen. So number of gram equivalent of metal will be equal to number of gram equivalent of oxygen. Now equate it. Sir, what formula? Because you have to calculate equivalent weight. So use the formula for equivalent weight. What is the formula? Using equivalent weight, number of gram equivalent is equal to weight of substance upon equivalent weight. So let's say X gram of this is used. So X upon equivalent weight of metal, let's say it is E. Upon, let's say, Y gram of oxygen is used. So Y gram of oxygen upon equivalent weight of oxygen is 8, sir. But how do you know this? Because you also know that for oxygen, I know O2 is changing oxide as in O2 minus. Just balance it. Because I have 2 oxygen over here, so 2 will come over here. That means I'll have 4 electrons over here to balance the reaction. So 1 molecule of oxygen is using how many electrons? 4 electrons. So equivalent weight of oxygen will be how much? So equivalent weight of oxygen will be, what is its molecular weights are 16 into 2, because this is O2, so 16 into 2. Upon what is its, for 1 molecule how much electron is getting transacted? 4. So this is 2 and this is 8. So equivalent weight of oxygen doing this oxide formation is always 8. So X and Y, if it is given to you, you can directly estimate the equivalent weight of metal without even writing the reaction. I have not balanced the reaction. How will I balance? I do not know the valency factor of metal. That is what I'm saying is the application of law of equivalence. Similarly, same beta. Yeah. So similarly, now metal plus chlorine forms metal chloride. Sir, if weight of metal and chlorine are given, then we can do weight of metal upon equivalent weight of metal. That is how we can calculate equivalent weight upon weight of chlorine. Let's say weight of chlorine used is given upon equivalent weight of chlorine, sir. But still, again, you have written 35.5. How do you know? Do that half again. Chlorine from Cl2 is turning to chloride. This half you know. Again, balance it. So how many electrons you have? 2. So for 1 mole of Cl2, how many electrons are getting transacted? So equivalent rate of chlorine will be 2 into 35.5 upon valency factor is 2. 2 will be getting cancelled. So this is your valency factor. I hope I'm making sense. Similarly for nitride, so equivalent weight of number of gram equivalent of metal upon number of gram equivalent of nitrogen, weight of nitrogen upon equivalent, how to calculate equivalent weight of nitrogen? N2 turning to nitride as in N3 minus 2, 3 2 just 6. So one molecule is having transacting 6 electrons. So equivalent weight of nitrogen will be 14 into 2 upon 6. So this is 3. So this is 14 by 3. Okay, here 28. This is double. So 28 by 6 is how much? 14 by 3. I hope we are clear. So this is the process of calculation of valency factor, which you should always keep in your mind. Now, let us do some application of whatever redox theory that we have done. This is a JEE 2024 question. Kindly solve this question. Now, Mr. Mystery, you were asking sir questions, getting questions to solve this. So solve this. Now, only 2 ml of KMnO4 solution of unknown molarity is required to reach end point of a titration. Okay, sir. So how much KMnO4 you are requiring? 2 ml. Titrate, but you are of unknown molarity is required to reach endpoint of a titration of 20 ml of oxalic acid, whose molarity is this in acidic medium. So shall we write the complete reaction? No. Why? Because we know number of gram equivalent of one will be equal to number of gram equivalent of other. But what formula of gram equivalent we shall use for KMnO4? So number of gram equivalent of KMnO4 will be equal to number of gram equivalent of oxalic acid, H2C2O4. Now this is the block chemistry logic that you should know, that what is oxalic acid? It is H2C2O4. Now, what formula I should use for number of gram equivalent? Sir, for KMnO4, its molarity is given and its molarity has to be calculated and volume is given. So what formula you should use? Molarity into volume into valency factor. Use this formula for KMnO4. Now, for H2C2O4, sir, KMnO4 in acidic medium. Now, this valency factor calculation you should know. So, valency factor calculation I am doing separately. I am not writing the complete valence reaction. But if I am transacting, I should know what I form so that I can calculate valency factor. So, what is the active ion? Sir, MnO4 minus changes to Mn plus 2 because I know medium is acidic given in question. So, from plus 7 to plus 2. Electron transacted are 5, so valency factor is 5. Molarity I have to find. Volume is 2 ml, so because volume should be in liters, so 2 by 1000 into valency factor is 5 equal to. For H2C2O4. Now H2C2O4 we know that this C2O4 will convert itself to CO2. So C2O4 2 minus having what is its oxidation state? We have already seen, but I'm doing it again for you. 2x minus 8 equals minus 2. So this is plus 3. It will oxidize to form CO2 because we know it is an oxidizing agent. So electron transacted is from plus 3 to plus 4 is 1. But here 2 carbon are there. So valency factor will be 2. So for oxalic acid also molarity is given. So molarity is 2. How much volume we have taken? 20. So 20 upon 1000. Yes, milli also can be getting cancelled, but because I'm doing everything properly, so writing it. And valency factor we have recently calculated 2. So this 1000 is already gone. This is 2, 5 is 10. So this 0 is also gone. So our answer is easy. 2, 4, 6. 6, I hope 6 ml. Have you eh? Mr. Gamer? No beta. Why should I eat idli? I eat paratha. Punjabis eat paratha. I should not eat. वैसे idli is more वो क्या healthy. Khair. Moving to the next question. Attempt this one. Attempt this question. The question says, in order to oxidize a mixture of 1 mole each of, now I'm doing it quickly. Why? Because I'm having 1 mole each of U. So if I oxalate, or if I oxidize ferrous oxalate, I know ferrous will oxidize to ferric, C2O4 will oxidize to CO2. I've done it twice. So I know its valency factor is 3. Can I write it? So the valency factor we know is 3. Now, because moles we know, valency factor we know. So number of gram equivalent, moles into valency factor. Without doing anything, we are writing. Now, this here valency factor is plus 3. So now, if we have ferric oxalate, then ferric oxalate, Fe is already in plus 3 oxidation state. So Fe can't increase from plus 3, it will not oxidize itself. Plus 2 oxidizes to plus 3. Plus 3 is a stable oxidation state. But C2O4 will oxidize and will transact how many electrons? 2 electrons. But how many oxalate ion you have per molecule? Say 3. So 2 into 3. That means valency factor for this guy will be 6. Although over here in this particular molecule, ferric is not even getting oxidized, but only oxalate is getting oxidized. But this get oxidized from C2O4 to minus to CO2, transacting 2 electrons per ion. And I am having 3 of such ions, so 3 into 2 becomes 6. I hope you are clear. Now, what about ferrous sulfate? In ferrous sulfate, only Fe plus 2 will oxidize to Fe plus 3. Why, sir? Because sulfur is in already plus 6 oxidation state, so sulfate cannot increase its sulfur cannot increase its oxidation state. So oxidation of sulfate cannot take place. Only ferrous will oxidize to ferric, so its valency factor will be simply 1. What about this guy? Sir, now this is the way JEE question tricks us. Now this is 2019 question tricking us. Why? Because ferrous is in ferric, will not oxidize. Sulfur is in plus 6 oxidation state in form of sulfate, not oxidized. So valency factor of this guy will be 0 because it will not have any transaction with oxidizing agent. So ultimately, we are having 1 mole of each species and we have to calculate number of moles of KMnO4. So number of gram of KMnO4 will be equal to number of moles of KMnO4 into valency factor of KMnO4 is 5 because medium is acidic. Now, so this is the total moles. Now, why I'm using total moles? Because I'll be adding number of gram equivalent of each. So number of gram equivalent of first will be moles into. So what formula of number of gram equivalent I'm using? Moles into valency factor. How many moles is given for each? Sir, 1 mole. So for ferrous oxalate is 1 into 3. For ferric oxalate it is 1 into 6. For ferrous oxalate it is 1 into 1. For ferric sulfate it is, for ferrous oxalate it is this, and for ferric sulfate it is 1 into 0 because no transaction. So this is N total of KMnO4 into 5 is equal to 3 plus 6 is 9, 9 plus 1 is 10, that is 0. So this is 10. So answer is simply 2. See, this is how now we have invested a lot of time in the theory part, and because we have invested time and energy and level of understanding, so such questions which is otherwise difficult, see, it becomes a one-liner for us. I hope it is clear. So last question 8 is answer. Let me check. Here, beta, answers. Beta, 8 is the answer. You are right. So maybe 2, 2 ja 4. Okay. Yes, I'm sorry. Beta 2, 2 ja 4, 2 ja 8. I'm sorry. I've added 2, 3 times. I'm sorry. Yes, Mr. Mystery, I'm sorry. Moving to the next question. This is, I hope this is 2. Everybody has got the answer. Moving forward. Now, such plus minuses can be but they create, so that's why you should practice. I gave my JEE paper in the year 2007. Got good rank. So your time now. Thank you. So this is a reaction. Now the other type of reaction which are asked in redox is balancing of redox reaction. So how to balance a redox reaction? Sir, we balance in acidic medium also, we balance in basic medium also. So because basic medium we have to add one step, so I'm using directly a basic medium question. This is 2021 question. A redox reaction is given to you, and now here you have to balance the reaction. So let us balance the reaction. How to balance it? The best possible method is ion electron method, where you write the two half reactions separately. So S8 is getting changed to sulfide. This is 2 minus sulfide. So first of all, balance sulfur. So 8, after balancing atoms except oxygen and hydrogen, balance after balancing atom except oxygen and hydrogen, what I have? Sulfur. So balanced oxygen and hydrogen is not there, so let us directly balance charge. It is having 8 to 16, so 16 electron will come in LHS. That means it is reduction half. What is the other half? Sir, S8 is only changing from, because there is no other sulfur in the reactant, so this sulfur is only changing from S8 to this guy, which is S2O3 2 minus. That means it's a disproportionation reaction. Now here I have 2 sulfur, here I had 8 sulfur, so I'll add a multiply of 4, because 4 into 2 is 8, sulfur balance. Now balance oxygen. How much oxygen I have? 4 into 4 is into 3 is 12. So add 12 water, as in add oxygen, add water to balance oxygen. After that, add hydrogen H plus to add to balance hydrogen. How many hydrogen I have? 12 into 2 is 24. So I'll add 12 into 2 is 24 H plus. But sir, medium is basic, so don't worry. If medium is acidic, do this much. If medium is basic, add one step. What is that one step? Add equal number of OH minus, as that you have added H plus ion, but on both sides. Because mathematically, this is doing nothing, adding similar thing on both sides. But if I talk of chemistry point of view, H plus and OH minus ion will attract each other and form water. Now simplify water. I have 12H2 over here, so 12 will be remainder over here. So medium has become basic. Now balance charge. I have 24 minus in left hand side, 4 2 ja 8 minus, so 16 electron in right side will balance the RHS. Now after balancing, equate the two reaction. It is taking 16, it is given 16. So how to equate, sir? Just add them. So if I add these two reactions, what I'm going to get is twice of S8 plus 24 OH minus gives 8 S2 minus 4 S2O3 2 minus plus 12 water. Now because it is still getting simplified, so I have to simplify it. 2, this becomes 12, this becomes 4, this becomes 2, this becomes 6. Nothing is getting cancelled, so this is my simple balanced reaction. Let us see the question. Question is asking us value of A. A is coefficient of OH minus. So answer is 12. Such questions are very much asked in your papers. So such balancing reactions you should know. Moving to the next question, I think you should attempt this one, because this is the same balancing logic which you have to apply over here also. So the same, I just explained this question, that the balanced reaction is already given to us. So 0.1 molar Ki, if I use, if the question is asking us to use 0.1 mole of Ki, as in it is giving I minus, with medium is acidic, with KiO3. This is IO3 minus the active ion. Yeah, with IO3 minus the active ion. Now I have to identify that which of the statements are correct. Statement 1 is 200 ml of Ki solution react with how many mole? Let's say if we have to identify that which are correct. So let us say this is a question for us, that how many moles of KiO3. So number of gram equivalent of this will be equal to number of gram equivalent of this. Either do that, or sir, because balanced reaction is given, so rather do what? Do moles of reaction, because balanced reaction is given. So I can easily say that number of moles of I minus upon 5 moles of reactant upon its stoichiometric coefficient will be equal to moles of IO3 minus upon its stoichiometric coefficient is 1. Now, this is volume and this is molarity. So, number of moles is equal to molarity into volume. So, 200 into 0.1, because it is ml, that is also ml. I mean, I'll take in, I'll think, acha, nahi, I have to convert beta, because that is moles only. So, I have to convert. So, 200 mole is 0.2 liter. So, 0.2 into 0.1 is how much? 0.02. So this is 0.02 upon 5. So 0.02 upon 5 as in multiply 2 as in 0.04. So 0.04, yes. So this moles of IO3 minus will come out to be 0.04. So yes, this is quite comfortable for us that we can check this using moles of reaction. Why using moles of reaction? Sir, because reaction is balanced, so why bother? Why doing valency factor calculation when balanced reaction is given? So both ways are, obviously you should be knowing, if balanced reaction is giving, equate moles of reaction. But how to equate moles of reaction? Moles of reactant upon stoichiometric coefficient. Now again for Ki, but now relate with H2SO4. So sir, but this is not H2SO4, this is H plus. So first let us do for H plus, because moles of reaction we can only do for balanced reaction. So moles of I minus upon 5 will be equal to moles of H plus upon 6. So let's say I do not know these moles. Let us see whether it will come this or not. So because this is same, so molarity into volume, this calculation I already know. This is 0.02, na? 0.02 upon 5. So moles of H plus, I'll get how much moles of H plus? 6 2 ja 12. So 0.012 upon 5. So multiply 2. This becomes 10. So 0.012 is 24 upon 10. That means 0.0024. Yeah. How much it is saying? It is saying something different. I hope. Acha, but this is for, okay, this is for H plus. No, I'm sorry. This is for H plus and question is asking for H2SO4. So ultimately, we have to do the stoichiometry now. Ki if you have one H2SO4, it will give you 2 H plus. So if you have one H plus, you will be requiring half of H2SO4. So if you are having this much of H plus, you will be requiring half of that, as in 0.0, that is not 24, that will become 12. So 12, still it is 0.06, so double of that. So double of that, not this much. So obviously option B is wrong. Similarly, you can check for C also, that 0.5 liter of Ki solution. So 0.5 liter as in 0.5 into 0.1 as in 0.05 moles produces this much moles of I2. So this upon 5. Where is I2? So this upon 5 will be equal to I2 upon 3. So because moles are same only, and stoichiometric coefficient, here I'll get 5, here I'll get 3. 5 and 3 will definitely impact some calculations. It will not be 0.05, it will not be a factor of 10. So obviously I can see this is wrong. So such questions you have to predict some mathematical prediction. Obviously you can calculate, but I can see this is wrong. And last one is saying equivalent weight of KiO3 is molecular weight upon 5. What is for, so okay, for KiO3 minus we have to calculate valency factor. So for IO3 minus, the oxidation state is plus 5. If it is turning to I2, it is 0. So transaction is 5. You have only one iodine, so into 1. So valency factor is 5. So molar mass upon 5 is obviously correct. So A and D are correct. So A and D are correct, as in option 1 is your answer. Now such questions are good. I hope we are clear. Hello sir, how are you? Sachin, I am perfectly good beta. I hope you are doing great too. IIT Delhi. Sir, can we find yesterday physics PDF? Yes, beta. And today's PDF, beta, everything will be there in WhatsApp channel. Join PWJ English. Link will be there in the description section. You can get all these questions. Now, moving to the next question. It was a good question. Finally. So moving to atomic structure. Now, because we are moving to atomic structure and okay guys, with atomic structure, I will be accelerating a bit of my speed. Okay. So Saksham is here. So let us take, this is 6:30, 15 minutes break. So we will meet at 6:45 p.m. So let us take break for 15 minutes, have some chai coffee. I was also having kish kish, so let me remove that kish kish. So we'll meet at 6:45. Okay, guys. Yes, beta. Thank you. But mystery, black mystery. Thank you. But I would rather say, beta, after these theory, go and practice lot of questions. It is actually going to help. Chalo. Atomic structure. Let us start atomic structure. And let us increase our speed a bit. So now, sir, from atomic structure, I mean, in atomic structure, we definitely know that it all started with Dalton said atom is small, but after discovery of fundamental particles, we started knowing that atom must be constituted of these electrons, protons, and neutrons. The first model given was Thomson, like a plum pudding model. Later, Rutherford said, no, there's a nucleus, electron revolving around that nucleus. Size of nucleus is order of 10 raised to the minus 15 meters. Size of orbit is of the order of 10 raised to the power minus 10 meters. So all the mass is concentrated on a very small volume called nucleus. But Maxwell said, no, electron is charged particle. When it is accelerated, it radiates so much of energy that energy of the electron will decrease, and it will have a spiral motion, and it will meet the nucleus, and electron will be destroyed. Oh, sorry, atom will be destroyed. So stability of atom was questioned. Post Rutherford model, Bohr gave it atomic model, but before Bohr atomic model came into existence, there were some developments of Bohr model. The first development was that we started treating electron as a wave. And what wave? Electromagnetic radiation. What is electromagnetic radiation? It is having electric force also. It is having, whenever charge is moving, it applies magnetic force also. So let us summarize some characteristic of EM waves. If electric field produced by the electron wave, let us suppose electron wave is propagating along x-axis. This is direction of propagation of electron wave. Then produced electric and magnetic field are mutually perpendicular to each other. The electric field and magnetic field, which are mutually perpendicular to each other, which are produced. Now, the complete behavior of an electron as a wave, when considered, the electromagnetic radiations came into existence. So for these electromagnetic radiations, we consider them as a wave and we characterize through their properties. So we should know their definition, like the maxima that it attains is a crust, the minima that it attains is a trough. If you travel from a crust to another crest, the distance is called wavelength. Frequency is nothing but reciprocal of time period. Velocity, these electromagnetic radiation always travels with the constant velocity of light. Value is 3 into 10 raised to the power 8 meter per second. How to relate this frequency and wavelength? Nu is equal to C by lambda, as in frequency of any electromagnetic radiation is equal to the constant velocity of light upon wavelength. That means the frequency and wavelength are inversely proportional to each other. Wave number is nothing but reciprocal of wavelength. Amplitude basically decides the intensity of an electron wave. So this amplitude is the maxima or the minima, which basically impact the intensity of an electromagnetic radiation. Now, because there are so many electromagnetic radiation, as per their uses they are classified. So classification of these electromagnetic radiation is known as spectrum. So once we know this spectrum, there are so many important conclusions that what are their uses. In this direction, frequency increases, and in this direction, wavelength increases. This is how we learn the classification of electromagnetic radiation, which is known as the broad spectrum. The high frequency radiations which are of use for our knowledge are the cosmic rays. What are the range of frequency and wavelength? That you can learn in your modern physics. In chemistry, the range of wavelength and frequency is not generally asked, but yes, for modern physics type of question you have to learn them, but do that memorization in physics. So high frequency radiation are cosmic rays. less than that are gamma rays, less than that are X rays, then ultraviolet, then visible. Visible is nothing but VIBGYOR. So for VIBGYOR also, violet, indigo, blue, green, yellow, orange, red, this direction frequency increases. That is violet electromagnetic radiation have highest frequency, therefore red has least frequency. Speaking inversely, red has highest wavelength, therefore violet has minimum wavelength. After visible we have infrared, then microwave, then radio waves. Now these are some uses. Because of their use they have been classified. So gamma rays are used for cancer treatment, X-rays are used for medical pictures, ultraviolet your CID germicidal lamp, the खून कहाँ गिरा है दया, the blue colored lamp, the germicidal lamp are ultraviolet radiations. Visible radiation is for illumination, infrared radiation is your induction heater, the microwave is your microwave is also microwave for cooking purpose, and then radio waves for signal and transmission, because of which we are seeing each other. Now I mean I am seeing your comments and you are definitely seeing me. So these all electromagnetic radiations are the infrared, are the radio waves range, obviously requiring very less of energy, but wavelength are very large, so they can travel long distances requiring less of energy. Therefore your Wi-Fi router is not taking that much of electricity as your air conditioner in your room. Although your air conditioner in your room is not teaching you, your Wi-Fi you can explore the world. So Wi-Fi requiring very less energy, because energy required for such electromagnetic radiation is very less. Their wavelength are large. So a very beautiful application we can see also. Now, apart from, before discussing Bohr model, one more development. They said yes, electron can be understood by considering it as a wave, but you can, some of the properties of electron you cannot understand if you consider them as a wave. You can only understand those property of electromagnetic radiations when you consider electron as a particle. So that particle property also becomes important. What are those particle property? The most important property is photoelectric effect. Yes, rather very less asked, but you should know that is that one of the property which can be, one of the property which can be only explained using particle nature is the black body radiation. So for black body radiation I'm not going in detail, you should just know this NCERT graph which says that as you increase wavelength, intensity increases, acquires a maxima, and then it decreases. Once you increase the temperature, the pattern remains the same. As wavelength increase, intensity increase, attains a maxima and then decreases. But as temperature is increased, the peak of the intensity attained at the wavelength, the value of wavelength decreases. For example, at temperature T1, peak is attained at this wavelength. Let's say this wavelength is lambda 1. If you increase the temperature, the peak of intensity is attained at this wavelength, that is lambda 2. So if you increase the temperature, pattern as in variation of intensities with wavelength is same, but the maxima that is attained at higher temperature, that maxima is attained at a minimum wavelength. So this is Ven's displacement law, not telling you advanced topic, but this graph I feel everybody should know. Now after that, what you should know? I said after that we should know threshold, the photoelectric effect. What is photoelectric effect? Incident energy is equal to work function energy plus kinetic energy. So whenever I have a metal surface, okay, this is not relating to photo. Let me first do a photoelectric question. Okay, let me do this question only. Photoelectric effect I'm explaining. What is photoelectric effect? You have a metal surface, incident radiation coming, striking on the metal surface, electron present in the bulk will take that photon, that electromagnetic radiation when given by sun is known as a photon. So electron take that photon, attain that energy and comes to the metal surface because they are attracted by positive ions. So once it comes to the metal surface, the amount of energy required is called work function energy or threshold energy, and after coming to the surface, if energy is left, it ejects out of the surface with some kinetic energy. So that becomes your classic photoelectric effect equation. Now, sir, what about the packet of energy that we get? How we calculate the energy packet? The energy packet calculation is given by Planck's theory, which said that energy attained by each packet is directly proportional to frequency, and obviously it is inversely proportional to wavelength, and the proportionality constant becomes Planck's constant. So in terms of wavelength, it becomes hc. So energy of each packet is either equal to h nu, and it is also equal to hc by lambda. But if you have a light source and light source is giving you energy packets, so it will not give you one packet. Let's say in a time t it will give you thousands of packets. So total energy will become total number of packets into energy of each packet, as in total number of packet into energy of each packet. So this becomes the energy given by a source. So let us see this question. The energy of 1 mole photons of radiation wavelength this much is. So you just have to do into divide for such questions. So we have to calculate energy, total energy. But total energy for how many photons? 1 mole photon. So 1 mole is Na, and energy of each photon, we will not use this formula because wavelength is given. So we'll use hc by lambda. So h into c, okay, by lambda. Okay, why I'm writing this formula again is because there is a way you should do this calculation easily. What is the way to do this calculation easily is simply, once you are going to calculate energy and you are given hc and lambda, if this lambda is given in angstrom, then you can easily calculate energy in electron volt. How? We know value of H is 6.626 into 10 raised to the power minus 34 joule into second. C is 3 into 10 raised to the power 80. You can any way do the multiplication, but it will rather take time. So if you want to save some of your time, this Hc can be equated as 12400. So this is a mathematical trick to help you with the easy calculation. So energy in electron volt will come out to be 1,2 because this is an angstrom, so a nanometer. So 1 nanometer is 10 raised to the power minus 9 meter. 1 angstrom is 10 raised to the power minus 10 meter. So if I take minus 10, so I have to increase a 0 over here. So this becomes 3000. So upon 3000. So this is nothing but 12.4. So 3 4 ja 12. 3.1, approximately 3.4.1 something, this much. Now whatever energy you get is directly in electron volt. So this is the energy. Now we have to calculate total energy. So total energy is equal to number of photons. How many photons I'm having? 1 mole. 1 mole is Na into 4.1 into what is electron volt? 1 electron volt is 1.6 into 10 is power minus 19 coulomb into volt becomes joule. Answer, whatever value you have, okay, you have in kilojoule per mole. So because I have to make it in kilojoules, so I have to divide by 1000. So it becomes kilojoule. Now, why I am not calculating intentionally? I am not calculating because there is one more mathematical trick. Although you can do, but there is one more mathematical trick. What? Sir, okay. Ekaf, leave the center, beta. I teach from my home studio. So I'm at my place. It's in Madhya Pradesh. So now coming to the question, what is charge of 1 electron? Sir, 1.6 into 10 to the power minus 19. Yes. Hi Ariva. What is charge of 1 electron? This much. What is 1 mole? 6.022 into 10 to the power 23. Sir, charge on 1 mole of electron is 1 Faraday. Remember, 1 mole into electronic charge is 1 Faraday. That's why I was intentionally not calculating it, because you can even write it as 96500 approximately into 4.1 upon 1000. So this 0 will be gone. So this is nothing but 96.5 into 4.1. Why I am doing this? Because you can do approximations once you have options. Increase it, make it 100, decrease it, make it 4. So 100 into 4, somewhere around 400 will be your answer. Which option is closest to 400? Option C. Black Mystery is saying D. I hope you are getting this. Okay. 3 cheers to MP. Sakshama. Yes. Okay, beta. I mean, good for everybody. Sir, if I take running notes for this whole lecture, is it enough for JEE? Yes, beta. For 2027, beta. For 2027, go to one shots. Here we are accelerating obviously, and because we are yeah beta, midnight it will be extended, because I thought one hour for one chapter. I'm having 7 chapters, so I've just finished 2 lectures, 2 chapters. So obviously, and I mean 2.5 chapters, but 3 hours is gone. So yes, it will extend by 12. We'll have to till by 1 maybe we can be done. Let's see, because I have to send sir all lectures. So beta, actually, if you are preparing, obviously these lectures are going to help you a lot. But if you are having time, as if you are studying for 2027, then do these also, because they will also give you a feeling of how to prepare in a efficient and faster manner. Because ultimately in your examination also, the number of times you will read, more number of time you will read, more number of time you will see the same thing, your efficiency of attempting the question will increase. So studying again and again is always helpful, because remember class 10th, in your class 10th board paper, you must have seen that and attempted that question I don't know how many times. That's why you should do that question like anything, because the content was less, so you could revise it that much of amount of time. But if you are disciplined enough, then you can do the 11 12 JEE basics also, JEE theory also, number of times. Many students do it, and those who finish the theory again and again, 2 3 times, maybe 4 times, they are the, I mean, easy 99 percentilers. They make 99 percentile, and then they know the minimum they are scoring is 99 percentiler. So you can become that 99 percentiler by revising more and more. So is JEE Advanced possible? Beta, JEE Advanced also has 45 to 50% paper as easy. If I say 55, then I should include moderate level of questions also. So easy and moderate is somewhere around 55% of the paper. If you attempt 55% of advanced paper, your rank is anywhere around 2000. So yes, AIR 2000 you can reach with this much, but yes, 2000 or maybe 3000 is a easy rank. 3000 3500 is a very easy rank if you just do the mains level of questions properly, select them in advanced paper, and you're through. But yes, add-ons are there, and those add-ons will obviously help you to increase the rank and reject the questions in advance also, that not to fussify in a question which is meant to be left for the first attempt as in you should always attempt your paper in your mains paper also. 2 part. First part, do all the easy moderate, leave all the tough questions, do not touch them. Yes, in the second half, once you are left with time, once you have earned that time, and then do the question. Now moving to the next question, I hope we have got the answer. Now going to photoelectric effect. Now what does a photoelectric effect signifies? As sir, photoelectric effect says the characteristic of photoelectric effect that electrons are ejected from metal surface as soon as beam of light attack the surface and they start coming out. Now why I've taken this theoretical side is because I want to tell you that number of electrons ejected is proportional to the intensity or brightness of the light. Number of electrons. I'm not speaking about their kinetic energy. More be the number of electrons will be coming out of the metal surface when more photons will be going. The number of photons increases when intensity increase. I hope we are clear with this. Sometimes intensity is also termed as brightness. Now, for each metal there is a minimum frequency with which you have to give energy so that it can at least come to the metal surface. That minimum energy is called threshold energy, and corresponding frequency is called threshold frequency or work function frequency, below which photoelectric effect is not observed. You have to come to the surface or else photoelectric effect is not observed. At a frequency when the incident radiation frequency is greater than work function frequency, then only ejection of electrons are possible, and the kinetic energy with which the electrons get ejected, now this kinetic energy is proportional to the frequency. Because if you give, let's say work function is 70 rupees, if you give 100 rupees, 70 rupees will be invested to come to the metal surface, so kinetic energy will be 30 rupees. If you give 1000 rupees, then kinetic energy will become, after 30, add that 900, so 930. So if you increase frequency, kinetic energy will increase, but number of electrons will increase when packets will increase, and when packets will increase, the photons that are incident when intensity increases. So this is a very important point, and for that important point, let us draw the graphs also, because these graphs are now, each graph are actually JEE questions. So treat these complete theory, every slide is a question for you guys. But if I will be taking those questions, then it will be difficult for me to give you all these concepts also. So that is why I have designed these all the lives in such a way that each slide will be giving you at least one probable question for your JEE. One probable concept. Obviously you are going to have 25 questions, but that 25 questions will be coming from a concept. The concept will be delivered in each slide, so pay full attention. Now the graphs, sir, as frequency increases, you have to plot kinetic energy, sir. 100 rupees, 30 rupees, 1000 rupees, more kinetic energy. But ejection will not take place till a minimum frequency of threshold is reached. As threshold is reached, now as you increase frequency after this, kinetic energy is going to increase. Now intensity of light and kinetic energy, because intensity increases, the number of packets increases. Whatever is the kinetic energy will be same. So intensity has no impact. Whatever kinetic energy will be there, it will be same. How much intensity you will increase, it has no impact. Similarly, if I'm plotting a graph between frequency and electric current, now what is electric current? Number of electrons will be, if number of electron increases, current, electric current, photoelectrons current will increase. So electric current refers to number of electrons. So if you increase frequency, sir, the same photon will come with a more kinetic energy. Number of photon will remain the same. So till threshold frequency, you have no current because no ejection is taking place. Post threshold frequency, you start having electric current, but electric current will remain same. Number of photons are not increasing. With frequency, the kinetic energy must be increasing, but the value, the numbers will not be increasing. So this will be your graph. But if you increase intensity, then number of electrons will start increasing. So rather it will have a linearly increasing graph. I hope we are clear, guys. Now these are some very beautiful and important graphs. Moving to, those were also questions, not theory. So moving to the, ultimately where we came, sir, ultimately we came to Bohr model. Now Bohr did its calculation and given us what? Radius of electron in nth orbit, where Rn is equal to R naught into n square by z. Velocity of electron in nth orbit, V naught into, thus these proportionalities are very important. And energy of electron in nth orbit is minus E naught into z square upon n square. Very important formulas that you should remember by heart. Now, one of these formula must be used in this JEE Mains 2023 question. The question says the radius of second orbit of lithium is x. So x is what? Second orbit. So radius is r naught into n square. So 2 square is 4. For lithium, z is 3. So ultimately I know r naught in terms of x. Now this is given. So equation 1. The expected radius of third orbit. So R3 will be equal to R naught, which is 3x by 4 into n square, which is 3 square as in 9 upon z. So for beryllium, z will be 4. So answer will be 27x upon 4 into 4 is 16. So this is option 3. I hope we are clear with this. Yeah, perfect. Moving to the next question. The next question says for hydrogen atom, energy of electron in first excited state is this much. So this is energy in first excited state. What is first excited state? The ground state is n equal to 1. So first excited state is n equal to 2. So E2 is given. So E2 will be equal to minus E naught into n square, which is, sorry, this is energy. So z square, because this is hydrogen, so z is 1. So 1 square upon n square. So this becomes 4. So this value is given out to be minus 3.4. So ultimately E naught is given to you. Okay, sir. Kinetic energy of same electron of hydrogen is this much, and you have to give me the value of x. Now, what is kinetic energy, sir? Ultimately, if you do the energy calculation, you do not have to remember and do the derivation. Even I am not doing the derivation, giving you the result only. That energy of electron in nth orbit, which is nothing but total energy of electron, is obviously equal to its kinetic energy plus potential energy. This is even true for a gravitational system, that total energy of any electron or gravitational system is nothing but negative of kinetic energy. The first conclusion that you should know. Also, the total energy is equal to double of potential energy. So these are the two important conclusions which you should know. Here only this conclusion is used. So because I know what, now I have to calculate the kinetic energy. So the total energy is already given. Why bother? Why I'm bothering calculating the value of E naught? Why? Because for the second excited state, the total energy is already given to you, and you are asked for the same electron as an electron in the same first excited state. You are asked just the kinetic energy. So we know kinetic energy is whatever energy you have in whatever orbit, just multiply it with a negative sign, that will be your kinetic energy. So if your total energy is minus 3.4, your kinetic energy will be plus 3.4. So your answer will be plus 3.4 electron volt will be directly the kinetic energy. Do not bother applying formula also. So okay, x electron volt, and you have to, so this is 34 into 10 raised power minus 1 electron. Okay, your answer will be 34. See, yes, black mystery, perfect. Moving to the next question. The next question, again, the proportionality which I was emphasizing on. Now, why proportionality is important? Let us check and see. Now, this is a 2021 question asking you just that proportionality only. The kinetic energy of the electron is this much. Now, kinetic energy proportionality will be that of total energy only. Why? Because there is a negative sign. Proportionality is the same. So, what is energy? Sir, energy is proportional to z square upon n square. It is saying z square upon n square. Yes. So, A is correct. Now, the product of velocity of electron and principal quantum number. So what is velocity proportionality? V naught into z upon n. But question is saying you do not have to do it for velocity. Product of velocity and principal quantum number, which is n. So n v will be just proportional to z, because nv, if you multiply n will be, so this denominator will be gone. It will be just be proportional to z. Nv proportional, it is saying z square. So no, this is wrong. See, frequency of revolution of electron. Okay, now what is how to calculate frequency of revolution? Now let me do it in another page for you. So for frequency, a very important conclusion I would rather say, you should know frequency is nothing but 1 upon time period. Time is nothing but distance traveled upon speed. So speed will come in the numerator. So because I'm discussing proportionality, so let us check the proportionality of velocity upon distance. So what is the distance what that electron covers? So 2 pi r. Distance of a circumference is 2 pi r. So 2 pi is just constant. So writing r only. What is proportionality for volume? So for volume, it is V naught into Z upon N. So this will be proportionality for radius is R naught into N square upon Z. So this is N square upon Z. So Z will go in the numerator. So rather proportionality becomes Z square upon N cube. Let us check. Z square upon N cube. No, it is saying Z cube upon N cube. This is wrong. So this is wrong. C. Coulombic force of attraction of the electron. Okay. Coulombic force of attraction. So what is Coulombic force of attraction? How to know this proportionality? Sir, we know that whenever we have a nucleus and revolving electron, the inside force will be equal to outside force. Inside force is this Coulombic force, centripetal force. Centripetal force becomes equal to centrifugal force, which we know through the derivation. So this force will be equal to mv square by r. I hope you remember the formula, the derivation. If you don't, I'm telling you, centrifugal force is nothing but mv square by r. Now because I'm just interested in the proportionality, so I am removing this m, focusing on velocity. So velocity is z by n. So velocity square becomes z square upon n square. Now what about radius? R naught into n square upon z. So proportionality becomes Z cube upon n raised to the power 4. Okay. So Z cube upon n, yes, this is correct. I hope everybody has got answer. Now, so what will be our answer? A and D. So option B will be our right answer. I hope we are clear with this. Now, moving to the, my voice is what audible, na? I'll speak slow because otherwise I'm doing kha kha. So I should not do kha kha. So moving to the next question now. The hydrogen spectrum, Bohr theory also help you to predict that what are the spectral lines that you obtain as per your broad spectrum. Whenever electron makes a transition from higher state to ground state, there will be release of some electromagnetic radiation, and those electromagnetic radiations released are called spectral lines. So for hydrogen, the spectrum was obtained and it was studied, and it was proposed that whenever electron make a transition from higher state to ground state, as in n equal to 1, whatever spectral lines or electromagnetic radiations you get belong to a series called Lyman series. Now these are some scientific terminologies which you should know. So for hydrogen, whenever electron makes a transition from higher state to ground state, the spectral lines becomes the spectral lines of Lyman series. Whenever electron make a transition from higher states to n equal to 2, they are called Balmer series. N equal to 3, Paschen series. N equal to 4, Brackett series. N equal to 5, Pfund series. Humphrey you can leave, that is n equal to 6, but till Pfund you should know. Now, in the broad spectrum where these electromagnetic radiations lie, Lyman series spectral lines lie in ultraviolet region. Balmer lies in visible region, and rest all lies in infrared region. The wavelength part you can skip, it is learning this part. Yes, for modern physics you should learn them, but for chemistry essentially you can not, they are more or less asked in advance, but for mains you can leave the value of wavelengths. Now again, relating it with the energy packet, because every electron, every spectral line will be associated with an energy, and we definitely know that energy of each packet. So if an electron making transition from high state to ground state, there will be some difference in energy. So difference in energy will be proportional to frequency, because energy is proportional to frequency, and difference in energy will be inversely proportional to wavelength. Therefore, let's say for Lyman series, if somebody is asking you that from infinity to 1, how much is the energy difference? This much. From 2 to 1, what is the energy difference? This much, because this graph we plot as per the actual mathematical values. So this is more and this is less. So this is high frequency but lowest wavelength. This is least frequency, least energy, but maximum wavelength. So the maximum and minimum wavelength you should know through this logic. Applying this logic directly to the questions. So the question says, now these questions are very, very famous for your JEE. Now this is a 2019 question. Let us attempt this. The question says, for a given series of spectral line of atomic hydrogen, let delta nu equal to, okay, this is nu bar max minus nu bar minimum, be difference in maxima and minima frequencies in centimeter. Okay, frequency. Actually, listen, nu bar generally we write for wave number. Symbol nu bar generally we write for wave number. Generally, this is not a universal fact. Examiner is giving you question and telling you take nu bar as frequency. So take at frequency. Don't say, no, I write it as wave number. Question, examiner has tricked you. It is saying also that this is nothing but frequency. So first let us calculate, then you have to calculate this ratio. So let us calculate nu as in frequency difference for Lyman series, which is nothing but, I'm for that nu bar I'm writing as frequency only, because now we know it is frequency. So frequency of maximum transaction minus frequency of minimum transaction in Lyman series. So how to relate, because I have to calculate the ratio only, so rather I'm taking proportionality, because Ultimately, we know the formula of wavelength. What is the formula of wavelength? Let us revise that formula. The formula of wavelength says that for any transaction, 1 upon lambda is equal to Rydberg's constant into z square into 1 upon n1 square minus 1 upon n2 square. This wavelength comes in meter when you put Rydberg's constant as 1.1 into 10 raised to the power 7. This is approximately value of Rydberg's constant. It is more than sufficient. Now, what is n1, sir? N1 is that orbit which is obviously lesser, because n2 is that orbit which is higher. Why? Because then only you will get lambda as positive. Yes, if electron eat that wavelength, it will go from lower orbit to higher orbit. If electron will throw that energy packet, it will come back from higher orbit to lower orbit. Ultimately, it will eat this wavelength, go up, give out that wavelength, it will go down. So transaction will be of this wavelength only. So for mathematical purpose, you can always remember that put n1 which is lower and n2 which is larger. Now, after knowing this formula, we definitely know that frequency is nothing but nu is equal to c by lambda. C is a constant, so 1 upon lambda. And 1 upon lambda formula we have recently seen, it is r constant, so leave z square because it is talking of hydrogen, so leave 1 upon n1 square. So for maximum, what shall be the value of n1 and n2? You just tell me. So it will be maximum. Sir, maximum frequency. So this is maximum frequency. So maximum frequencies for Lyman series is 1 to infinity. So 1 is lower, infinity is larger. So 1 upon 1 squared minus 1 upon infinity squared. This is for maximum. Minus. What is proportionality of new frequency minimum, frequency of minimum frequency transaction? For Lyman series, minimum will be 2 to 1. That means 1 upon 1 squared minus 1 upon 2 squared. I hope we are clear with this. That means proportionality is, this is nothing but 1 minus, this is 1 minus 1 by 4. So this is 4 minus 1, 3 by 4. So this is nothing but 3 by 4. So the whole proportionality becomes 1 by 4. I hope we are clear with this. This is for different, this is new difference in frequency for Lyman. Now, let us do the same thing for difference in frequency, but for Balmer. So it will also be equal to frequency max minus frequency minimum. But now for, and because we are calculating proportionality, so I rather write proportionality, and now I know the only thing is 1 upon n now. So for maximum Balmer series, maximum is this, as in 2 to infinity. So 1 upon 2 squared. So this is 1 upon 2 squared minus 1 upon infinity squared. Minus, what about minimum? So minimum frequency is for Balmer 2 to 3. That means 1 upon 2 squared minus 1 upon 3 squared. That means proportionality, this is nothing but 1 by 4 minus. This is 1 by 4 minus 1 by 9. So let us solve it. This is 1 by 4 minus 9, 4 is 36. And 9 by 4 is 5. So proportionality is 36 into 4. And in the numerator, you should have 36 minus 9, 5 4 ja 20. So 36 minus 20 is 16. So this is 4 4 ja, this is 1, and this is 9. So this is, I guess, 1 by 9. This is, I guess, just check the calculation. This is 1 by 9. And we are supposed to calculate, let me use another pen. We are supposed to calculate the difference of this Lyman and Balmer ratio. That means 1 by 4 upon 1 by 9. So this rather becomes 9 by 4 as an option A. Let me check. Yeah. I hope we are clear. Perfect. Black Mystery has already found the answer. Perfect, bhai. Perfect. Moving to now, these were actual application of questions that are asked in your JEE paper. So I'm investing my whole of energy in explaining all of them. Moving to Some statement based questions are also flowing in January JEE. So for statement based question, you should know such theory. Now, what are the theories involved? Atomic spectra, we definitely know that whenever we analyze those electromagnetic radiation, those observations are called spectrum. Now let us analyze those spectrum. So spectrum actually are of two types. They are based on nature also, they are based on origin also. As in, if some excited sample is giving out energy, that spectrum is called an emission spectrum. If from a white light source is coming and as a sample I absorb that electromagnetic radiation and then allow whatever is remainder of the packet of incident energy, then that spectrum becomes absorption spectrum. This is on the basis of origin. Now on the basis of nature, as in when you obtain that spectrum on a photographic film, how does it look like? What is the nature? It can be continuous or it can be discrete. Continuous as in one color, another color, another color, another color, or colors are superimposed. You do not see any black portion in your photographic film. Once you have discrete, then obviously you see some black, as in some irregularities in the receiver side of those electromagnetic radiations. So they can be a band spectrum or they can be a line spectrum. Like for example, let's say on the basis of origin that I've already explained, that source is giving whatever spectrum you get is a emission spectrum, and whenever light is coming and I'm absorbing and letting out the remainder of radiations, then it becomes an absorption spectrum. Now, important conclusion, sir, emission and absorption spectrum are photographic negative of each other. For example, whenever the top one is colored, it is black. Whenever you find a colored lines over here, it is having black lines over here, and whenever it is black, it is colored. So emission and absorption spectrum are photographic negative of each other, which you can only understand if you see this NCERT photo. So this is about emission and absorption spectrum. Now, what about continuous spectrum? When you have these colors superimposing each other, and what is this discrete form? Band spectrum and line spectrum. Band as in you get color and then you get a band of dark spaces. Again color, band of dark space. Again band of color, again band of dark spaces. So these dark spaces make it discrete. And band spectrum, a theoretical knowledge for statement based questions, band spectrum is given by molecules, not atoms. Atoms give line spectrum. They just have, atoms have electrons. So those limited electrons, actually for hydrogen you only have one electron, because Bohr theory has done this, and Bohr theory was only applicable for single electron species. So they will just give one packet, and those packets will give you lines, and you will have dark spaces, and those dark spaces will definitely be more. You line then dark, line then dark. So actually line spectrum is given by atoms, band spectrum is given by molecules. I hope we are clear with this. Now, some more details about this NCERT photo of absorption and emission spectrum. As wavelength, very important conclusion, as wavelength decreases, the spectral lines tend to converge, and as wavelength increases, spectral lines tend to diverge. Now, what does this mean? If you read the English, it will appear as a rocket science, but go by common sense. Common sense says, like for example, I'm having a wavelength. Here, the wavelength was large. So once the wavelength is large and you plot two wavelengths, once the wavelength is large and you plot two waves, you see by yourself, and the spectral lines or the waves are diverging, as in going away from each other as wavelength is increasing. And as wavelength decreases, as wavelength decreases, they start to come closer to each other, as in they start to converge. So as wavelength decreases, spectral lines tends to come closer to each other, they used to converge, and as wavelength increases, they tends to diverge. A very important topic which you can only feel using common sense. I hope we are clear with this. Now, sir, whenever these spectral lines are getting formed, can we have some permutation and combination? Yes, you definitely can, but I am giving you direct conclusions. whenever an electron is making a transition from an higher state to ground state, what are the number of different spectral lines you get? It is n into n minus 1 by 2, a basic mathematical permutation and combination thing that you know, but the conclusion you should learn directly. From a higher state, electron is making a transition to ground state. So what is the number of spectral lines produced? N into n minus 1 by 2. Now, if electron is making a transaction from, let's say, n2, some excited state, to n1, not to ground state, to another excited state but lower than n2. So if transaction is taking place from n2 to n1, then what is the total number of spectral lines? Total number of spectral lines formula becomes n2 minus n1 by this becomes n2 minus n1 is the total number of different. Okay, this is delta n. I'm sorry. The formula becomes delta n, which is n2 minus n1 whole into delta n plus 1 by 2. I'm sorry. Delta n is difference in energy, n2 minus n1. So what is the different number of spectral lines that you get? Delta n into delta n plus 1 by 2. This was n into n minus 1 by 2 when let's say electron is making a transaction from 6 to 1. So what are the different number of spectral lines? 6 into 6 minus 1 is 5 by 2. If electron is making a transaction from, let's say, 6 to let's say 4, for example, you can count also, but learning the formula. So electron making transition from 6 to 4. So what is the difference? 6 minus 4 is 2. So 2 into 2 plus 1 as in 3 by 2. So answer will be 3. I hope we are clear with this. Now, in case single electron isolated, if electron make transition from nth state to ground state, a maximum number of spectral lines are n minus 1. Like for example, if in the question the sample is having only one single electron species, then that single electron species, if it is going from 6 to 5 or after 5 it is going to 1, then it can't come because there is only presence of one electron. So in that case, when you have only one electron in your system, then what is the maximum number of spectral line? Whatever orbit you are, minus 1 is the maximum number of spectral line, or L minimum can be, I can either make a transaction from higher state directly to 1. So minimum can either be 1. Ultimately I have to go to the ground state. But the theory also plays with such type of question. If you have a single electron species and only one atom, that single electron species, only one is present, then what is the maximum number of spectral lines? No rocket science, n minus 1. I hope we are clear with this. Now, moving to the question. Now, with the question also, I'm discussing theory also, because again, I'm telling you, I have accelerated the speed and deliberately. So I'm for such some slides, I'm using the direct conclusions, which are actual questions. And moving after Bohr model also had limitation. First is it is only valid for single electron species. Second is it said that orbits are circular. Two scientists, de Broglie and Heisenberg, when they came, they said, no, Bohr, you cannot predict the velocity, that is the speed, the momentum and the position simultaneously, because de Broglie said wave nature and particle nature are inversely proportional, and Heisenberg said if you try to calculate position and momentum, you will definitely do some error. The uncertainty in position and momentum will be definitely minimum, it will be equal to h upon 4 pi, maximum it will be definitely greater than h upon 4 pi, but minimum error you will make h upon 4 pi. So combining that Heisenberg principle and uncertainty principle and de Broglie equation, you again get questions. So applying, learning those questions. This question says from JEE 2023 that if the radius of first orbit of hydrogen atom is, let's say, alpha naught, or let me write a naught. So radius of first orbit, so that means a naught is r naught into 1 square by 1, because it is hydrogen. So I mean a naught, whatever constant we take as r naught, is given out to be a naught. Now then de Broglie wavelength of third orbit. So de Broglie wavelength, sir, what is de Broglie? De Broglie says that wave nature represented by wavelength is inversely proportional to particle nature represented by momentum, which is mv or p. Proportionality constant for de Broglie wavelength is also h. So we know lambda de Broglie is equal to h upon p. Instead of p, I'm writing mv. Now, through Bohr theory we know, because it is also relating de Broglie with Bohr theory, through Bohr theory we know
that whenever a system, an electron is making these angular motion, the angular momentum, which is mvr, is quantized. This is what Bohr said, as in it is a multiple of h upon 2 pi. What times of? N times of. So can you see this mv term in both Heisenberg and de Broglie's equation? Yes, sir. So replace this mv from de Broglie to Heisenberg. Replacing this mv from Bohr model to de Broglie's equation. So lambda de Broglie will be equal to, or else you can directly, you can take this h also. So h upon mv will be equal to 2 pi r upon n. It will be equal to 2 pi r upon n. I'm taking h upon mv is equal to 2 pi r upon n. That means n lambda is equal to 2 pi r. A very important conclusion, which actually says that 2 pi r is circumference of Bohr orbit. So that Bohr orbit is not circular. It is wavelength times of wave number. So the circular motion, the circular orbit proposed by Bohr was also challenged by this de Broglie's equation. The challenge is this result, this conclusion of de Broglie equation and proposal postulate of Bohr model. So this postulate only suggests that circular orbit is not possible. Now using it in the formula. So for third orbit, value of n will be 3. Lambda you have to calculate. 2 is 2, pi is pi. What is radius of third orbit? Sir, r naught, which has been formulated as a naught, into n square, which is 3 square, upon z. So for hydrogen, z is still 1. So okay, let us solve now. So this is 3. So this lambda is nothing but 3 to just 6 pi a naught. 6 pi a naught is option C. I hope we are clear with this. Yeah, tomorrow you have maths beta. Definitely yes. So trick, multiply by 2 for that type of question. Okay, sometimes trick works, sometimes do not. So don't. How you are doing mainly PC problems? No beta, Asif, I am doing physical chemistry basics, and for when I say basic, I mean mole, redox and atomic. I'm just quickly moving to periodic table after this. So moving to next problem, the problem again relates to Heisenberg principle, which says, sorry, de Broglie, when light of wavelength this much nanometer falls on metal with threshold this much, the de Broglie wavelength emitted is okay. Now it is using photoelectric effect also and de Broglie also. So ultimately, when light of wavelength this much falls on a metal surface, so we know that incident energy is equal to work function energy plus kinetic energy. This is the threshold formula. So incident energy is equal to work function energy plus kinetic energy. Now, when light of wavelength this much falls on metal of threshold this much, so it will be ejected with some kinetic energy. So let us calculate that kinetic energy. Incident energy is a packet of 248. So because it is in nanometer, so 12400. So I am writing 0 because this is in nanometer. So this is 248. Now see, this is getting cancelled quite easily. So this is 10 and this is 2. That means this is 5. So 5 equals, and this is 3. So this is also electron volt. This is also electron volt plus kinetic energy. So directly you can say kinetic energy is nothing but 2 electron volt. See, calculation has become one liner if you know the some basic. Now this trick will definitely, I would say you should know that this is giving you mathematical edge also. So kinetic energy of electron is 2. Now if you know the kinetic energy, can you calculate the de Broglie wavelength? Yes sir, because de Broglie wavelength we know it is equal to h upon mv, and we know momentum can also be written as under root of 2m kinetic energy. Momentum can be written as under root of 2m kinetic energy. So h, value of h is 6.626 into 10 is power minus 34. The question sometimes gives you some other value. It is saying 3. So let us also take 3. Why bother? Question is only telling us to approximate upon under root of 2 into. What is mass? Mass of electron, it is given also. We should know also it is 9.1 into 10 to the power minus 31. It is SI unit. Kinetic energy, sir, it is, we have calculated it is 2, but 2 is in electron volt. So 2 into 1.6 into 10 to the power minus 19, because then it will be in joule, which is SI unit. You just have to solve. I am not solving now because I will have to manage some time. If you solve approximately the closest integer you have to report, and your closest integer will be 9. I hope we are clear with this. Moving to the next question based on Heisenberg's uncertainty principle, which says the uncertainty in position is twice the uncertainty in momentum. From Heisenberg, we should know that uncertainty in position into uncertainty in momentum is minimum. It is equal to h upon 4 pi. Maximum, it can obviously go beyond this value, but minimum. So let us do for the critical case, that is for the minimum case. Now this in question it is given, it is equal to twice of uncertainty in momentum. Therefore, I can say twice of uncertainty momentum squared is equal to h upon 4 pi. So delta P is equal to under root of h upon 4 pi into 2. And this delta P is mass into delta V, because mass is constant. So because we are asked uncertainty in velocity, so I should focus on this. So delta V will be equal to 1 upon m. This 4 will come out as 2. Rest will be in the root. So under root of 2 pi. So can you see some option? Yes. Option C. I hope we are clear with this. Now, perfect. Perfect. Mr. Black Mystery. Perfect, bhai. You are solving questions. Perfect, bhai. I hope we are clear with this also. Yeah. Okay, we have new active participant tech. Yes, tech lethal. So yes, lethal tech. Now again the next question. Now we, after Bohr theory, I am directly coming to quantum model, not dealing with all but logics of quantum model. So electronic configuration we'll be doing in periodic table. How the electrons are filled we know through quantum model. Quantum model tells us other things also. So let us frame question and learn those other things. Like for example, there's a question and you have to select the correct statement. The electronic configuration for chromium and copper, we know that because of half filled and fully filled configuration, chromium becomes 4s1 and copper becomes also 4s1 for making half filled and fully filled. So chromium is definitely 4s1, so A is correct. The magnetic quantum number may be negative values, and magnetic quantum number value ranges from minus L to plus L including 0. So can this may have a negative value? Yes, it may have a negative value. So this is also correct. This is also correct. In ground state of an atom, the orbitals are filled in order to their increasing energy. Yes, definitely correct. In ground state, whoever energy is less is filled first. So this is also correct. The total number of nodes are no. Actually, node is a region around nucleus where probability of finding electron is 0. Nodes are of two types: radial node, formula n minus L minus 1, and angular nodes, formula L. If you add them, you get total nodes. So formula becomes n minus 1. This is saying n minus 2. So this is wrong. So D is wrong. So what is right? A, B, C. Option D is your right answer. I hope we are clear. Yeah. Aha. We are having more participant. Perfect, bhai. Prince, perfect. Now, again, quantum theory. The orbit having two radial as well as two angular node. So angular node is value of L. So for S, P, D, F subshells, value of L is 0, 1, 2, 3. That means for angular node to be 2, you should be a d orbital. So how many of them are d orbitals? So these two are gone. Now, so value of L is 2, but question is saying you should have two radial nodes also. So radial node is n minus L minus 1, as in n minus 2 minus 1, as in n minus 3. So n minus 3 has to be 2. That means n has to be 5. So it should be 5D. Option 1. Yeah, perfect. Perfect, Prince. Now, I hope we are clear. Moving to... Oh, very good. Very good. So guys, we are done with periodic table. We are done with the physical side of chemistry. Physical side of chemistry, as in the physical chemistry logics that we should know. Yeah, perfect. So post that, I'm just saving this. It is done. Now let we have finished mole, periodic table, mole, redox and atomic structure, and now we are starting with periodic table. So in order to start periodic table, let us first learn the elements which we have in our periodic table. How? With the modern periodic table. Now, yeah, perfect. After knowing all that quantum theory you should know that now, sir, but many questions are coming from electronic configuration. That's why I am now coming to periodic table. So in order to start periodic table question, yeah, now IOC inorganic chemistry has started, guys. So inorganic, those chapters were important before studying inorganic chemistry. So we are starting with inorganic chemistry, and inorganic chemistry starts from periodic table, which says you should know first the elements. So the complete periodic table is modern periodic table constituting of 18 vertical columns called groups, 7 horizontal rows called periods. The first element is hydrogen. The rhyme you should learn: है ली ना की रब से फरियाद. See, technology. So learn with me. है ली ना की रब से फरियाद. Technology. Beta mange car, scooter, baap razi. Yes. Now, because this is an English platform, so I should rather give a rhyme, a mnemonic, which should be English. But I feel whatever crowd we have is more than sufficient to learn the mnemonics to rhyme, because even I have learned these elements in Hindi, in my Hindi, my mother tongue language. But if at all anybody wants an English rhyme, I have those rhyme with me. But obviously you are giving your paper on April, so you must also be getting comfortable with at least this much of the rhyme that I'm using is in Hindi only. So, hai li na ki rab se faryad. After that, group 2, beta mange car, scooter, baap razi. This constitutes S block element, alkali metals and alkaline earth metals. After that, after these alkali and alkaline earth metals, P block start. Although after hydrogen we have helium, they are all first period elements, but helium is not regarded as P block element because its last electron is not entering P subshell. Then sir, why it is written over there? Because it is regarded as an 18th group element. Why? Because it is inert, and 18th group is inert gases, we definitely know, but still mentioning those points. So after helium, which is atomic number 2, you have lithium, beryllium, atomic number 4. So after that, atomic number 5 will be boron. The P block family starts. So boron, carbon, nitrogen, oxygen, fluorine, and last is neon. So this completes the second period. Now in first period, how many electrons we have filled? 2. How many elements? 2. In second period, how many elements we have filled? 8. Now Afbau also says that what is filled first? 1s2. After that, 2s2. Then 2p6. So for S and P, whatever is the period number is the principal quantum number. It is in accordance with Afbau also. So this modern periodic table also helps you to learn and understand the quantum considerations as well, hence coupling these chapters. And therefore it is said, in order to start inorganic chemistry, you should know atomic structure. Hence discuss that atomic structure initially. Now, sir, are hydrogen and helium considered under S block? No, beta. How do you block an element? By the last electron entering. So last electron of hydrogen enters S subshell, so it is S block. Last electron of helium enters S subshell, but it is written over there because none of its properties belonging to S block elements. Hence, it is rejected and written over there. Not rejected, rejected by S block elements, but not even accepted by P block. So, ghar ka bedhi, kolu ka bell types, na ghar ka na ghat ka, because its properties. But how do you block an element? Like for example, if somebody is ask you, how do you define the block of an element? If the last electron is entering to whatever subshell, that defines your block. But hydrogen has been nikalophile by S block element because none of its property is belonging to S block elements. Hence, for helium, no block is defined. Laksh batch is for JEE Main or JEE Advanced. Beta, Laksh is for JEE Advanced. Here we are coming for your April attempt, and for your April attempt, April is JEE Mains paper. Post your JEE Mains paper, we will definitely be coming for JEE Advance. If you are joining us especially in our in-house batches, then obviously those batches are for advance, mains and advance, because advance you can only clear once you are well through with your mains paper. So Laksh, Prayas and Arjuna is meant for JEE Advance. Now, after neon, which is the 10th element, we have placed the S block also, and because we have started P block, so let us finish P block. Here the boron family is group 13, so Baigan, Alu, Gajar in Thela, the rhyme. Ka, Shi, Gai, Shankar, Parvati, the rhyme from carbon till lead. New Zealand, Pakistan, Australia, sub Bikau as in nitrogen to bismuth. After that, Us se tipo, the famous rhyme for oxygen till polonium. After that, for halogens, I do not give any rhyme, so it is fluorine, chlorine, bromine, iodine, and last is astatine. After astatine, sir, these you have left. Why I have left? Because after atomic number 100, even IUPAC gives us a rule that you can write the name of those elements. I'll be giving you that rule for writing name and symbol of elements with atomic number greater than 100, loved by JEE. So after astatine, what group is left for us? After 17 group, we are left with group 18, which is inert gases. Hai na argar kar 0 run pe. Now this constitutes our S and P block, which together is known as representative element. So then in some question they asked how many S block elements, then they did consider helium and hydrogen. Hence I was confused. No beta, if they are asking S block element, you should not count helium, just count alkali and alkaline earth metals. In fact, if somebody is asking you for group 2 that how many alkaline earth metals you have, even beryllium is an S block element, but it is not regarded as alkaline earth metal because its oxide is not basic. So these are some tricks which the NTA plays with you, so you have to vigilant for such questions. फिर Acha, okay. Prince is giving a rhyme. Huh? Everybody has their own rhyme. So if you have a rhyme, let it be. Learn that only. Just for those who are not having any rhyme, I'm making them comfortable with periodic table. Now, after representative elements from 4th period, we start the 3D series, which is after calcium, which is 20. Shakti Walker, the rhyme which I use for scandium till zinc is Shakti Walker man fe ko ni. If you throw something, it will सूज जाएगा, तो सूजन. So Shakti Walker man fe ko ni सूजन. I hope we are clear. Now, after that, you should learn these groups independently. Why? Because sir, zinc, cadmium, mercury, this group 12 elements are actually D block elements, but they are not regarded as transition elements because D block elements are also termed as transition elements. Why? Because they have empty d orbital or they have half filled d orbital either in their ground state or in any of their excited states, so that they can react with outside reagents involving their desumption. But this zinc, cadmium, mercury, they do not have any partially filled d subshell in any of their ground state or in their excited state. Therefore, these are regarded as d block elements but not as transition elements because they have no empty d orbitals or half filled d orbitals in any of their oxidation state. Moreover, these are those elements, these are those groups which are highly volatile. Actually, these transition metals, these D block metal have very high melting point, but these alkaline earth metal, they have very low melting point. So in fact, they are so low that their melting point is very low. So they are easily vaporized, melting boiling point. So they are termed as volatile metal. So you should learn them with no rhyme, as in zinc, cadmium, mercury, just like this. After that, copper, silver, gold are the coinage metals. You should learn them too. Post that, nickel, PDPT. Now, no rhyme, nickel PDPT, sir, but many students get confused. PD first, PT first. Alphabetically, D comes first or T? D. So, nickel, alphabetically PDPT. So, nickel PDPT. Now, after that, you should know the second transition series. The first transition series is the 3D series. After that, you have 4D series, which is यारी जरा सी निभा मौत तक रुकावट राह में. उस rest after that we already know. After that, beneath yttrium we have lanthanum, and beneath lanthanum we have actinium. Now, atomic number of lanthanum everybody should obviously remember also, it is 57 and this is 89. So after lanthanum, we fill the 14 4f elements which are called the lanthanoids, and post actinium we fill the next 14 elements which are filled in the 5s subshell called the actinoids. Post their filling, the remaining D block elements are filled. That means after lanthanum, 14 are filled in lanthanoids, and then the other element will be coming next to lanthanum. So what is the rhyme for this? So it is La hafta varna re usdhar irdhar pीटूंगा. That pीटूंगा we already know because we know nickel PDPT. So again, La hafta varna re usdhar irdhar. Why I say usdhar? Because OS is osmium. So sometimes if you don't say that, you miss the letter, you miss the symbol. So La hafta varna re usdhar irdhar. After that, you know pीटूंगा. Now, what about the elements after actinoids? You should also know them because symbol directly questions are coming as per electronic configuration. If we know their places, their atomic number and electronic configuration becomes predictable. Now, so what is the rhyme for the last transition series? It is Acha. As you say, Acha. There was a singer in my time, Raftar. So Acha, Raftar, dubbing, singing, बहुत हंस के करता है. So if somebody is doing dubbing, singing with a lot of grace, then I'm saying another picture. Do not give in my side of Madhya Pradesh. If you say don't give that thing to, so don't give is said mat des. So mat des as in mat do, mat des, what do not give? Because it's a singer, so do not give him rugged cones. Rugged cones as in the cone, somebody plays that cones with their hands, no? So the story becomes अच्छा रफ्तार डबिंग सिंगिंग बहुत हंस के करता है, मत देस rugged cones. Now this is a rhyme which I have learned. Obviously you can have another rhyme, but ultimately you should know the symbol and their position in the periodic table. Now after that, sir, you have not given the rhyme for lanthanoids. That is all not important, very important, so giving you that. Obviously the rhyme says that this is classical rhyme. Seena par nadiyan, I say PM की समाई because these days people love PM. So सीना पार नदियाँ PM की समाई. यूं as in EU, गदगद as in GD, तब as in TB, तब. दिल ये as in DY, हुआ as in HO. After that अरे, अरे as in ER, तुम as in TM, ये भी as in Y भी, लूट लो as in lutetium LU. So what does the rhyme becomes? सीना पार नदियां PM की समाई, यूं गदगद तब दिल ये हुआ, अरे तुम ये भी लूट लो. The rhyme, the 14 elements you should learn for lanthanoids. After that we have actinoids. The rhyme says थोड़े पहलवान उनसे निपटेंगे. After that another story, पुराने आम कम बिकेंगे. After that कैफे में ऐसे फरमाओ मैडम, कैफे में ऐसे फरमाओ मैडम. Now because कैफे में ऐसे, they are all Einstein, they are all scientists, and scientists love Nobel Prize. So कैफे में ऐसे फरमाओ मैडम, so Nobel Prize, Nobel laureate, bring it on. So this becomes your actinoids. Again the story says थोड़े पहलवान उनसे निपटेंगे, पुराने आम कम बिकेंगे, कैफे में ऐसे फरमाओ मैडम, Nobel laureate as in LR Lawrencium. Now you can leave learning their name. If you can, it is good, but if with the shortage of time, if you have not learned their name, then let it be. learn their symbol, and if you learn them their symbol with the rhyme, their position in periodic table can easily be predicted. I hope we are clear with this. Now, what about their electronic configuration? Sir, electronic configuration, we definitely know that first ns2 is filled, as in first period 1s2, then 2s2 2p6 as per our principle, 3s2 3p6, then 4s2 after fourth period D will start, so D is n minus 1, so fourth period, so 4 minus 1 is 3D, and then 4p, then 5s2, after that one less, so 5s2 as in 4D, and then 5p6, 6s2 just lanthanum, which is 6d1, 6s2 5d1, that is for lanthanum. So ultimately whatever I will be doing that general electronic configuration filling here only, but I was just doing that analysis by iterating it because this is just in accordance with Aufbau principle. So sir, can you give us the general electronic configuration, because it is obviously asked? Yes. So for S block it becomes ns122. Why? Because period number is the principal quantum number, alkali ns1, alkaline ns2. For P block, ns must be filled, after that 13th group 14th group will be filled, so np 126 till 14 till 18. What about D block? So if you just exclude one element, what is that one element? Palladium. Because like in case of chromium and copper where one electron used to migrate inside, there are other elements also where one electron migrates to inside. But there is one element which is palladium in D block where two electrons migrate inside. So because two electrons are migrating inside, so I am writing it separately, and therefore if considering other element, what will be the general electronic configuration for the D block elements? Sir, ns2 will definitely be filled, but we definitely know this 2 can be 1 also for chromium and copper. So for chromium and copper there are other elements also with this exception, and n minus 1 D can be filled from 1 to 10. But if you are not writing palladium to I am writing palladium independently, therefore I am not including over here. But if I am not writing palladium independently, so I have to include, then general electronic configuration becomes ns 0 to 2, because this 0 also have to account, so this becomes 0 to 2, and n minus 1 D 1 to 10. I hope we are clear with this. And ultimately F block general configuration is very easy. The ns2 is filled, then n minus 1 D only one is filled, the lanthanum and actinium, but this electron can also go inside for the same reason, for stability of F half filled and fully filled, so this also becomes 0 or 1, and n minus 2 F 1 to 14. Sir, you said apart from chromium and copper there are other elements which allows migration of one electron to inside. Do we have to learn those elements? Beta, for a basic mains question you can leave, but for good type of question you should learn them also. So there is a rhyme, yes. So all the elements which have exceptional electronic configuration in the D block are these. So electronic configuration with exceptions, a rhyme for those elements which have exception in their electronic configuration, just like chromium and copper. What is the exception? They just take one electron inside, one electron. What are those exceptions? Sir, we have already done this rhyme, but I'm using, they do not belong to a same period, but I'm using a rhyme for that period. The only story you have to add in the rhyme is Nawabi NB. I mean, just this is a rhyme. Nawabi क्यों करें? Why you should Nawabi? Don't do Nawabi. Nawabi क्यों करे? Then the rhyme is same. मौत तक रुकावट राह में पड़ी है. And after that you should learn that like copper, silver and gold will also have exception. And because palladium is having different exception, and what is that different exception? It is taking 2 electrons from the s subshell, and n minus 1 is gaining those 2 electrons and becoming 10. none of the other elements are taking 2 electrons. They are just taking 1 electron. So just like copper, silver and gold will also be there, and just beneath platinum, although in case of platinum there is no profit. As for the theoretical profit that we have is stabilization of half filled or fully filled. Here the ns1, only 1 electron is getting transferred, and n minus 1 has 9, as in platinum belongs to the after this is nickel pd pt, so this is 4s and 3d, so this is 5s and 4d, so this is 6s and 5d. So actually this is nothing but 6s1 and this is 5d9. So for palladium it is 5s0 and 4d10. So only palladium has this exception that 2 electrons are introduced inside, but this exception we can understand. Why? Because ultimately it is attaining a fully filled configuration. For platinum, it becomes very crucial for students that 1 electron is migrating inside. By that migration also it is showing what? It is showing an electronic configuration which is not even fully filled. So this is 6s1 5d9. But the properties of platinum shows that the amount of energy required to remove 1 electron is relatively lesser. So you do not have to learn all those experimental reasons, but yes, the exceptions you have to learn. So what are the exceptions? Again, the rhyme for them is Nawabi kyun kare. After that, Nawabi as in NB, kyun as in CU, kare as in CR. Maut tak rukavat rah mein padi hai. Because copper has exception, similar exception is present in silver and gold, and platinum also has an exception like palladium, but all these other exceptions are they only take 1 electron inside. Only palladium takes 2 electron inside. I hope we are clear with this now. Okay, so this is the slide which I was having for you people. Now let me move to my P block basics. Now those were the P block logics which I have discussed you using the PPT. But now let us go to our slides. So periodicity, I'm starting after periodic table discussion, and the discussion starts with, obviously we have seen this modern periodic table, but the basic thing which you should know is modern periodic table was developed by Henry Moseley. How? Because he have observed that under root of characteristic frequency was having relationship with atomic number, not mass number, and the relationship, the graph which Moseley obtained before development of periodic table, the modern periodic table, the proportionality is, the equation is under root of characteristic frequency of the X-ray he used for the analysis was equal to a constant into Z into Z minus B, where Z was the atomic number. Yes, it is a straight line, but you should know the characteristic relationship between frequency and atomic number, and after this relationship it was proposed that you should draw and formulate the periodic table in accordance with increasing atomic number. So it was a straight line. We obviously know this now. We have seen this periodic table. Coming to the electronic configuration, which I was saying that you should know this in accordance with Aufbau rule. First period has 1s2, second period has 2s2, 2p6. So SNP has the same principal quantum number as period number. Third has 3s2, 3p6. Fourth has 4s2. After that, one less. So 3d, then 4p. 5s2, 4d, then 5p. Sixth period and seventh period, lanthanides and actinides start getting filled. But after 6s2, you fill one element. What one element? Lanthanum. Lanthanum with atomic number 57. After that, 14 element becomes lanthanoids, atomic number 58 till 71. 72nd elements comes beside lanthanum and completes the 4D series, the fifth period transition series. After that, we fill 6p6. After that, again same fashion, 7s2, one less, so 61 becomes actinium. After that, 14 elements from 90 to 103 are the actinoids, and 104 comes next to actinium. Then complete D is filled. After that, you fill 7p6. This constitutes the 18 elements. This becomes the magic number which will help you to calculate atomic number of last element, and this is how you can predict electronic configuration also, atomic number also, group also, block also, period also. Such question find lot of applications. So this categorization of periodic table you should definitely learn by heart along with the symbols. If you have any other rhyme, you can take that rhyme, but you should know that what element has what symbol and to which period it belongs. Yeah, perfect. Now, these exceptions we have already done. Now I will be giving you these notes. Why? Because if anybody wants the rhyme which I was iterating, so I have given those rhymes also with the symbol name highlighted. So I mean, for those who have not learned this rhyme, they can take these lecture notes also. Now, sir, please do more PYQs on periodicity. Then beta, see, I have already made the presentation in such a way. See, I have already told this in previously during physical chemistry questions. Actually, questions beta, see, questions for coordination compounds, I'll be doing only questions, because in order to discuss those questions, I need some theory. So I will be discussing those theory in the question, or else with some chapters I'll be dealing with the theory and then coming to the questions on those particular chapters. So because I have formulated this presentation in such a way that a person who is going to watch these 8-hour live, it will be helpful for that person even he is starting from zero. Yes, in order to practice more and more questions, if I do those questions over here, more benefit you will be getting if I'll be discussing theory. And then, because see, physical chemistry we want only questions, because 2 plus 2 is 4. What theory is used? So we only need practice. But chemistry is a explanatory science. That's why the statement based questions in January which you faced, why you were falling short of those questions, because you were not comfortable with the tricks and turns in the theoretical explanation side of it. So relax, but please be very much focused here. Invest these time with me till 12. You will definitely come to know how it is going to help you. Now this is a question actually. I mean, not one question. You can find 8-9 questions every year. Such questions you find. Now, what are the questions? A symbol is given to you and the name is asked. I have told you after atomic number 100 you can decide the symbol and name of element. How? You name the number. 0 is named as nil, 1 un, 2 bi, tri, quad, pent, hex, sept, oct, n. Now suppose I have an atomic number which is, let's say, 114. So what will be its name? So above 100 we can use this rule. The rule says, what is 1? 1 is un. What is 1? 1 is un. What is 4? 4 is quad. Add a suffix called IUM. This becomes your name and this becomes your symbol. Now these are actually questions, my friend. Now, okay, yeah, fine. Okay, Mr. Mystery. Now these are questions. So many questions you find. So let us attempt this question. The question says, if IUPAC name of an element is un as in 1 again un as in 1 em, then the element belongs to nth group of periodic table. The value of n is, okay, now atomic number you have known. This atomic number belongs to some nth group, sir. We know 118, that means it will be 7th period, because last element is 118. So 118, 117, 116, 115, 114. That means this is 18th group, 17th group, 16th group, 15th group, 14th group, and 13th group will be 113. So definitely it will be a P block. It will be an F. After that, D block is filled. I'm sorry. This will be a D block element, because here P is finished, 13th group. So 12th and 11th, because this is 112, 111. So this is 11th group. What block? D block. What period? 7th period. So used this also, the IUPAC nomenclature of elements also, and their position in periodic table also. I hope we are clear with this. Now moving to the next topic. The next topic is, whenever you fill some electrons, the atomic size varies. We definitely know atomic size increases down the group, and atomic size along the period it decreases. Why does it happen? Because electrons are filled. Once you go down the group, electrons are filled in the next shell, but sir, protons are also filled. But actually the inner shell electrons provide a shield between nucleus and valence electron, that is termed as the classic shielding or screening effect. Now let us say this is the nucleus having proton attracting electron. This is first, second, third, and let's say this is our valence shell. So distance of nucleus from valence shell becomes your atomic size. Now because this is valence shell, so this electron will not be getting attracted by the complete attraction force offered by the protons. Why? Because the inner shell electrons also provide shield. For example, if this is the valence shell, the shell which is next to the valence shell is called penultimate shell. The shell that is n-1th shell. Then the shell which is even inside the penultimate shell, that is n-2th shell, is actually known as anti-penultimate shell. So these penultimate and anti-penultimate shells also provide shielding. Why? Because these electrons are going to repel these electrons and provide a shield between attraction from the nucleus, called the shielding effect. Sir, we can calculate this shielding factor. Yes, through Slater's rule you can definitely calculate the value of shielding constant sigma, but for JEE mains level of question you should just know its periodicity. What does the periodicity says? Periodicity says that what is the effective nuclear charge? Effective nuclear charge is nuclear charge minus sigma. So how much valence electron feels attraction from the nucleus, decided by effective nuclear charge, which is number of protons minus shielding. And what is the effect of this Z effective as you move along the period, as in from lithium till fluorine we are moving along the period, although electrons are filling in the same shell, but I am saying Z effective is getting increased. Why Z effective is getting increased? Look at this value. Z effective is getting increased. It is getting increasing because the value of shielding, the value of sigma offered by the valence and penultimate shell is as you move along the period, Z is also increasing, but the value of sigma, the shielding offered by S subshell, S electrons are very much symmetric. Symmetric as in you can think of that they are fat person like me. So if a fat person is standing between the camera and the board, you can't see the board. So S has a symmetrical structure, so it has very high shielding. Less than that you have P, and D has very poor shielding. F has even less or weaker shielding. So actually D and F are known to have not poor but very poor shielding effect. As a result of which, because shielding is less, therefore Z effective becomes Z minus sigma, because shielding is poor. So whenever we have poor shielding in case of D and F block elements, the effective nuclear charge increases to a higher extent. So the periodicity along the period, Z effective was increasing, but down the group you can see Z effective remains the same. Through Slater's rule we can calculate this. Through Slater's rule we can anyway calculate this, but what you should rather invest your time in is along the period. Once you see for D block element, along the period also Z effective value remains the same because shielding is very poor. But the periodicity of this Z effective is along the period it should increase, and down the group Z effective remains approximately same. And because of this we say atomic size, because Z effective is increasing. So atomic size, because effectively nucleus is attracting, so atomic size will decrease. But down the group, although protons are getting increased, but the inner shell are providing shielding. So Z effective is approximately keeping same. But sir, electrons are filling in the next shell. Therefore, size increases along the period. Even Bohr theory tells us that radius of electron in nth orbit is proportional to n square. As orbit number increases, radius increases to the square of its proportion. So radius of first orbit will be r, let's say, of first orbit will be r. For second orbit it will be 4r. For third it will be 9r. So down the group size increases, but increases to a very high extent. So whenever you have a periodicity down the group, always account for the atomic size, because atomic size increases tremendously down the group. Yes, along the period it decreases, but the value of increment is much larger than the value of decrement. Reason being is because of the value of Z effective, which you can calculate also using Slater's rule, but for mains level of question you should not. Even for advanced also sometimes Slater's rule application is used, not always. Moving to the next question now. So moving to the next question, I mean the next topic. Sir, atomic radius periodicity we have related with Z effective. Now what else? You have any measuring instrument that you will put on nucleus and put it on the valence electron so that you can find the radius? Moreover, is atom present in nature in atomic form? No sir, it is formed, it is present in molecular form. Moreover, if at all it is present in atomic form, electron is not a person who is standing so that you can measure that distance from my, because sir, you can measure this distance if I have a particle nature, and in atomic structure we have seen electron has a wave nature. So how you are going to experimentally determine the atomic radius? Therefore, theoretically we have developed some definitions of actually measuring an atom as covalent radius, ionic radius, metallic radius, and van der Waals radius. Now what is a covalent radius? If atom is forming a covalent bond, nucleus are very heavy, they are still spectroscopy, through spectroscopy we can find the nucleus of an atom. So if an atom is forming a molecule, we can find the distance between the nucleus divided by 2. Yes, it will give us an approximate value, but that approximate value will be termed as covalent radius. Similarly, if the atom is present in nature not as a covalent molecule, let's say as a solid, let's say as a metallic solid like alkali metals, like transition metals, then again you can find distance between the nucleus divided by 2, and the radius and the value, the exact value will be your metallic radius. And if at all like inert gases, the atom in nature is not forming any molecule. So how to calculate the atomic radius? Sir, you can have two atoms which are attracted by weakest intermolecular force of attraction, or weakest forces of attraction are van der Waals forces, which even takes place in a system which is attracted using London dispersion force, instantaneous dipole-dipole attraction. So let's say molecules are attracted by instantaneous dipole-dipole attraction, then you can measure the distance between nucleus of adjacent atoms divided by 2, that radius becomes the van der Waals radius. So ultimately how many radiuses we have known? Covalent, metallic, and van der Waals. Now obviously through the basic diagram, pictorial representation, you can predict that covalent radius is going to be the smallest. Relatively metallic radius will be of larger magnitude, and van der Waals radius will be much larger, because these two atoms are attracted to each other by physical forces of attraction. Now I hope we are clear till this point. Now after that, after discussing atomic radius, questions come from ionic radius as well. Now what is this ionic radius? Sir, when parent atom gives electron, it forms a cation. When parent atom gains electron, it forms an anion. If I give away and throw away my electron, like for example, this is best asked for isoelectronic species, like okay, there is a this is distributed. Okay, nitrogen has how many protons? 7. Oxygen has how many protons? 8. Fluorine has 9. Neon has 10. sodium has 11, magnesium has 12. But I am not talking of the parent atom. I am talking of their ion. So if 2 electrons are removed from magnesium, so 12 electrons become 10. Similarly, if 3 electrons are added to nitrogen, 7 electrons becomes 10. So these are isoelectronic species. So for isoelectronic species, you think by your basic common sense that magnesium is having maximum proton. That means it will have the most powerful nucleus. Nucleus do what? Nucleus attract electrons. Outer the electrons numbers are same, so who will attract those electrons maximum towards itself? Sir, the nucleus which is having more protons. So whenever you form a cation, the size of cation decreases, and whenever you form an anion, the size of anion increases because of the same logic. Some people say you do the ratio of n by p. I do not suggest any such reasons because there is again so many exceptions. So why to learn a rule which has exceptions? So common sense says if I am neutral, the parent atom, if I become cationic, I gain positive charge, my size will decrease. The more cationic I become, the more smaller I become. And if I gain electron, I become anionic. The more anionic I turn into, the larger size I will attain because of this common sense. I hope we are clear with this. Now, next is, okay, so let us practice a question from 2015. I need answer. Now this is how, after so much of discussion, now I'm ending up with a question. So let us attempt this one. I guess the comment screen is, beta बहुत जोर हिंदी लिख रहे हो हैं? ना हो पाएगा. Good. If you are writing something good, then good. If not, then also good. हाँ, answer, yeah. Chalo. No worries. So Mr. No worries. Now, I hope somebody must have got the answer. Let us decode the question. The question says ionic radii in angstrom. The values are given. Now you do not have to calculate and find the values. The periodicity will help us. That is the name of the chapter actually. In NCERT, the chapter name is periodic table. But we can very well say it is periodicity because we can calculate. Sir, 0, is it fine? Yes beta, is it perfect? It is perfect. And if you are not comfortable with the theory, then it is more perfect for you because I am discussing questions also and theory also. You do not have to read theory from anywhere else. Read this theory, but yes, repeat and revise the notes from this theory only. It will help you a great deal for your mains and even for your advanced paper. In advance you have to add a few things. Now the atomic radii, sir, we know N3 minus will have the largest size. So just check which is having the largest size. Sir, 1.71 is largest. Okay. O2 minus, F minus will be smallest. So smallest, here smallest. So obviously option C is your right answer. See? Yeah, perfect. Now, what are the factors that affect atomic size? Sir, Z effective. As Z effective increases, nucleus will attract electron. It will attract electron, size will decrease. So more be Z effective, smaller will be the atomic size or atomic radius. So let me write, because it is saying atomic size, so I'm writing atomic size. So stronger be the nucleus, it will attract electron, so size will decrease. So as Z effective increases, size decreases. Now, as number of shells increases, obviously the size is going to increase because we know Bohr theory, in fact, it increases to a proportion of square. Now, what about sigma? Sir, we have already formulated that shielding of S is strongest and D and F have poor shielding. So as shielding increases, sir, attraction between nucleus and valence electron decreases, and therefore sigma, therefore size increases. So shielding is directly proportional to, as shielding increases, attraction decreases, and therefore atomic size increases. So these proportionality for statement based question, for theoretical questions, you should know. Or else when you attempt such questions in haste, it becomes wrong. So you have to be very, very much comfortable with the theory. Now, Sir, we have formulated atomic size. That means there is no exception. But yes, obviously exceptions are there. Sir, P block nahi padna. See, the P block logics I have taken in the chapter of periodicity and chemical bonding, as I said now. As you move down the group, sir, we definitely know atomic size and ionic size. Both should increase. If you do not have to see learn the value, but yes, ionic size you have no exceptions. In general, ionic sizes have no exceptions. Whatever the periodicity says atomic size or ionic size increases down the group. See, 27, 23, 53, increasing. So no exception, perfectly good. But if you see the atomic radius, and I am talking specifically of the notorious group, 13th group, loved by JEE. Why? Because 13th group just comes after 12th group. Because group 12, nahi beta, that's what I'm telling you. I have deliberately taken everything. Black mystery. You were asking no questions. So these are all actually questions. Every slide is not one, but these questions have been repeated like so many times in one and in the other form. And after January attempt, now these things will be coming in statement. So how are you going to interpret those statements? Then you will say, sir, statement based questions or karao. Are statement based questions will have 6 or 7 types of statements. So 6 and 7 types of statements can only be well understood when you are well comfortable with the theory. I am deliberately making this attempt again and again too, because actually when I understand as a student listening to theory, then gone. Because it is very difficult to bring all the focus. Once you write, because of that physical movement, we are forced to focus. If we are not writing, we are not forcing the physical side of our body to be focused. And therefore it is all mental game, and mentally we start floating around. So obviously I understand it is quite difficult to sit and have a focused attention for a span of 8 hours, but you can make a attempt, है ना? Chalo, moving to atomic size. Why I'm saying notorious group? Because just before this group, D block was filled, and D block have increased the Z effective because shielding was very poor. So boron to aluminium, you find no periodicity, irregularity. Atomic size should increase. It is increasing also, no big deal. But now 143, 135 now. Do not learn the value, but yes, periodicity has been challenged. Why? Sir, because this is the first time in the fourth period, the 3D must be filled. So its Z effective of gallium is large enough. Sir, if Z effective is large, my nucleus is more strong, and therefore it will attract more electrons. And because it attracts more, because it attract not more electrons, the same electrons to a higher strength, and because strength increases, size decreases. So I hope that helped. So what is the logic? The poor shielding of DNF, the high increment in Z effective. I hope we are clear now. After 135 till 167, again it is increasing. Why? Because my nucleus is also strong. So that exception, that drastic change happened from aluminium to gallium, because before aluminium the nucleus was not so much increased. After gallium, it was having impact of 3D. Indium is also having an impact of 4D. So the impact, the effective nuclear charge thing has been compensated. So again periodicity followed. After that, yes, now this is also a catch here. Although the periodicity is followed, but you have to make note of this, that before helium also one special thing has happened, that apart from 4D, 4F are also filled in the 6th period. But sir, here the size is, this is, I mean, now this is a trick played by Mother Nature, that although Z effective of helium has also been increased to a larger extent, but the increment is not observable in the atomic size. So periodicity remains the same. But if you see ionization value, the ionization value from indium to helium also, normally ionization should decrease. But because its Z effective is large, so its ionization of helium is larger than that of indium. So sometimes an effect can create a cause in the value, sometimes it cannot. So when you are asked a question on the basis of this, those exceptions are very much loved by JEE, which have some logical explanation behind them. So I hope we are clear with this, that atomic size increases down the group, but whenever we have poor shielding, because of that Z effective increases, so anomality happens, and anomality largely happens in group 13 element. You should also learn this exact trend, that for group 13 element, boron has smallest size, after that gallium, then aluminium, then indium, then thallium. The exact order you should also learn, very important, very famous. Now, which of the following anion has smallest radius? Out of these options, which has smallest radius is our question. Sir, anion. So, sir, you said for ions, you should always go by periodicity. So, actually, fluorine, chlorine, bromine, iodine, as you go down, I'm still saying, as you go down, size will increase. No anomaly with ions. But here, we are comparing it with hydrogen, which is not the same group. Actually, the logic behind hydride is H minus has a size just lesser than iodine. It is even larger than bromide ion. Why? Because hydrogen H minus is having 2 electrons, and how many protons it is having? Just 1. That means those 2 electrons with stable electronic configuration is attracted by just 1 proton, and because proton is having no power, therefore size is tremendously increased. So this is an understanding for hydride ion. Although for this type of question, in this question it is only asked which of the following has smallest radius. So obviously you should know that F minus has the smallest radius, so your answer will definitely be B. This question is easy, but ultimately you should know this exact trend of halide ion and associate with hydride ion. So hydride ion is larger even than bromide ion. It is just smaller than iodide ion. A very important logic. Now, coming to ionization, atomic size we have already discussed. Atomic size down the group increases, so distance from nucleus and valence electron increases. So as you move down the group, it becomes quite easy to remove the electron, because ionization is nothing but amount of energy required to give an isolated gaseous atom and convert it into a cation. Because you are giving energy, so ionization is always a endothermic process. You supply energy, and once you keep on ionizing any atom, successive value of ionization enthalpy is always increases, whatever be the electronic configuration. Is the logic of successive ionization energy, because once you remove one electron, it becomes a positive ion. A plus will always have an affinity towards minus. If you try to remove one more electron from that species, the next ionization enthalpy will always increase. So successive ionization enthalpies always increases irrespective of electronic configuration. I'm repeating it. Statement based questions. Now, what are the factors which affect ionization enthalpy, sir? With atomic size, it is inversely proportional. We have already discussed. And as nucleus becomes, as Z effective increases, valence electrons are more strongly attracted, so it becomes difficult. So ionization value also increases. So periodicity is just reverse of atomic size. So along the down the group, atomic size increases, so this decreases. Along the period, atomic size decreases, so ionization increases. A beautiful periodicity which you should know. Now, if applying those periodicity in the block chemistry, sir, block chemistry relating with periodic table. So as the value of ionization enthalpy increases, now how it is increasing? Because we are moving along the period, but there is some dip, like boron is having less, oxygen is having less than nitrogen. Although down the group it is decreasing and there is no anomaly. So where are the question lying for us? In the anomalies. Why? Because there will be some logic. Why there is a dip from beryllium to boron? Why there is a dip from nitrogen to oxygen? The logic lies behind their electronic configuration. Beryllium is 2s2, Boron is 2s2 2p1. If you remove one electron, it will be removed from a fully filled, it will be removed from a partially filled. Removing one from fully filled will be difficult, hence ionization of beryllium is more, boron is less. Similarly for nitrogen and oxygen, because nitrogen is half filled. So these logical explanations you should know. Now if you compare second ionization enthalpy, now these all are questions, my friends. Now if you compare second ionization enthalpy, then again first and second, if I'm talking of successive ionization enthalpy, second is always greater than first, but I'm comparing second of two different species. So we can do that how? Using electronic configuration, like for beryllium and boron. Beryllium is 2s2. After removing this pink colored electron, it becomes 2s1. So beryllium plus is 2s1. Boron is this. After removing this 2p electron, boron plus becomes 2s2. Now you tell me, removing second electron is through this electronic configuration, and we can definitely see that this can be removed easily because this is partially filled and now this is fully filled. So who will have a higher second ionization enthalpy? Boron. So whose ionization and second ionization enthalpy will be more? Boron. Whose first ionization enthalpy is more? Beryllium. How you are answering this? Through simple logic of electronic configuration. Now, what is the periodicity? Periodicity we have already explained. Then in case of D block, what can you think? Sir, for D block, like for 3D series, 4D series, 5D series, what did I say? Sir, down the group, as size increases, ionization decreases. But if you go down from 3D to 4D, atomic size increases. But after 4D till 5D, actually size remains almost the same. So atomic size of 4D and 5D are approximately same. Why? Because 5D is filled in the 6th period, hence lanthanoids will be there. So Z effective will be increased to a largest extent because F has been filled, and because Z effective has increased to such a great extent, therefore atomic size of 4D and 5D are approximately same. This is lanthanide contraction, and because of this atomic size of 4D and 5D is same. And if you compare their ionization, then sir, 5D series have very high Z effective. That means removing electron is difficult, and therefore the periodicity for D block says from 3D to 4D atomic size decreases. Let us see. This is 658, this is 640. Don't learn the value, but learn the trend. But from 4D till 5D, just look at the trend. The ionization is increasing. So lanthanoid contraction has an impact that atomic size are same, but ionization of 5D elements are larger than 4D. I hope we are clear with this now. Again, using that same Z effective increment, as I was saying in the ionization value, for helium, obviously, aluminium, gallium has a, this is 477, this is 478. Increased. Why increased? Because 3D must be filled. That we have already seen. But here I was telling you that F is getting filled. So in atomic size, there was no anomaly. But in ionization, there is this is 558. See, this is 590. So what is the reason? Z effective is increased because of filling of lanthanoids. The filling of lanthanoids increased the Z effective. That created no impact in atomic size, but it has tremendously created impact in ionization. So this you should always learn. For the boron family, I would rather suggest learn the exact order, like the size I have given. I'm giving you the ionization trend also. So I'm not asking you to go and learn one shot somewhere else. Learn these notes again and again. You have to revise whatever things I'm saying, that you should learn those things. At least learn these things by revising these of my lecture notes. So what is the exact trend for ionization enthalpy? Lowest is of indium, then aluminium, then gallium, then thallium, then boron. You can make any mnemonic trick also, but learn the exact trend of group 13 element, atomic size also, ionization enthalpy also. Now, some questions to practice. That obviously we can see that this is 1s2 2s2, so we are linking it with ionization enthalpy because everybody is we are comparing of the second period, so this is along the period and the values of ionization enthalpy. So ionization enthalpy along the period, we definitely, what is the periodicity? It increases. So because this is 2s2, that means it is just starting. This is 2p1, so that is 2s2, but 2s2, remember, fully filled configuration. 2s2 2p1 half filled, so we should have, because it increases along the period, so we should have lowest value. Sir, S should have lowest value. What is the lowest value that you see? 801. So S should be 1. Which option says S is 1? Option A. So see, if you are very much comfortable with your theory, this is how you make a question correct. Now what will be your answer? Just by looking at one option, you can, what about the other options, sir? Obviously this is second period element. For second period element, we have even drawn the graph, we have even seen the graph. So that is why I am saying, instead of focusing on more and more question, please focus on learning the relevant logics. Don't treat it as a theory. These are the logics which you should be very much comfortable with. Then only you are going to finalize those statement based question and not fear out of it, because you are anyway, with reading more and more, you are also increasing your power of interpreting the question, reading the questions. I hope I'm making sense with that. Now going to the next periodic property, which is again very important, electron affinity. So what is electron affinity? If an isolated gaseous atom accepts an electron, then energy is generally energy is generally released, and the amount of energy released is known as electron gain enthalpy. Negative of this is called electron affinity. So the electron gain enthalpy is an enthalpy change. So because it is an exothermic process, so generally it is negative. And what is electron affinity? Theoretically it is same, but mathematically it is negative of this. So electron affinity is affinity of nucleus to gain an electron, which is obviously nucleus always wants to gain an electron, with some exceptions like nitrogen. Because nitrogen is second period element, so size is very small. Because nitrogen is having half filled configuration, so it would rather try not to disturb its stable electronic configuration. Therefore for nitrogen, electron gain is positive, or else electron gain is generally negative. What is the periodicity? Same as that of ionization, so it is inversely proportional to electron affinity. Okay, I'm sorry, this should not be electron affinity. I'm sorry, this should not be electron affinity. Yeah, so with atomic size, okay. No. Actually I have taken electron affinity instead of electron gain enthalpy. So periodicity wise both are same. Yes, I know there is a change of sign, but that sign you should not think of like mathematical justification. Like for example, if I am an atom and I am releasing energy, let's say 500 kilojoule, and if somebody is releasing energy, let's say 1000 kilojoule, then you will say who has more electron gain enthalpy? The negative sign you will not watch, because delta H is negative, that means process is exothermic. So for such thermodynamic cases, minus and plus should not be taken mathematically. Minus means energy is released, plus means energy is absorbed. The magnitude you only see to calculate, to predict and periodically answer that whether somebody has higher ionization or higher electron gain. You should just focus on the magnitude. I hope we are clear with this. And whatever periodicity electron gain will have, obviously the same periodicity electron affinity will have, and therefore what I'm saying is that atomic size and electron affinity are inversely proportional, because if size will increases, then nucleus is more distant from the valence shell, so it will rather be difficult for the nucleus to attract the incoming electron. Similarly, if there is more and more screening, the nucleus attraction will decrease, and therefore electron more screening, so electron affinity will decrease. That means the periodicity of ionization is same as that of electron affinity. Finally, more be the Z effective, obviously more be the electron affinity, because now you are providing more power to the nucleus. So the periodicity of electron gain enthalpy is similar to that of ionization. Along the period increases, down the group decreases. Generally it is negative, yes. For inert gases it is positive. For alkaline earth metals, not alkali metals, for alkaline earth metals it is positive, and for nitrogen it is positive. Yes, for whole nitrogen family value is less because they all have half-filled configuration, but for only nitrogen it is positive. Some very important conclusions. Moving forward, there is one more periodicity change in the periodicity of electron gain, which is for second period element there is always an anomaly, because second period element is not small, it is very small. So because we know electron gain enthalpy decreases down the group, so who should have highest electron gain? The first element. But fluorine do not have highest electron gain. Instead of fluorine, chlorine has highest electron gain. Oxygen do not has highest electron gain. Instead of oxygen, sulfur has highest electron gain. Nitrogen do not have, in fact leave nitrogen because nitrogen has positive. So a very famous question for oxygen and fluorine, that why oxygen and fluorine have, they should have maximum electron gain, they are electronegative also, but still they have they do not have highest. The element next to below them has the highest. Why? Because they are very small, and because they are very small, so whenever an electron is actually trying to enter, whenever an electron is actually trying to enter the already present electrons, they provide repulsion because space is very less. So the electron repulsion compensates for the nucleus attraction. Nucleus definitely want that electron to be coming inside, but at least in order for that electron to come inside, I should offer that electron some place to sit. Because of the small size, electrons are already filled and there is no as such available space for the incoming electron. Therefore, for second period element, the electron gain is not substantially large, rather the element below them attains the highest electron gain enthalpy in their respective group. A very important conclusive question for all your papers. Now obviously I have written that, given you this. Obviously who know this can skip the slide. If you do not, this is a type of question for you. Moving forward, now a question to practice. The question says the formation of oxide requires, okay, so oxygen is taking an electron and forming O minus. Sir, ultimately electron gain is taking place, so it is exothermic. But whenever O minus is served with one more electron and you are actually forming the oxide, sir, minus minus repel each other. Remember, successive ionization always increases, similarly successive electron gain. So when you try to give electron to a negatively charged species, or minus minus repel each other. So if at all you are trying to add the second electron, the second step will definitely be an endothermic process, because then you have to force this electron inside. The overall reaction will decide, the overall value can be calculated once you add the reaction. So the statement is asking you that this is why this second step is endothermic. So why this is endothermic? Because O minus has, this is nothing has to do with size. Oxygen has nothing has to do with electron affinity. Oxide ion, yes, oxide ion will tend to resist the addition of another electron because minus minus repel each other. Therefore answer will be beautifully option C. Again, a logical question. The question says ionization potential of sodium would be numerically the same as. Now, ionization potential of sodium. So sodium, given energy or given potential, forming Na plus, giving out one electron. So this process will be ionization. Energy potential by potential is equal to work done upon charge. Work done is nothing but energy, so potential is equal to energy upon charge. So if you have energy, the proportionality will be same for potential also. So this is ionization. If I do the reverse process, then it will actually be electron gain, but by whom? By the cation. So ionization of sodium will be same as that of electron gain by this cation. Magnitude wise it will be same. This will be an endothermic process, so this will be an exothermic process. If I give 100 rupees, it will go forward. If this gives 100 rupees back, it will come backward. So magnitude is same. So this is electron gain of sodium cation. Electron affinity of Na plus, electronegativity no, electron affinity of sodium no. Obviously option A is your answer. I hope we are clear with this. Now moving to electronegativity. Now electronegativity is not a property, it is a tendency. Therefore, you can mathematically and experimentally calculate ionization, electron gain thermodynamically. But electronegativity is not a property which you can experimentally measure. Rather, it's a tendency that this tendency also can only be defined whenever an atom forms a covalent bond. Like in the redox chapter, we have done that whenever a bond is formed between two atoms, the more electronegative atom attracts the shared pair of electron towards itself. So how that tendency has been quantified, because it's a scale, it's no property, you cannot measure it. It can be estimated. Electronegativity of one atom can be estimated with respect to another atom. So it's a relative tendency, not a property, point number one. And because electronegativity is also a property of attracting electron, therefore it also has similar periodicity as ionization and electron gain. I hope we are clear with this, because electronegativity itself means how much nucleus wants to attract electron towards itself. So periodicity goes the same, therefore it is inversely proportional to atomic size as ionization and electron gain. But yes, it is directly proportional to Z effective, but this is the point because of which I'm mentioning it. NTA loves this logic, that as S character increases, like especially for carbon, because when you have orbitals which are hybridized, as S character increases, we definitely know that penetration of S, if a shell has different subshell, then who has lesser energy as per Aufbau rule? Sir, NS. Who has larger energy? NP, then ND, then NF. So actually, because S has lesser energy, which also signifies that penetration of S subshell is closer to the nucleus. Therefore, nucleus will have more dominance, and nucleus will try to do what? Nucleus will try to attract electrons. So whenever you have more S character, electronegativity will be more. So electronegativity is directly proportional to S character, and therefore a carbon having sp hybridized is more electronegative. Carbon having sp3 hybridized is obviously less electronegative. The electronegativity which I have written over here is on Pauling scale, one of the very famous scale in which we quantify electronegativity with respect to another species. Now, one more thing, sir, if some species is having positive oxidation state, so more be the positive oxidation state, more be the electronegativity, because more plus will try to attract more electrons and more electronegativity. Like for example, if I have manganese in +7 oxidation state and it is forming some oxide, if I have a metal in +2 oxidation state and let's say it is also forming an oxide, so ultimately oxide or any compound or any cation having more positive oxidation state will have more affinity towards electron and will have more electronegativity, implying to a conclusion that electronegativity is directly proportional to oxidation state. Some very important conclusions for direct questions. I hope we are done. Now speaking of oxides, so now we can list the periodicity of oxides as well, because we know that metal has electron giving nature. Electron giving nature is of a base, so metal oxides and hydroxides are basic in nature. Similarly, in an inverse format, I can say electronegative or non-metallic species are those which have property to gain electron. Property to gain electron in terms of acidic basic nature is the acidic nature. Base is someone who gives electron, acid is someone which gains electron, and because generally non-metal have this property, so non-metallic oxides and hydroxides are generally basic. There are many oxides which are amphoteric because they react with acid also and base also, but here some of the amphoteric oxides I have listed, but the best possible way to learn the amphoteric oxides are through this rhyme. What is the rhyme? Rhyme is Suno Janabe Ali. Rhyme is, I have already written the rhyme. Suno Janabe Ali. और उनके is nothing but it is just for the story. Bekar Bhai. Now who are these Bekar Bhai? Bekar Bhai are just the element below these Suno Janabe Ali. Below SN we have PB, Kashi gas Shankar Parvati, zinc, cadmium mercury, बैगन आलू गाजर. So सुनो जनाबे आली और उनके is nothing just for the story. बेकार, and what are those bhai? Bhai is the element just beneath these three elements. Apart from them, who else are amphoteric in nature? Sir, apart from them, let us complete the story. सुनो जनाबे आली और उनके बेकार भाई. After saying that बेकार भाई, you say to those बेकार भाई, you say as in you watch what? Watch as in sub TV. So as in sub as in antimony, TB, T as in tellurium, V as in vanadium. So these all oxides in the given oxidation states are amphoteric. Yes, there is a catch for chromium. Chromium is only acidic in +3 oxidation state. If you rather have chromium in +2 oxidation state or maybe in +6 oxidation state, from +6 oxidation state chromium will try to gain electron. So gaining electron is acidic nature, so chromium +6 is not amphoteric, it is actually acidic. +2 wants to become +3, so it will try to give an electron, so giving electron is actually basic nature. So if somebody is going to ask you that chromium is amphoteric in what oxidation state, actually it is +3. Now also there is some fight between for vanadium, because vanadium is +5 oxidation state. If somebody is snatching your neck, then yes, if you observe 1000 reactions of vanadium, then maybe 600 reactions it shows from acidic side of it nature. So it is more inclined towards it is more showing prominent number of acidic reactions. But yes, logically speaking, as per good references, I'm directly mentioning as per J.D. Lee, which is actually, I mean, Advance also loves it. So as per those generals, vanadium should be considered as an amphoteric oxide. I hope we are clear with this. Now, that Hindi, somebody is like writing Hindi. What is the question, bro? Sir, hi, the meaning of it. We don't know the meaning of that Hindi. Okay, beta, that is only just a story. See, Ekaf, I mean, this is just a story. The story I have built, the mnemonic is a story. Suno Janabe Ali और उनके is nothing. बेकार bhai are the elements just beneath them. And what do you say to them? As in watch sub TV. So as in will give you AS, sub is antimony, TB is tellurium, and T will help you remember tellurium, and V will help you remember vanadium. So this is just a rhyme to remember the amphoteric oxides, the amphoteric metal who forms amphoteric oxides, because there is no other way around. Now, after that, let us summarize the periodicity that we have seen. Obviously, the periodicity says that atomic size along the period, let us now complete this. This finishes our periodic table. Atomic size along the period, sir, along the period, atomic size decreases. Down the group, atomic size increases, but this increment is large. Effective nuclear charge, nucleus must be getting stronger, that's why it is decreasing. So along the period it increases, yes, but yes, down the group Z effective remains approximately same. I'm not talking for D block elements in general. Now along the period, because atomic size has inverse relationship with ionization, electron gain and electron affinity, so along the period it should increase. Down the group it should decrease. Now, metallic nature, sir, this is electronegativity. So, electropositivity will also be inverse of electronegativity. So, because electronegativity is gaining electron. So, as we move down the group, size increases. So, I will try to give more and more electrons. So, down the group, metallic nature increases, and therefore, along the period, it should decrease. Now, these summary is just the essence of periodic table. What about acidic oxide? Who forms acidic oxides? A non-metal. Where do you find non-metal? Sir, when you move along the period, so over here it increases and down the group it decreases. Rather, as you move down the group, base is somebody wants to give electron, metal wants to give electrons. Therefore, down the group metallic nature increases, so basic nature of oxide increases, and along the period it should definitely decrease. This finishes our periodicity logic and brings us to actual application side of inorganic chemistry, which is chemical bonding. So I'm starting chemical bonding because we have to finish bonding also, and after that we'll take a break for D block and coordination. So let us finish chemical bonding. The chemical bonding, I mean, logically speaking, chemical bonding, sir, I wrote my, okay, let me sip some water and then let me take some questions, because during periodicity I was not taking question because yes, this was a theoretical topic, but those theoretical topic is very much asked in NTA. So I've taken all those logics also. You can, by the time I can read some comments. Sir, I wrote in my board examination that ionization decreases. Today I have state board chemistry. I wrote this to get, do I get my beta? In general, even ionization down size increases, so ionization definitely down the group ionization decreases. I was saying that for D block elements, for D block element ionization, periodicity, for D block element all the periodicities, I mean, obviously challenged. In general, you have not written wrong. For P block elements, for S block elements, in general, ionization down the group decreases because atomic size increases, so it becomes easy to remove electron. So it is not wrong, Ekaf. Don't worry. Okay, the question was why? So all the factors, Z effective, size, Z effective, size, number of shells. That's it. What all the factors that we have seen. Yes, aspirant, my advice to you is that study as much as you can, maybe from this live, maybe from the previous lives that we have, and attempt more and more PYQ so that you are more and more comfortable with the theory. Okay, chalo. Tanish Kharde is saying, what if increase the amount of everything? Of everything as in? Suman, hi. Aspirant list, hi. Chalo beta, let us start. Ekaf, what was screening effect? Beta, I have invested so much. See, screening is basically this. Screening in the Suman, in the class, sir. Okay, I didn't get you. Okay, Ekaf, sorry, who was saying about idli? Yaar, Anuj, idli effect. I do not know what is this, but still, as energy. Okay. So, who was asking that screening? Ekaf, like I am standing in front of, I am, camera is nucleus, these are valence electron, I am inner shell. So if I come close, can you see the board? No. That means I am providing shielding between you, that is camera, that is nucleus, and valence electron. So as shielding increases, the attraction between nucleus and valence electron decreases, and because it will decrease, size will increase. This is shielding. That's it. Now moving to moving to chemical bonding. So chemical bonding says, ultimately, why two atoms exist in nature as a molecule? Because they want to pair their unpaired electrons. How to pair these unpaired electrons? Sir, orbital overlap take place, which is happening in accordance with valence bond theory. But how we have came to this conclusion that valence bond theory exists in nature? Because whenever two atoms approach each other, obviously the nucleus will have repulsive force, but nucleus and electron of other and nucleus and electron of other will have attractive force. So definitely the attractive force must be larger in magnitude than the repulsive forces. That is why atoms are coming closer to each other and existing in nature as molecules. So when we have when we have plotted this energy graph, experimentally we have observed that whenever two atoms approach each other at a specific distance between their nucleus, they attain a minimum energy, and that minimum energy is then known as their bond energy, because this much of the energy they have released, and therefore because as a system they have released energy, so their energy has been reduced. If the system energy is reduced, that means the stability of the system has been increased. So if you give that energy to that molecule, obviously the molecule will break open. But this we have known using the logic of VBT, which says that two atoms combine each other in order to pair their unpaired electron, and in order to pair their unpaired electron, overlapping of the orbitals will take place. But this VBT knowledge came to being after the development of quantum theory. So that means before the development of quantum theory, nothing was said about atomic structure, nothing was said about chemical bonding. Yes, some theory have been developed before the development of valence bond theory, and those theories are called the octet rule, which were obviously formulated as per the initial offering done by the scientists, that what all elements exist in nature which show no chemical reactions are inert gases. So people saw what inert gases have in them. They said that they have inert electronic configuration. So it was predicted that atom combine in nature to form inert configuration called as the octet rule. They want to complete their octet or doublet. This VBT came to nature after the octet rule has been violated. Sir, then why you are telling us octet rule? I'm just discussing that octet rule initially because you find few questions through that octet rule as well, so devoting a few time for them. Now, so whenever species attract each other, they come in close proximity to each other, and they form a bond which is known as a chemical bond. If the chemical bond formed is strong, then energy released is somewhere around 200 kilojoule. If the chemical bond formed is weak, then weak bond are also formed. Then the energy released is approximately 1/10. So what are these strong chemical bonds? The ionic bond, covalent bond, chemical bond, and metallic bond. Ionics form due to transfer, covalent due to sharing, coordinate when one gives electron to another, donate electron, so dative bond. And metallic bond is when covalent bond is formed by the metallic species, as in those atoms which exist in nature as metal. Whatever unpaired electrons they have, unpaired electrons do overlapping as per VBT that we know, but those bonds in case of metallic atoms are termed as metallic bonds. Weak forces like hydrogen bond and van der Waals forces of attraction, which we'll be just discussing in few slides. Why? Because states of matter chapter has been removed, but hydrogen bond and van der Waals theoretical question, the statement based questions, are very famous for JEE. So these are the two basic types of chemical bond, the strong one and the weak one. Sir, we definitely know, you have explained us that as per VBT, overlapping takes place. How much, what are the different types of overlapping? Before octet rule, let me finish this also. What are the different types of overlapping? Sir, head-on overlapping is sigma bond. Sideways overlapping is pi bond. But there is one more type of sideways overlapping, because through atomic structure, we know we have d orbitals also. So when d orbitals have sidewise overlapping, the number of lobes which overlap sidewise will increase, because P has how many lobes? 2. D has how many lobes? 4. So sidewise overlapping is less effective. But if even lesser effective, if 4 are having sidewise overlapping or 2 are having sidewise overlapping, where the effective overlapped area will be more? When 4 will have. So actually when D sidewise or laterally overlap with each other, what is formed is a delta bond. So extent of overlapping explains us that sigma is the strongest. After that, the delta overlapping, and the least is the pi overlapping, which is sidewise overlapping or lateral overlapping of p orbital. This delta is not much famous, but you should know this delta overlap also. Moving to so a question which helps us to know chemical bond as per the basic theory, as per octet rule. So in which of the following you find ionic, covalent as well as coordinate bonds? So obviously we can see the NH4Cl will form ammonium cation and Cl ion. So obviously this is ionic bond, plus minus attraction. But if you see ammonium ion is made of NH3 reacting with H plus. What is NH3? NH3 has nitrogen making 4 covalent bonds with hydrogen. So it is having covalent bond also, ionic bond also. How NH3 and H plus are associated with each other? When NH3 coordinate its bonds to hydrogen, then ammonia forms ammonium cation. So definitely this NH4 plus will have an impact of coordination bond also. So ultimately ammonium chloride has both ionic, covalent within ammonia, and coordinate within ammonia and HCl. Therefore obviously this has all the 3 bonds. What about NaBF4? Sir, obviously this is also Na plus and BF4 minus. So this has given electron, this has taken electron and completed their octet. So ionic bond is there. Again, if we check BF4 minus, so it is formed when BF3, covalently bonded BF3, because boron is having incomplete octet, so it will rather want F minus to give away the lone pair. So a coordinate bond is again formed. That's why BF4 minus can also be formed. So this also has ionic, covalent within BF3 and coordinate within BF3 and F minus. So this also has both the bonds. So option this is also right, this is also right. What about CH3CN? This is no ionic compound, so it will not form because carbon is not ionic. Carbon forms covalent compound. So this is the 4th bond with nitrogen. Nitrogen is a second period element, so will complete it octet. This is isocyanide, and because this carbon octet is not complete, so this nitrogen will rather coordinate. So it has covalent and coordinate, no ionic bond. Therefore this is not an answer, because A and B both are answers. Option 4 will be a right answer. Quite a good question. Yeah, perfect Tanishq. Now I would rather see, guys, I'm rather suggesting you, because I'm covering IOC, all of us know it is theory na. So I giving questions, you can already do that. Open any book of PYQ, you will find number of questions. What I'm actually trying to achieve from this live, from this 8-hour live, is give you the explanatory science as well, because explanatory science for completing all the chapters of IOC in one day is more than sufficient. This IOC is going to make 8 to 10 questions, because here we have discussed atomic structure also, redox also, and mole concept also. So from there and from these IOC topic, more than 10 questions, maybe 11 questions you will be getting for your mains. So this is almost 40% of your chemistry today. So that's why I'm investing. So please, whoever are falling, feeling, sir, I need questions, because question I give, you practice, you do. Even if you are focusing less, once your hand starts moving, your focus comes. So please drink water, jhatkofy your head. If at all concentration is getting weak, please invest yourself with me. Now, yeah, moving forward. So again, the next question says, choose the incorrect order of bond strength. So how to choose the incorrect order of bond strength? Here we have already seen that, okay, these are pi bonding. So, sir, what bond is more efficient? Definitely, first of all, the value of principal quantum number must be less. The orbital which is having lesser principal quantum number will definitely have effective overlapping. Like for example, 3 plus 3 is 6, 2 plus 3 is 5. That means they are more energized. So more energized will be, obviously more energized orbital will be more diffuse, more away from the nucleus. So their overlapping will be less effective, because whatever orbitals are of lower energy will form effective overlapping. So these are of effective overlapping. So this is obviously correct because it is correct, and we are asked incorrect. So because this is correct, so not an answer. I hope we are clear with this. Now this one, this is 3 plus 3 6, this is 3 plus 3 6. Now the principal quantum number is same. Now just go to them. We have seen that PP are 2 lobes, DD are 4 lobes. So 4 lobe sideways overlapping is more efficient. So this is also correct. So not an answer. I have explained you this. Now 3 plus 3 is 6, 3 plus 3 is 6, 2 plus 3 is 5. So these are of lesser energy subshell, so having effective overlap. So definitely this is also correct. So not an answer. So ultimately, first I'm watching the principal quantum number. 3 plus 3 is 6, 3 plus 3 is 6. Now you can compare PD overlap and PP overlap. Sir, PP overlap will be less because P and P both are having 2 lobes. P and D, at least one P has 2 lobes, but D has 4, so overlapping will be slightly higher. Yes, DD will have much higher, but PD will also have higher than PP because P has 2, P has 2. D ultimately has 4, so 4 sidewise laterally overlapping with 2 is effectively more. But it is saying PP is more, therefore this is wrong and hence an answer. I hope it is clear to us. Yeah, perfect. Now Ekaf, start answering whenever question comes. So Ekaf, good. I understand the reason that you are asking more and more questions. That is the hunger in a student should have. But Ekaf, today we have some agenda na, hai na? I hope you understand. So for all of you who want more questions, please go and do PYQs directly after doing this live. You will be finding those questions doable like anything. The amount of confidence that you will be having inside will be huge. So revise this also, and you will be very much comfortable with the content. Yes, first check principal quantum number, because ultimately you should first check the energy level. Yeah. This I have already explained why I have given this in slide, because for those who like Ekaf is asking, so I have designed these slide in such a way that it is going to help everybody. Moving to the next question. Now this is again a question, explain a statement based question. So there will be some theory. So why I should make that theory? I should give everything to you. Now, order of bond energy, now you have to explain that chlorine, bromine, fluorine and iodine. So down the group, you said atomic size decides everything. Yes. So down the group, as you move down the group, sir, atomic size increases. So because atomic size increases, so bond length increases. So as bond length increases, it should become easy to break the bond. So the amount of energy that is required to break the bond is termed as bond energy. So amount of energy required, because atomic size is increasing, bond length is increasing, therefore it should decrease. So what is the expected order? Expected order is fluorine should have highest, then chlorine, then bromine, and iodine must be broken very easily. So we are expecting that it should decrease. So you should have maximum and you should have minimum. What is the actual order? Actual order is chlorine, bromine, the fluorine which we were expecting, to come first is actually coming third, is the only exception. Now what is the reason? Actual reason is, once you actually, this atomic size trend is valid for bond dissociation generally. Is it not valid over here? It is still valid. But for fluorine, one more effect is coming into place. And what is that effect? That these halogens are not any simple atoms. Group 17 are the only atoms which are having 3 lone pair in their valence shell. Don't we know that lone pair have very high repulsion? And because these lone pair have huge high repulsion, so that small size is bringing those lone pair much closer to each other. Sir, minus always repel each other, and thus because of these lone pair repulsion, we expected fluorine to have highest bond energy, but it is not having least, by the way, because ultimately size is increasing. So because iodine is so far apart from each other, bond length is so large that iodine still breaks very easily, but fluorine comes third. So instead of first, it comes third. A very important conclusion. I hope we understand this. Now, moving to the formal charge calculation, so I would rather say you do not read this formula, although this is an NCERT logic, so I have given this formula, but I'm saying you do not read it. Why? Like for example, I have this ozone, so you can draw the Lewis structure of ozone. How, sir? Oxygen double bonded with oxygen. Now, how to bond the third oxygen of ozone? Sir, oxygen is having 6 electrons in its valence shell. Give coordinate bond to this oxygen. Why? Because once you give coordinate bond, octet of this will also be complete. Now, the coordinate bond how can be thought just like a covalent bond. So, sir, make it a covalent bond. Okay. You can also just replace the coordinate bond with a covalent bond. But once you replace a coordinate bond with a covalent bond, just do this thing. Give a positive sign to the donor atom and give a negative sign to the acceptor atom. Why? Because let's say this is Chunnu, this is Munnu. I have given Chunnu, let's say this is Chunnu, this is Munnu. I have given Chunnu is here, Munnu is gone from atomic structure of central oxygen. One electron is gone from central atom of this oxygen. So electron gone means plus, extra electron came, that is minus. Now you see the partial charge. Why to apply formula? So what is if I have made the structure as per the formal charge calculation, but I'm not using the formula. What is formal charge on this oxygen? Says 0. What is formal charge on oxygen number 1? +1. What is formal charge on oxygen number 3? -1. So why bother writing and learning this formula? The chemical bonding logic will always help you. I hope we are clear. Now, to be honest, actually, I don't know any ideas after hearing your class because of your teaching. Just hook me. Okay, okay. Thank you, Laksh. Okay, perfect, Ikaf. Work for every question. I eventually saves our time. Is correct all time. We can use the shortcut, sir. हाँ बेटा. Tanishk, that's what I said. Instead of using the formula, use the common sense and make the structure, and common sense is going to help you. Now, okay. So octet rule is based that you should have inert electronic configuration. On the basis we have covalent bond, ionic bond, coordinate bond, but obviously it has exceptions. What exceptions? Exceptions like many molecules were existing in nature which are which are having less than octet, like BCl3, BF3, the Lewis acids. Many molecules you have which have bonds having more than octet, like PCl5, SF6. So octet rule can't explain it. There are existence of odd electron species. So if electrons are all getting paired, then odd electrons should not exist. So these things octet cannot explain. Inert gases, compounds were obtained. Octet rule was entirely based on the concept that inert gases do not form compounds. Compounds of xenon are known to nature. Then after their existence was discovered, octet rule was completely blown. And obviously octet rule gave no information about the geometry, which was only given once VBT was formulated. Now why I am giving that limitation? Because obviously the JEE serves you some questions like number of molecules from the following which are exceptions to octet rule. So which are having exceptions to octet rule, let us tick them. CO2 has complete octet, so no. NO2, yes. Nitrogen, double bond O and coordinate bond O. So there will be an odd electron on nitrogen. So yes, according to octet, this should not be existing. So this is exceptions of octet, as in this is not in accordance to octet. H2SO4, sulfur will have 6 bonds. So this is also an exception. BF3 less than octet, so exception. Methane is perfect. Silicon is perfect. ClO2. double bond O, and then coordinate bond O. Chlorine has 7, so this also has odd electrons, so this is also an exception. PCl5 is more than octet, so an exception. BF2 is less than octet, so exception. This is carbon compound are always completely octet filled, so no, no, no. So how many tick I have? 6. 6 is my answer. So these are some questions. If you just look at the questions, they are quite doable. But if you combine it with a statement based question becomes tricky, and that's why I am discussing all the possible statements that who can make, that NT can offer you. So discussing every detail. Now again a similar question. So which of the following pair contain odd electron and an expanded octet? So you should have odd electron. So NO has odd electron and H2SO4 has expanded octet. We have already done this. Sulfur forms 6 bonds. What is Born-Haber cycle? A conclusion of periodic table also. Born-Haber cycle tells us how to apply Hess law, which is energy conservation. For example, NaCl exists in nature as solid formed by sodium solid and chlorine. Chlorine in nature exists as Cl2 gas. But how much chlorine you need? Half mole. So what is the amount of energy released when 1 mole of a solid is formed by in nature through its constituent in their most stable state? Sir, this is the definition of enthalpy of formation. So enthalpy of formation, which is this, is equal to first sodium changes to sodium gas. So what is solid changes to gas? What is this process called? Sir, sublimation. What type of process? Sublimation is, sir, endothermic. So we supply energy. So this becomes 1, which is an endothermic process, plus now so isolated gaseous atom will give 1 electron, known as ionization enthalpy. So sodium will get ionized and form sodium cation in the gaseous state. So this becomes step 2, which is again an endothermic process. Now I have Na plus waiting for Cl minus. How Cl minus ion is formed? First you have to break Cl2. Cl2 has bond Cl bond Cl has bond energy, so you have to supply bond energy to break chlorine molecule and form chlorine atoms. So what is the enthalpy change? Known as bond dissociation enthalpy. But 1 mole bond dissociation enthalpy will break 1 mole of molecule, and 1 mole of molecule will create 2 mole of atom. I need 1 mole of atom, hence using half mole. So this becomes third process, which is also endothermic, because here also we supply energy. Now after gaseous chlorine is formed, the electron given by sodium is gained by chlorine and formed chloride ion. So this process will be electron gain. Now this process will be an exothermic process. So this becomes the fourth step, which is an exothermic process. Once you have Na plus and Cl minus in gaseous state, plus minus attract each other, and because of attraction they come close to each other and form a solid. So gas have high energy, solid have lesser energy. Where energy is released, it is released in form of lattice. So delta H lattice becomes the fifth process, which is also exothermic. So enthalpy of formation will be equal to these 3 endothermic processes plus these 2 exothermic processes. In questions, what is done is some of the value is hidden from you and it is turned into a variable. Other values are supplied to. Let's say this is the question will hide one of the value, will supply other values, and you have to find the answer. Very probable question for JEE. I hope I am done with Born-Haber cycle. Now coming to Fazan's rule. Now what is equation for estimation of beta? See, actually, yeah, if you just go to the one shots of chemical bonding and thermodynamics of my one shots also, there can be n number of additions which can be added to a theory, but rather learning them will always have an edge for such questions which are asking you to move one step higher. In general, we are discussing at this point of time with the one shot, we are discussing all the probable logic. So obviously I am restricting myself to discuss anything in that detail which is valid for good level of topics. So these all are logics also. and high probable topics also for your NTA April attempt, JEE Mains April attempt. Now, coming to the next important logic, which is Fazan's rule. Now, Fazan's rule says what? Fazan's rule discusses that even you have a covalent compound or even you have an ionic compound, none of the compound is completely covalent or completely ionic. But we apply Fazan's rule only to check whether an ionic compound, as in you have an ionic compound, but that ionic compound can also have covalent nature. So the percentage of covalent nature present in an ionic compound is estimated using Fazan's rule. How, sir? Let's say you have a cation and you have an anion. In general, we know cations are smaller, anions are larger. So as the size of cation decreases, the distance between nucleus of cation and electron of anion is, you can obviously observe this distance is lesser. So don't you feel this plus will also attract this minus? Yes. And once this nucleus of cation starts attracting the electron of anion, these electrons starts polarizing, starts accumulating closer to the nucleus of cation. Because electrons start accumulating here, that means electrons are not present here, they are present over there. So this partial distribution will do what? It creates partial negativity here and partial positivity here. So this is nothing but polarity. That means this electron is listening to this nucleus also and this nucleus also. This is nothing but sharing of electron. Therefore, this polarization brings covalent nature in this ionic compound. So how this covalent nature is increasing in an ionic compound? Point number one. So how this covalent nature is increasing in the ionic compound? Once you compare the polarization power phi of the cation. Polarization power is largely dependent on charge. Once charge is same, then you should go for size. So phi is basically charge upon size. The primary factor is charge. So polarization power of cation decides the polarizability of an ion. How the polarization power of cation will increase? So definitely we know, as or if you just compare size of cation, so as size of cation decreases, polarization power of cation increases. Because polarization power of cation increases, so ionic character, the covalent character in that particular ionic compound will increase, and because covalent character will increase, therefore ionic character will decrease. Simple. Similarly, if I apply the same logic over here, because here charge is same, so definitely first you have to think about charge, but because charge is same, so let us compare it with size. The anions are same, this has different cation. Which cation is smaller? Sir, Li plus is smallest. Because it is smallest, so its polarization power will be highest. Because its polarization power will be highest, so its covalent character will be highest. So order of covalent nature will be, it will have highest covalent nature, and CSCl we have least covalent nature. These all are independent questions of your JEE. I hope we are clear with this. I hope we are clear with this. Yeah, perfect. Perfect. Now, what about charge? The more dominating factor, sir, it is. So as charge increases, I'm not discussing about size because I'm comparing charge now. So as charge increases, phi also increases. As phi increase, polarization power of cation increase. As polarization power of cation increase, covalent character increase, but ionic decreases. Like for example, here also anions are same. So let us compare cation. Cation is having +1 charge, cation is having +4 charge. So as positive charge is increasing, polarization power of cation is increasing, therefore this will be highest covalent, this will be least covalent. Highest covalent is this, so highest ionic will be NaCl. I hope we are clear with this. Yeah, perfect. Now sir, anions also, yes. What anion has to do in order to become covalent? It has to let go of its electron, as in it has to get polarized. How it can get polarized? Sir, if larger be the anion, easily it can polarize because it will have less impact on its own electrons. So as the size of anion increases, polarizability, as in polarization of the anion ability, will increase, as an anion will be polarized easily. As anion will be polarized easily, cation, it will be easier for the cation also to polarize. So if polarization is happening to a larger extent, then covalent character is increasing. That means the sharing nature is increasing. That means ionic nature is decreasing. So ultimately, if I have to compare the covalent nature of these salts, then here cation is same. So larger be the anion, more will be its covalent nature. So NaCl will be the most covalent salt. Now, what about charge on an ion? Sir, charge always is the most dominating factor. So more be the charge on either, sir, what is Coulombic force of attraction? K Q1 Q2. So if charge on either cation or anion, whatever increases, ultimately it is going to help the polarization. So as charge increases, not discussing about the size when charge I'm considering. So polarization will definitely increase. Polarization ability will also increase. So covalent character will increase and ionic character will decrease. Like for example, here this anion is having -3 charge, so it will have highest covalent nature, and this have least covalent nature because its charges. More be the charge, more is your ability to get polarized. I hope we are clear with this. Now, one important point for good type of questions. So I'm moving one step forward for Fazan's rule, because Fazan's rule, NTA has also started loving a bit more than I mean, good questions for Fazan's rule also is probable in the statement based questions. So discussing a few points about Fazan's rule more. There are some cations which have inert gas configuration. Now what are these cations which have inert gas configuration, sir? Alkali metal, alkaline earth metal, they lose 1 electron, 2 electron and form inert gas configuration. So like group 1, group 2, they form +1, +2 cations, easy. There are some cations which have pseudo inert gas configuration. Well, now what are these cations? Like copper group and zinc group. But when zinc group loses 2 electrons, the 4s2 electron is gone, so 3d becomes fully filled. When copper form +1 cations, so 4s1, the ns1 is gone, they have fully filled n-1d. So because they have fully filled configuration, which is not exact inert gas configuration, but because their properties also show that they are stable, so what we say that their configuration is stable, and to that stability we refer as pseudo inert gas configuration, not exactly like inert but inert gas. Now there are some cations which have non-inert configuration, yes, because they also show stability in some of their oxidation states. Now what are these cations? We definitely know there are some cations whose Z effective must be very large. Where Z effective increases, sir, in the sixth period, after filling of lanthanoids, the Z effective must be increased. So even if for the last D block element in the sixth period, that is mercury, Z effective is increased to the largest extent. After that, obviously they will also have high Z effective. So because their Z effective is so strong, so through their properties, like mercury in +2 oxidation state, helium in +1, lead in +2 and bismuth in +3. These oxidation states are very stable for them, and therefore these particular oxidation state where they have tremendously high Z effective, they are also termed as non-inert gas because they are stable. So electronic configuration is stable, so stable like inert configuration, but they are not actually inert, so non-inert configuration. Moreover, helium, lead, bismuth, why their lower oxidation state are stable? Because of inert pair effect. So inert pair effect is also a point to be discussed. We'll be discussing in the next slide, but for just finishing Fazan's rule first. So these are the 3 type of stable cationic configuration, and why I'm specially mentioning it, because the polarization power of what type of configuration is highest? Of non-inert configuration. Why? Because these are through their properties also, and we'll be studying inert pair effect also for them. So because their Z effective are so strong that these cations have huge Z effective, and huge Z effective will offer them huge polarization power. Polarization power increment will polarize the electrons of anion also and will create covalent nature, and therefore the compound which are formed by cations of such configuration, which is non-inert configuration, the 4 cations which I have mentioned, are having the most covalent nature. Very, for good questions you should know this. Now after that, the pseudo-inert configuration like copper, like group 12, group 11, which are having fully filled configuration, their D subshell, and least will be inert gas configuration, the actual inert gas configuration, the group 1 and group 2 cations. I hope we are clear with this. Some people learn it as S cations have less polarization power, D cations have more polarization power. I am discussing more about the D because I am specially mentioning that why they are more polarizing, because they have non-inert configuration and pseudo-inert configuration. Non-inert, I'll be discussing next slide, the inert pair effect also. Now, and because of this polarization power only, diagonal relationship is also observed. Now what is diagonal relationship? We definitely know. Lithium shows similar property as magnesium. Beryllium shows similar property as aluminium. Boron shows similar property as silicon. Why they have similar property? Because all the anions, their cations are the same because they have same polarization power. Although they have different size, but because of the ratio of charge upon size, their polarization power is same. So actually polarization power is the reason for diagonal relationships also between these 3 groups, or basically these 3 examples. So why their properties are same? Because their polarization power is same. I hope we are good. I hope we are good. Kya? Atul Bhargav, I mean, it isn't explained by Fazan rule. Due depends on configuration. Beta, see, inert pair effect. Once, let me finish inert pair effect, the non-inert configuration you will understand. Let me just do the another slide. First, I'm just finishing off this with the Fazan's rule. So, order of covalent. Now, why I'm discussing this for such type of questions? Like for example, PbCl2, HgCl2 and BaCl2. If you are supposed to calculate the covalent nature, who will be more covalent? Sir, Pb plus 2, Hg plus 2, both are non-inert. Now because both are non-inert, so go to charge. So who is having more charge? Sir, Pb plus 2 and Hg plus 2. Charge is also same. Now go to size. Sir, along the period size decreases. So mercury, if you move along the period, then you get lead. So along the period size decreases. So as size decreases, covalent nature increases. So PbCl2 will be most covalent. After that, mercuric chloride, and the least will be the BaCl2, which is alkaline earth metal, which is having exact inert configuration. I hope it is clear. Now, coming to whatever students are saying, sir, non-inert configuration. So coming to the inert pair effect also, the non-inert configuration. Actually what happens is, once we move down the group, the difference between NS and NP subshell increases. Why? Because we know S has a penetration effect. S is closer to the nucleus than P. And once you move down the group, the P subshell becomes more and more away from the nucleus. As a result, once you move down the group, the distance between NS and NP keeps on increasing. So once you have moved down the group to very large extent, like especially in case of boron family, Bagan, Alu, Gajan and Thela. So this is NS2, NP1. Carbon family, Kashi Gai Shankar Parvati as an NS2, NP2, and nitrogen family as in New Zealand, Pakistan, Australia, Sab Bikau. So I have taken the last element, the 6th period element, which is NS2, NP3. So as we move down the group, the distance between NS and NP, the difference between NS and NP subshell goes on increasing. So for 6th period element, the energy difference has been increased to such large extent that 6s2 electrons and 6p1 electrons. So these 6s2 electrons are so much closer to the nucleus that they do not consider this as valence shell. Because the energy difference has been increased, now they can be termed as valence shell while they can be termed as inner shell electrons. Why? Because energy difference has been increased. So what electron you give? It's a valence shell. You don't involve your inner shell electrons in bonding. So as you move down the group, the difference between NS and NP increases, as a result of which NS start behaving as inner shell electron. And only what electron participate in bonding? The valence shell, which is only the NP electron. So stability of group oxidation state. What is group oxidation state for boron family? It's 3. But 2 will not participate. So group oxidation state -2 is +1. So stability of +1 increases, not +3. Similarly, for carbon family, how many electrons is present in the group? 4. But what electron will be given? Only P. 6s2 will not participate because it will also act inert as inner shell electron. So what stability, what oxidation state it will show? +2, not +4. Similarly, nitrogen family, +3, not +5. I hope we are clear. Now coming to mercury, with the similar, almost with a similar reason, and with the knowledge that they have strong Z effective because of the filling of D, E and F electron. They have strong Z effective, and that strong Z effective is even going to attract these inner shell electron to a larger extent because nucleus has been empowered. So it will also attract these electron to one, they have came closer. Second, nucleus has gone so powerful. So for mercury also nucleus has gone so much powerful that once it acquires +2 oxidation state, it is holded very strongly by the strong nucleus of mercury, and hence for mercury also +2 becomes more stable state, not 0. So this is the actual picture of inert pair effect, which says the stability of group oxidation state -2 increases down the group. I hope we are clear with this. Now I hope the doubts which some of you must be having is done. Now if you say for the color part, yes, in the detailed one shot I have discussed the color part also, but generally color part is only asked in JEE once you are discussing the DD transition or FF transition. So color is basically a property of transition elements, and therefore here I will be discussing that in the transition part, not over here. Now moving forward, some application of Fazan's rule, like I am discussing radius of aqueous ion. Now sir, how you relate aqueous ion? See, let's say I have sodium cation. Now this sodium cation is not present as a gaseous cation. It is now attracted by water because cation and water is a polar solvent. So the cation will be encircled by the polar solvent, and because it will be encircled by the polar solvent, so its size will increase. So hydrated ion has a different size. Similarly, chloride ion, once attracted by solvent molecule, the size of aqueous ion increases. Now why the ions, the cation or anion gets attracted or hydrated by water? They get attracted because of the charge density. Sir, water is a polar solvent, so more be the charge, more water molecule will surround that particular ion. So again, more dominating factor will be charge. Once charge is same, then you go with size. So if a cation is heavily hydrated, its size in aqueous medium will be large. Gaseous cation have different sizes, but aqueous cations have different periodicity, and that can only be thought once you know this Fazan's rule application, that this is also happening because of charge density of that ion. Like for example, if somebody is asking you that what is the size of Li plus gaseous and CS plus gaseous, then gaseous, sir, gaseous it is periodicity. This periodicity we already know that down the group size increases. But if we talk of the aqueous ion, then charge is same because lithium cation is smallest, so its hydration will be highest. And because its hydration will be highest, so it will be encircled by water molecule more and more. So its aqueous ion will be larger in size because aqueous ion size is considered along with the solvent molecules. I hope we are clear. Now similarly, now here we are directly comparing the size of aqueous ion. So who is more hydrated will have more size, who will get more hydrated, which have more charge density. Clear cut. charge density is property of charge. So plus 3 will be heavily hydrated, so will be surrounded by more water molecules, so will be bigger. What about F minus, I minus? Sir, F minus is smaller, so will be surrounded largely by hydrated ion, so its size will be highest, although F minus gaseous is smaller. So I hope the logic is clear to us that here we are discussing size of the hydrated aqueous ion, not the gaseous ion. Yeah, okay, perfect. Now coming to a very important topic of chemical bonding, which is resonance. We definitely know what is a resonating structure when non-sigma electron starts delocalizing. Here, nucleus do not move with respect to each other. What moves? Only non-sigma electrons, and whatever structures we obtain are called the resonating structures or the canonical structures. Once you draw all the resonating and canonical structures, it becomes easier for you to predict the resonance hybrid, and molecule exists in nature in form of that particular resonance hybrid. So if for some molecules one structure is not sufficient to explain all its properties, rather we draw series of structures. What structures? Lewis structures. Why we draw series of structures? Because there is possibility of drawing those non-sigma electrons sometimes somewhere else, sometimes somewhere else. Like for example, if I have carbonate ion. Now what is carbonate ion? CO3 2 minus. Sir, carbon, central atom, 3 oxygen, single bond I have made. Sir, but we know carbon forms how many bond? 4 bond. So let me make that pi bond over here. So giving minus to this carbon and minus to this carbon, so this becomes CO3 2 minus. But whenever you have possibility of drawing a pi electron, you can always draw it over here or over here or over here. If I've drawn it over here, then this oxygen will get minus. If I've drawn over here, then these oxygens will get minus. So none of the Lewis structure is incorrect, but actually any structure can be drawn. So how many structures I have drawn? 3. So these structures are known as canonical structures. After drawing these canonical structures, what we have, we can predict the average resonance hybrid. So what is the average? Every carbon is bonded with single bond to another oxygen. Sometimes you are double, sometimes you are double, sometimes you are double. Why I am drawing a dotted line? Because this is giving them a partial double bond character with the overall molecule attaining -2 charge. So if you are supposed to calculate all or estimate all the property of carbonate ion by looking at this structure, you will say that this has bond order 2, this has bond order 1. As bond order increases, bond length decreases. So you will say bond length x and bond length y, x is lesser than y. But if you go to mother nature, you will see that this is x, this is y, then all x and y bond length are equal. But that you cannot predict with this structure. So for some compounds, the properties cannot be predicted from any canonical structure. It can only be predicted from the resonance hybrid. So molecule actually exists in form of resonance hybrid. Now, how to calculate bond order, sir? How to say that they have same bond orders? That means they'll have same bond length. In order to calculate bond order, what we do is we just concentrate on one of the bond. Let's say we are concentrating on this C bond O. What is bond order in this structure? 2. What is bond order in this structure? 1. What is bond order in this structure? 1. So 2 plus 1 3 plus 1 4. So 4 divided by number of resonating structures is 3. So this becomes 4 by 3, that is 1.33. So bond order of each C bond O is how much? 1.33. This is how you have understood resonance also and its application also in order to compare the bond order and strength of any particular bond. Now, doing the same thing for a different example. Now this is a very famous example of nitrate ion. Somebody is asking you nitrate ion and nitrite ion, who is more stable? So if you draw resonating structure of nitrite ion, you have drawn nitrate ion, you have drawn 3 structures. If you draw resonating structures of nitrite ion, you draw 2 resonating structures. More be the number of resonating structures, as in more electrons are busy delocalizing in their home. If the township is having more duplexes then and having more delocalizing electron, as in kids, then the kids can play from one home to another home. They will not go outside. Similarly, when you have more number of resonating structure, delocalization is happening to a larger extent. Therefore, electrons will not participate in reaction with outside world. That means they will be stable, not reactive. So because of more resonating structure, nitrate is more stable than nitrite. Comparing the bond length also, I've made the average hybrid, this is Y. I have made the resonance hybrid, this is X. But now calculate bond order, which we have seen. So calculating bond order. If we calculate over here, let us do for this bond only. So bond order 2 plus 1, 3 plus 1, 4. So 4 by 3 is 1.33. Predictable. Let us focus in this bond. 2, 1. So 2 plus 1 is 3. But 3 by 2 is 1.5. So this is same N bond O, that is also same N bond O. But if somebody is asking you what about the bond length, let's say this bond length is Y, this bond length is X. So more be the bond order, as in atoms are bounded closer to each other, so bond length will be lesser. Bond order is inversely proportional to bond length. So because this bond order is more, so bond length will be less, so X will be lesser than Y. So bond length, this is strong. I mean, this bond, N bond O is stronger, but overall nitrate ion is stable. So this also solves a very tricky question, that although bond length of N bond O in nitride is smaller, bond length of N bond O in NO2 minus is smaller, but still nitrate is more stable. Why? So bond length explanation is different, but stability explanation is through resonance. I hope we are clear with this. I hope we are clear with this. Yes, Parnika, I read it. We want NCRT Petara for batch JEE. You will be getting, but for the coming days, we are working for your April attempt. So this live is taking, obviously you can see a lot of energy also, but your participation, thank you that you guys are actively listening to all of this. Yes, for all those students who may be in the mid time, you get abstracted by one or the other things, then maybe you can take a pause, but you can always come back and watch the video recording. So if you have doubts, you can ask here also, but invest an optimum amount of focus beta, because this is especially, I have made them for covering all the important logics, more and more number of logics that I can, the probable logics. Now this is a question which you can attempt, so I'm leaving this question as a test for you. That bond order calculation I have already done. I've given you the answer that charge per oxygen atom is 1 by 3 and bond order of S bond O minus is 5 by 3, that is 1.67. so for those who are actually working, this is a homework for you. I mean, homework as in you can do right now also, but obviously I have the class also. Now for bonding, coming to the next topic, which is VSEPR theory. Now, what is this VSEPR theory? So actually, what happens is, through VBT, we know that atom makes a bond to form a molecule because of overlapping. We know that. VSEPR theory help us to predict the shape of that particular molecule. VSEPR theory helps us to predict the shape of that particular molecule. How? Whenever a central atom makes a bond, the valence electrons are categorized as two types. Those valence electrons who are making bond are called bond pair electrons, and the electrons that are left behind are called lone pair electrons. Spectroscopical analysis have helped quantum theory also and VSEPR theory also to come to a conclusion which says that lone pair repulsion is highest. After that, lesser is lone pair bond pair repulsion, and least is bond pair repulsion. I hope we are done with this. Now, sir, if we know this order, then how can we predict the shape of molecule? Let us revise that. First, let us know how to calculate steric number. Steric number is summation of bond pair plus lone pair. I have already told you, bond pair making electrons, lone pair left out electrons. But while calculating bond pair, you only calculate sigma bond. Why? Because if one atom is coming to you, one nucleus with respect to other nucleus, minimum you will form one bond, that will be sigma bond. After that, whatever bond you are forming, that nucleus with respect to you has already been accounted for. So when you are calculating shape, I want nucleus with respect to me. If some nucleus is bonded to me with more number of bonds, obviously the bond length will decrease, but ultimately that nucleus obviously I have accounted with respect to myself. So once we are going for the shape, once you calculate steric number, we only count the sigma bond. I hope we are done with this. So steric number is sigma bond plus lone pair. Now this will also help us to predict the hybridization state also. That central atom whenever makes a bond hybridizes, intermixes orbital, and the hybridized orbital are capable of forming more stronger bond. So how to calculate steric number or how to calculate hybridization state? Whenever steric number is 2, so hybridization state of central atom is sp. If it is 3, so 3 orbitals I need, so sp2. If it is 4, then it is sp3, or in coordination compounds we'll see hybridization can also be dsp2. If steric number is 5, then it can be sp3d, or dsp3 is rare but we can see this. If coordination number is 6, then hybridization can be sp3d2, or in complexes we'll also see d2sp3 hybridization. So this is how we can predict hybridization also, and let us now decode how to predict the shapes. So if the molecule is having no unpaired electron, if the molecule is having no lone pair of electron, as in when the lone pair on central atom is 0, then whatever shapes we get are called the symmetrical shape. The first symmetrical shape being, if we have AB type of molecule, then central atom B. For example, C O2. Sir, O2, oxygen is making double bond. I am just counting sigma bond. So A B2 type molecule, when central atom has no lone pair, I am linearly shaped. Shape will be linear. Bond angle will be 180 degree. I hope we are clear with this. Now, what is AB3 type of molecule? It is trigonal planar, bond angle 120 degree. AB4 type of molecule like methane with carbon forming 4 bonds, or xenon with 4 oxygen is also tetrahedral. So these tetrahedral has a bond angle of 109 degree, 28 minutes. Next, now these are all tetrahedral example. This is XCF4, ammonium cation, but nitrogen has no lone pair, so 4 sigma bond, no lone pair, steric number 4. Sulfur triple bonded with nitrogen, fluorine. Sulfur has 6 electrons in its outermost shell, so no lone pair. How many sigma bonds? 4. So this is also tetrahedral. I hope we are clear. So there's some untraditional structures, but using the same logic. Now, steric number 5, 3 triangle, 3 bond making triangle, 1 up, 1 down. So shape is known as trigonal bipyramidal, with these bonds as 120 degree and this bond as 90 degree. Obviously 120 degree are far apart, so this bond length, let's say it's called, let's say it's equatorial, and it is axial. So axial is at 90 degrees, so generally bond length of axial is larger than equatorial. That's why PCl5 easily breaks these two chlorine and form PCl3 and Cl2. AB6 is traditionally octahedral. What is this octahedral? Octahedron 6, 8. 4 triangular faces upside, 4 triangular faces downside. So this octahedron and all these shapes which we have seen are the symmetrical shape. Now what are these symmetrical shape? That if you see any shape, if you calculate any shape and calculate what? The dipole moment. Like let me do for the simplest one. Like for example, I have C double bond O and double bond O. Then obviously I know overall molecule is polar. But this is minus, this is plus, so plus minus vector is here, plus minus vector is here. This is the dipole moment vector. If the overall molecule is having the net vector addition is 0, so overall molecule will have no dipole moment. That means overall molecule will have no polarity. Therefore, all the symmetrical structures will have the similar vector addition of the net dipole moment as 0, and therefore even they have individually they have polar bonds, but the overall molecule will be non-polar. That is what I have written over here, that all symmetrical shapes have mu net 0 when the combining atoms are similar. So all such symmetrical shapes molecules are non-polar overall in nature. I hope we are clear with that now. dipole moment and polarity. Now, what about dipole moment and polarity? Sir, dipole moment we have already seen, but let us summarize this. If two charges are separated by a distance d, then from positive to negative, a force is proposed, and that force is the force of this electric dipole. So the direction of the dipole moment is from positive to negative. Point number one. What is the magnitude by which the force has been applied? The magnitude of electric dipole is calculated by charge into distance between charge. Unit of charge is coulomb, unit of distance is meter, but it is attributed to the name of the scientist, so the unit used is generally debye. What is 1 debye? 1 debye is equal to 10 raised to power minus 18 electrostatic unit into centimeter, because ESU centimeter is also famous for some JEE Mains type of questions also. And what is what is 1 debye in terms of SI unit of charge? It is equal to 3.35 into 10 to the power minus 30 coulomb into meter. So we obviously know, if you do not know, you should at least know this relationship, that one electrostatic unit is equal to 3.335 into 10 to the power minus 10 coulomb. So such calculations help you where, in what type of questions? When you have to calculate percentage ionic character. So how to do this percentage ionic character calculation? If you are a covalent molecule, but because of polarity, what you are obtaining, sir, plus minus, that means you are obtaining ionic nature. So your ionic nature can be estimated using dipole moment. How, sir? First we calculate your dipole moment theoretically. Then we go to mother nature and calculate your dipole moment experimentally and do the ratio. So dipole moment observed as an actual, as in nature, whatever you have your dipole moment, upon dipole moment calculated into 100 will give the percentage ionic character in a covalent compound. I hope you are getting this. If you are an ionic compound, whatever covalent nature I have can be estimated using Fazan's rule. If you are a covalent compound, that whatever ionic nature is estimated is done using percentage ionic character calculation using dipole moment, using electric dipole moment value, value of mu. I hope we are clear. Yeah. Acha. Atul and हाँ beta, perfect. I mean, that was a question for homework beta. Abhi I'm discussing important topics over here. So good. Yes, oxygen charge you have gone. Good, 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 very good. But homework is homework. Let us proceed forward now. Such questions are asked out of you, like over here. This is a JEE 2024 question, that dipole moment is given. Dipole moment, acha, a diatomic molecule has a dipole moment. Okay, this is the observed dipole moment. That means 1.2 debye. If the distance is this much, distance is given, then fractional charge on this atom. Okay, so it is actually asking us what is the fractional charge, because it is giving us the observed dipole moment. So we know dipole moment is equal to charge into distance, because this is not calculated dipole moment, this is the actual observed value. So this will be the fractional charge. The fraction of charge which the dipole has gained in nature can be estimated. How? Using the observed dipole. So observed dipole is how much? 1.2. Unit is debye, is equal to charge. First we'll calculate in charge, then we know the conversion of debye into ESU. Into distance, distance is 1 angstrom, as in 10 raised to the power minus 10. So this is coulomb into meter. So we can do the estimate. The coulomb is debye, this is 10 to the power minus 18. So okay, this is debye. So okay, conversion you have to do. First, 1 debye is equal to this much coulomb meter. 1 debye is equal to, so here first we converted into coulomb meter, or because I have to convert it into ESU, so I can directly write 10 to the power minus 18 ESU. So this is 10 to the power minus 18. This will directly come in ESU centimeter, and here charge I will be getting in ESU only, because here this I've converted to ESU, but 1 angstrom is 10 to the power minus 10 meter. So I want to get it in centimeter. So 10 to the power minus 10 meter, as in minus 8 centimeter. So okay, so this is gone, and here I'll be left with 10 to the power minus 7. This is the format. Okay, answer is 1.2 only. Answer is 1.2 only. Yeah, I hope we are clear. Yeah, perfect, 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 Rohan. Yeah. Now see, once you get beta, see, once you get questions, it becomes easy to predict. Formula seen, put answer, formula seen, put answer. I am giving you more and more formulas because you do not know what is going to come. My job is to give you concepts, more and more concepts in 8 hours. That is the meaning of a revision. So I'm giving you more and more concepts. But yes, once such questions don't come in between, sir, we feel lethargic. Don't feel that, because my job is to give you complete IOC and I am trying to do my job with best of the efficiency. Now, once you introduce lone pair in the central atom, then symmetrical structures become unsymmetrical. So unsymmetrical structures obviously will have some mu net. So let us find those unsymmetrical structures. Now, when you have a molecule of the form AB2L, as an L represents lone pair, that means I'm introducing 2 bond pair and 1 lone pair. Again, steric number will be 3. How you will think about the structure? By going to the symmetrical structure. This is AB3, but in AB3, 1 bond pair is replaced by lone pair. So while looking at the shape, you don't see lone pair. So shape will be bend shape. But while looking at the angle, you now see lone pair, because we know lone pair repulsion is higher. So angle will be less than 120 degree. So bond angle, this theta will be less than 120 degree, because this is AB3. Visualization is AB3, but lone pair is having more repulsion, so bond angle will reduce. I hope we are clear with this. Now, what about this? If you have 4 steric number, that means this is configuration 3 plus 1. Again, we'll think of AB4, but in AB4 type of molecule, I'm introducing 1 lone pair. So 3 bonds will be formed, a triangle will be formed, but this lone pair we will not see. So it is a triangle forming a pyramid. So shape will be trigonal pyramidal, just like ammonia and XeO3 having the same shape, which is trigonal pyramidal. What about the angle theta? This theta will definitely be lesser than 109 degree 28 minute, because lone pair will reduce the tetrahedral angle. Like in case of ammonia, you should learn also, very famous, ammonia angle is less than, but how much less? It is approximately 107 degree. Now, if I have bond pair 4, but due to 2 bond pair and 2 lone pair, so steric number is again 4. We'll again think of tetrahedral structure only, but now we'll replace 2 bond pair by lone pair. This angle will be reduced to a much larger extent, and in order to see shape, don't look at the lone pair, because lone pair belong to the central atom only. So nucleus with respect to other nucleus has a shape of V shape or bent, just like water, where angle is again lesser than 109 degree 28 minute, but here we have 2 lone pairs, so angle will be much lesser, which is again can be seen also, it is 104.5 degree. So again, a very important observation. Bond angle of ammonia is larger, bond angle of water is lesser. Why? Because here you have 2 lone pair. I have given you some more examples. Those who are interested can see those examples as well. Now, moving forward, sir, bond pair, steric number 4, as in 4 bond pair plus 1 lone pair. So what are you thinking? AB5 is trigonal bipyramidal, but in trigonal bipyramidal, the equatorial bonds are how much distant from each other? 120 degree. So once you try to introduce lone pair in a AB5 type of crystal, never add it in axial position, because axial position is at an angle of 90 degrees, so more repulsion will be offered. Always introduce it at equatorial position, because they are rather at larger distance, 120 degree from each other. That's why in AB5 type of molecule, whenever you are supposed to add lone pair, first introduce lone pair where? In the equatorial position. Like for example, if I have 1 lone pair in the equatorial position, make the shape seesaw. If I have 2 lone pairs, as in 3 plus 2, 2 lone pair will occupy equatorial position, so shape will become T or maybe bend T, because these lone pair will be forcing the bonds to be tilted. So T or bend T, just like this IF3 or CLF3. If I have 2 plus 3 configuration, then whole the 3 lone pair will be going to equatorial position. It will be just restricting the axial bonds in the same plane only. So shape will be exact linear. This bond angle will exact be 90 degree. I hope we are clear with this. Now, moving forward, if I have 6 steric number, but because 5 bond pair and 1 lone pair, then we'll think of AB6 as an octahedral. In octahedral also, these are the 2 bonds. Why I'm showing as wedge and dash? Because I'm taking this as the plane, one upside, one downside. Introduce one bond pair, replace one bond pair by a lone pair. So this shape is still a square and a pyramid, a square and a pyramid, a square and a pyramid. But actually, if you see, this lone pair will try to tilt the square. The square will not be a perfect square. It will be tilted upside. Why? Because lone pair will have more repulsion. So if a better question is asking you, is this angle exact 90 degree? No, sir. This angle will be lesser than 90 degree, because yes, if you visualize and say the shape, it is square pyramidal, but this square is tilted square, not this perfect square. I hope we are clear now. If I have 4 bond pair and 2 lone pair, then lone pair will be coming opposite to each other. So I have a square planar geometry just like XEF4. Moving forward, now these are some basic questions, so let us attempt this question. Let's see who all can give us the answer. Let us try this one, guys. So the question says, number of species from the following in which the central atom uses sp3 hybridized orbital in bonding. So again, you have to think about the hybridization only. What hybridization? Which is showing sp3 hybridization. So which is showing sp3? Sir, this is 3 bond pair, 1 lone pair. So yes, it is sp3. SO2 is 1 bond pair, 1 bond pair and a lone pair. So this is steric number 3. So no. Si, obviously silicon is carbon. Okay, no. Si, O2. So silicon double bonded O, double bonded O. No, this is sp. BCl2 is sp, CO2 is sp, water is sp3, methane is sp3, BF3 is sp3. So how many I have? 1, 2, 3. Okay, yes, beta. There is a logic for SiO2. There is a logical, or rather I would say natural explanation. What is that? That is why I have taken this question. Okay, a block chemistry logic. Yeah, 4. Actually, SiO2, if you just look at one SiO2 unit, you will say it is linear. But actually in nature, SiO2 is a silica. All the glasses, all the different variety of glasses that we have are nothing but substitutes of silica only, because in nature it exists as a covalent solid, a covalent network solid. So yes, this is also considered as an sp3 hybridized structure, although you cannot say just with SiO2, but with the knowledge of block chemistry, it is a fact that in nature SiO2 exists as a tetrahedral unit with each silicon bonded with 4 oxygen atoms and forming a network solid. So this SiO2, because of that factor, is an sp3 hybridized central atom. A good point, a good question. That's why I have included this. Now, the structure of PCl5 in solid state. Actually, PCl5 in nature exists as PCl5 is when solidified. PCl5, one of the molecule releases Cl minus and forms a cation called PCl4 plus. The extra Cl minus is attained by the +5 oxidation state of phosphorus, which is having empty orbitals also. The one chlorine as Cl minus will be introduced in this phosphorus, giving rise to PCl6 minus, because ultimately PCl5 is a covalent molecule. How can it exist as a solid? Because covalent exists as gas. Actually in nature this covalent exists, this covalent compound exists as solid when it converts itself into an ionic compound. And how it can convert into an ionic compound? When you propose this, when they are coming closer to each other, one molecule loses Cl minus, another gains. So this becomes a tetrahedral cation and this rather becomes an octahedral anion. So can we say the same thing about BrF5? No. BrF5 forms Br plus, but instead of Br6 minus, it rather forms only Br minus, because size of Br6 minus 6 bromine cannot be accommodated around phosphorus, because bromine are large enough. Although that logic I have not written, so answer for this is obviously octahedral anion and tetrahedral cation. A beautiful explanation. Now, next question says, since fluorine is more electronegative than nitrogen, net dipole moment of NF3 is greater. No, this is false. Now, why it is false? A very beautiful explanation for this also. Both structure are trigonal pyramidal. Now, we have recently seen that because of lone pair dipole moment will be from nucleus from plus to minus. But because of nitrogen hydrogen bond, this is minus, this is plus, so bond pair will dipole moment because of these bonds will be in this direction. So ultimately it will be getting added with this mu, because this are directed. Yes, their x component will get cancelled, but their y component will be added with this dipole of lone pair. But here, because fluorine is more electronegative, so net dipole moment will be directed downwards. Yes, that their horizontal component will be cancelled, but ultimately the dipole moment due to lone pair and the net vector due to the bond pair electrons will be in opposite direction. I'm not saying it is completely cancelled, but this is ultimately cancelling each other, and here they are supporting each other. So although you are fluorine more electronegative, but your dipole are getting cancelled while your is not. So you will rather have a higher dipole moment. So the question is saying that NF3 is greater, so is wrong. So statement 1 is incorrect. Statement 2, in NH3 the orbital dipole due to lone pair and the dipole moment N bond H are in opposite direction. No sir, in NH3 it is in same direction. In NH3 it is in same direction. So that's why this is also false. So both statements are false. So option B is your right answer. I hope you are clear with this. Now, moving to, sir, why you are again discussing valence bond theory? I'm just giving you this photo to make you understand the shape of orbitals. Just because in atomic structure I have not touched upon them, so you should just know the shape of the orbitals, that S is having similar wave function. What are electrons? Electron are like wave. So if you have an s orbital, it has same wave function. Now if I write positive over here, I do not mean this is a charge, because orbitals are region around nucleus where probability of finding electron wave is maximum, because I am now considering quantum model, because orbital are conclusions of quantum model. Orbitals are shape of orbitals as in solution of Schrodinger wave equation, so quantum model. So whenever we see electron wave, the plus minus notion that we see is represented by this positive charge. Whenever an orbital over here, they have same wave notion, I have represented using color, but many a times plus is written, but that plus is not charge, that plus is the notion of the wave. So similarly, S have same notion. P, with respect to the molecular axis, it has opposite notion. D, the lobes that are diagonally present have same notion, while the other has opposite notion. I mean, they also have same, they also have same. This is not charged, they same notions. That's why I've represented them with color, because students are very much confused with it. In D, this dumbbell has same notion, the Saturnian lobe has another notion. So obviously with the color also it is quite visible to you. Now, why I'm giving you the point is because I have to tell you what are gyrades and ungyrade ligands. So gyrade ligands are those actually which are symmetrical with respect to center. So S and P are gyrade. Now I have to explain you just this, that's why I'm using this. So S and D are gyrade means that if I'm at center, now let's say I'm moving upside, what environment I have plus, to the same, just move opposite on the same direction. So let us say I move exactly opposite, I same the same wave notion. So it is symmetrical about the center, and hence S are gyrade. Gyrade is symmetrical orbitals. Now come to D. Let's say I'm at center. I have chosen an angle of 45 degree and moving this side. So let's say I'm moving here. Just move to the opposite side. So still I have C positivity. So that means this is also symmetrical with respect to center. But if you do that in a p orbital, this is plus, this is minus. So wave motion is getting opposite. It is not symmetrical. That means p orbitals are ungirate, a very famous point which students miss. So that color picture help us to actually understand what are gyrate and ungirate ligands, gyrate and ungirate orbitals. I hope we are clear with that also. Now D shape I have already discussed. As per VBT, orbital overlap, but how they overlap? They can have positive overlap when same notion gets overlapped. If opposite notion gets overlapped, then no bond is formed. So negative overlap result in no bonding. Positive overlap only result in bonding. Positive overlap may be sigma bond, maybe lateral as in pi bond. You also have zero overlap like S and P. When P is directed along the molecular axis, they can have head on, but S and P lateral overlapping is not possible, so this will be a zero overlap. Similarly, P when directed in different axes, they can also not be overlapped, so they can also form no chemical bond. You should know thus such points. The PPDD thing, lateral overlapping, I've already explained. These are some questions which are asked, so I'm giving this question as a practice for you because we need to finish chemical bonding. I thought that before 10 we should finish, so we have already exceeded 10:30. So the questions I'm leaving for you because most of you are waiting for the questions also. So once I'll be going for the 15-minute break, you will be taking these questions as your practice questions, and then we'll be coming back. Chalo. So concept of hybridization, yes. Atomic, this is methane. So methane forms 4 bonds, but these 4 bonds are formed by hybridized orbitals. How these hybridized orbitals are formed? By the participating orbitals. When they intermix, they form equal energized, equal number of, how many atomic orbitals are participating? 4. How many hybridized orbitals are formed? 4. So the concept of hybridization state we already know, but why orbitals get transformed, why they get hybridized, in order to say that whatever bond they form, all the bond have same energy. So they are formed by equal energized orbitals having same shape and size, and or hybridized orbital are more effective in forming a perfect overlap than the participating atomic orbitals. Some theoretical points for your statement based questions. Now these are some features of hybridization that we definitely know. As S character increases, electronegativity increases. So let's say this is a carbon which is sp hybridized, forming a bond, let's say with hydrogen. So sp hybridized carbon is more electronegative. So because I'm more electronegative, so I will attract the bonded electron more towards myself. So bond length will decrease. So bond length decreases as electronegativity increases. So bond length, as electronegativity increases, bond length decreases. That's why if we have sp3 hybridized carbon, the C bond H will be lesser. If we have sp3 hybridized, sp hybridized carbon will have lesser C bond H. sp3 hybridized carbon will have larger C bond H, although C is same. I hope we are clear with this. A very important point to note. Now, steric number calculation, hybridization, the geometry, this we already know. The bond angle table we have already seen. Now, one important question, CO2 you can do by yourself. So this is your homework. Yes, SO3 I'm making for you. I'm asking you how many pi bonds SO3 has and what are those pi bonds. So how to do it? Let's say I have sulfur. Sulfur is, sir, it is 3s2 3p4 because this is oxygen family. So sulfur has 3 electrons here, 4 electrons here. How many bonds SO3 is going to form? Let us go to VSEPR theory. Sulfur, double bond O, double bond O, double bond O. Why I'm going to VSEPR theory? Because we can clearly see the shape. This is trigonal planar. Forming how many bonds? Sir, 3 sigma but 3 pi. And here we are asked what are the number of pi bonds and what are the type of pi bonds. So 3 sigma bond and 3 pi bond. So ultimately how many unpaired electrons I need? 6. So this is a ground state configuration. So let me excite sulfur. So 3s 3p, and now it will be excited to 3d. So 1 2 3 4. What all electrons are going to get excited? This one, and this one. So they will get excite and form 4 unpaired electrons. How many bonds are going to form sigma bond? So this is 1 sigma, 2 sigma, let's say 3 sigma. So 1 sigma, 2 sigma, 3 sigma. So how many hybridized orbitals are only formed by sigma? Sigma bonds are only formed by hybridized orbitals. So how many orbitals I will participate in hybridization? 3. So I'll be getting 3 sp2 hybridized orbital because 1 s, 2 p. Hybridization state you can obviously predict also, 3 bond pair. So 3, steric number 3, hybridization sp2. But what orbitals I am left with? Sir, you are left with this 3p orbital and you are left with 2 3d orbital. So these electrons, these 3 electrons are going to form pi bond with whom? Sir, these are going to form pi bond with oxygen. This oxygen, these oxygen. Electronic configuration of oxygen is 2s2, 2p4. 2s is all paired. Now, once you excite oxygen, how many? Okay, 2s2, 2p, okay, I'm sorry, 2p4. Huh. So this oxygen will make a sigma bond. 1 sigma bond oxygen is making. So which electron of oxygen is going to form the pi bonds? Or this one? I hope it is clear to everybody. So the electron of oxygen, this has already formed sigma bond. The electron of oxygen which is going to pi bond is present in 2p. The electron of sulfur which is going to pi bond are 3, which are present in 1 3p and 2 3d. So ultimately this 3p and this 2p will form 1 pi bond. You will have another oxygen where this 3d and 2p of another oxygen, this 3d and 2p of the third oxygen. So this is a p pi bond. So p pi bond is 1 and this is a p pi d pi bond. So p pi d pi bonds are 2. So out of these 3 pi bonds, 2 are p pi d pi and 1 is p pi. I hope we are done with this. I hope we are done with this. Chalo. Moving to CO2 you can do. Moving to a basic. Okay, let me do one thing. Bend's rule actually is just a simple logic which says that electronegative atom, Bend's rule is just this simple logic which says that if you have electronegative atom, then electronegative atom hates S character. Now I'm including this S character logic because of the fact that as S character increases, bond length decreases. Sir, how do we know this? Remember this point, the basic point which we have concluded. As electronegativity increases, S character increases and bond length decreases. So we have, this scientists have already taken this explanation from the chemical bonding logic. So I'm just relating this S character and bond length now. That S character is inversely proportional to bond length. I hope we are clear with this. That S character is inversely proportional to bond length. S character is inversely proportional to bond length. Now why I'm using this Bend's rule, I'll tell you why. Just because for many questions you do not have to know this. Like for example, I have XeO2F2. Can you tell me in XeO2F2 fluorine will go where? Sir, 2 electron oxygen, 2 bond oxygen will form, 1 fluorine will form. So this is AB5 type of molecule. Hybridization will be, sir, 4 bond pair, 1 lone pair. So 4 bond pair, 1 lone pair, hybridization will be steric number 5. So sp3d. Okay. Moreover, sir, we know equatorial bonds are lesser, axial bonds are moreover bond order more, so bond length is less. So anybody can predict that oxygen will come in the axial position and fluorine will come. Oxygen will come in the equatorial position and fluorine will come in the axial position. I hope we are clear. Anybody and everybody can predict this? No. Sir, we do not even Bend's rule. Then why you are explaining? Like for such type of questions also it is very easy. Like for example, you are asked, you have to compare O bond O. In H2O2 and O2F2. Sir, ultimately we are supposed to calculate, we are supposed to not calculate, actually estimate that which bond length is. Sir, this is also O bond O, this is also O bond O, this will be same. No. Why? Again, for this also you do not need Bend's rule, your common sense will help you. How? Sir, ultimately lone pair are repelling. This you can feel lone pair of this oxygen, lone pair of this oxygen will repel. Yes, understood. If this oxygen is connected to fluorine, then fluorine, sir, is electronegative. Everybody knows it. Because fluorine is electronegative, so it will withdraw electron towards itself. That means the electron cloud on oxygen has been given there. Similarly, electron cloud over here is given here. That means electron density here and here is decreased. So lone pair repulsion will also relaxed, decreased, so they can relax and come closer. Whereas over here they are still angry and fighting enough, so this is large, so this will be large and this will be less. You can predict this through common sense. So O bond O of bond length of H2O2 is larger, the peroxide bond length of H2O2 larger, and O2F2 is smaller. You can obviously predict this. I hope we are clear. But if we are comparing O bond F in OF2, okay, this is O2F2 and this is OF2. Now why I have made this photo like this is because if you see the structure, this is similar. Ultimately, I am comparing what point of difference is this. Here it is connected with fluorine. Here it is connected with a group, but ultimately with oxygen. So my point to you is, now you, for such questions, you have to know Bend's rule. I mean, this is a good question, by the way. Sir, what Bend's rule? Ultimately, I have to compare this O bond F. What is the point of difference? This fluorine and this oxygen. Now we know lone pair, this is oxygen with lone pair. This is just fluorine. Which is more electronegative? Fluorine. Electronegative atom hates S character. So it will transfer, this fluorine will transfer S character to oxygen. As S character decreases, so it will transfer. So here S character is increased. So because S character is increased, because they will attract S character. So as S character is increased here, oxygen will not transfer. As S character is increased, that means bond length, S character is inversely proportional to bond length. That means as S character increases, bond length decreases. As S character increases, bond length decreases. That means this bond length of O bond F will be this of O2, this is OF2. So as S character increase, bond length will decrease. So this will have a decreased bond length. That will rather have an increased bond length. Yes. Such questions sometimes tricks you. So whatever is Bend's rule is just this simple block. So whoever learns this block will apply the Bend's rule for good questions also. Yeah, for mains level of questions, sometimes it can be asked, sometimes it is asked for good level of questions also. But still I've included that Bend's rule. Now, this is just an application of Bend's rule. I have given theta1, theta2 calculation over here, but again, this will be your homework, because if at all there are few students, so I'm giving few questions for those students as well. Now, one chemical bonding logic which you should not leave is the Drago's rule, which is nothing but sometimes Drago says no khichdi banao, as in no hybridization. This is hybridization, khichdi, no khichdi banana. When no hybridization takes place, sir, hybridization cannot take place because once we have observed the bond angle of hydrides of group 15 and group 16 hydrides, we definitely know these hydrides have what shape? So lone pair. Tetrahedral is the thought by which we are thinking, but because this is lone pair, so this is trigonal pyramidal. What about them? They are bent. E, but with two lone pairs. So here also theta is less than 109 degree 20 minute. Here also theta is less than tetrahedral angle. We know that. Once we have observed their bond angle, we know because two lone pairs, so this is less. One lone pair, so this is more. But actually after ammonia and water, if we have gone down the group, then just see their bond angles. Sir, they are close to 90 degree. Sir, how can a tetrahedral angle become close to 90 degree at each other? That means hybridization is not even taking place. This was proposed by Dragos. Because for the hydride of group 15 and group 16 elements, except second period hydrides, as in NH3 and H2O, remaining all the hydrides have bond angle approximately equal to 90 degrees. So how can this happen when the p orbitals are not even taking part in the hybridization? Because p orbitals px, py, pz, pz are mutually perpendicular. So how can the combining atom be 90 degree to each other when there is no case of hybridization? So that's why it is said that they do not undergo, they have no hybridization. And because they have no hybridization, so this is definitely hybridized, this is definitely hybridized. How much S character they have? So 25%. How much S character they have? Sir, 100%. More be the S character, more be the electronegativity. That means they hold their electrons very tightly. So who becomes the strongest base? They becomes strongest base. So ammonia is strongest base among its hydride. Oxygen is strongest base among its hydride. Rather, if you just go by electronegativity, you will say oxygen and nitrogen are electronegative, so they will not give. But actually, we are not talking of element, we are talking of their compound. And when they compound, the complete family decide how you are going to do. So therefore, complete hybridization is deciding that they are strong bases, and down the group basic nature decreases. So Brent's Drago's rule gives the basic nature explanation also of group chemistry. I hope we are clear with this. Now, a concept of back bonding. Back bonding can take place as case 1. It can take place to the central atom, as in if I have BF3, so this BF3 has sp2 hybridized central atom, but this boron, because of its availability of empty orbital and the octet is not complete, this empty orbital will always make it Lewis acidic. So why will it wait for another element to come and satisfy its electron deficiency? Rather, if it is having a bonded electron which is having excess of electron, the back bonding can take place, because lone pair is excess of electron, empty orbital is deficiency of electrons. So plus minus attraction is nothing but back bonding. So even this can form back bond, this can form back bond, or this can form back bond. Sir, that means you are drawing the pi bond that you are making, it is resonating. Yes. So overall resonance hybrid can tell you that this can also be double, this can also be double, this can also be double. That means if you have BF3, then bond order is again calculated using average resonance hybrid. Bond length, because it is not single bonded, bond order is 1.33, so bond order increase, so bond length is decreased of B bond F. This is application of back bonding. Hybridization remains same, sp2. Bond angle is obviously same, 120 degree. And yes, acidic nature has been satisfied. So if a question is coming to you that among BF3 and BI3, who is more acidic, then here basic nature, acidic nature is satisfied. Why? Because here the back bonding, the pi bond is formed between 2p. So 2p is stronger bond, and because 2p is, this pi bond is strong, this pi bond is between dissimilar energized orbitals, so this is weakest. Although this is also getting back bonding, but the extent to which it is getting back bonding is weak. So its deficiency is not satisfied, whereas its deficiency is satisfied. So its acidic nature is good enough. So it will be least acidic, while that will be most acidic. And if you do not do this back bonding logic in your hand, then you just think that, array, fluorine is more electronegative, so BF3 will be more acidic. No. Concept of back bonding therefore tricks with some questions. I hope we are clear. Sometimes back bonding can also be taking place to bonded atoms. Sir, how in case of bonded atoms? Like for example, this is nitrogen having lone pair. This is silicon having empty d orbitals. If instead of SiH3 it is CH3, then no back bonding of this sort can take place, because it is having empty d orbitals. So lone pair can be coordinated here. and because you are coordinating lone pair, so it can sometime go here, sometime here, sometime here, so you will be again getting 3 resonating structures, and the resonance hybrid will be this. But this will change the shape. Why? Because lone pair is not now present in central atom, because it has become pi bond. Pi bond we do not count in steric number calculation, so steric number has been changed to 3. So its hybridization is not sp3, rather it is in nature it is sp2, because its shape will not be trigonal pyramidal, its shape will be trigonal planar. So here back bond is impacting various chemical bonding explanations. Bond order is obviously increased because of partial double bond character, and because bond order is increased, so bonding decreases. Yeah, clear with that? Now, just like benzene, we have inorganic benzene because of the same reason, back bonding, nitrogen giving electron to boron, nitrogen giving electron to boron, giving electron to boron. The very simple, the very famous, and the very famous, I would rather say, this is inorganic benzene. This is just like alternate pi bonds of benzene, but if you see reactivity, benzene is more stable, because obviously there is no polarity, which we can obviously see that this inorganic benzene can easily be reacted with HCl, and it gives addition reaction forming the corresponding compound, while you do not see benzene reacting very easily. Addition reaction is not seen. Yes, substitution can be seen, but benzene is not showing reactions like normal alkene. So obviously reactivity of this inorganic benzene is more. If you talk of hybridization state, then again, sir, because lone pair is gone, it has gained lone pair, so this was sp2, it will remain sp2, but yes, this will also turn sp2. So hybridization of both boron and nitrogen will be sp2. An important conclusion. Bridge bonding, back bonding concept, sir. This, when B2H6 exists in nature, BH3 actually exists as B2H6. Why? Because this boron is Lewis acidic, this boron is also Lewis acidic. If they keep 4 hydrogens on a plane and brings 2 hydrogens on upside and downside the plane, then this hydrogen can form bond with this boron also, this boron also. Although this will be electron deficient, because there is involvement of 3 center, but how many actual electrons are used in the bonding? Sir, only these 2 electrons. So if you just try to plot the orbital picture, then this hydrogen is having electron all the time. This boron is somewhere participating with this hydrogen, sometimes with this. So if you draw the electron cloud, you will draw such a picture, because here electron density is less. This picture is like a banana, so it is also called banana bonding, known as 3C2E bond. Similarly, you can also have 3-centered 4-electron bond, which is happening in case of aluminium chloride. Aluminium chloride also in nature is not Lewis acidic, because its acidic nature is also satisfied because it exists as dimer. But because this aluminium is receiving 1 electron, so it is rather becoming tetrahedral. If it is AlCl3, normal AlCl3 will not be tetrahedral, rather this 3-centered 4-electron bond will make it bonded with 4 chlorines. So these chlorines are acting as bridged chlorines. I hope we are clear with this. Now, coming to the last topic of chemical bonding, which explains the molecular orbital theory details to us. Now, what does this molecular orbital theory tells us? Sir, we definitely know when electron functions, they participate with each other, the interference electron wave is nothing but orbital. So when 2 electron waves interfere, they can do so in constructive interference also, they can do so in destructive interference also. Like here 2 functions A and B are interacting and doing a positive overlap. Here 2 electron wave are interacting, but the interference is destructive overlapping. So constructive overlapping results to molecular orbitals which are of lower energy, hence more stable. Destructive overlapping of atomic orbitals result in formation of ineffective overlapping, and because overlapping is ineffective, as in overlapping is destructive, therefore they form molecular orbital which is called anti-bonding, having higher energy. And because energy is higher, so stability of these anti-bonding molecular orbitals are less. Now, why this molecular orbital theory came to picture is because of the fact that atomic orbitals, they participate and they form compounds in nature. Why? Because every atom wants to pair its unpaired electron. We know this. Magnetic properties are that whenever an atom is having unpaired electrons, it behaves paramagnetic. That means it is attracted by external magnetic field. And whenever atom has all paired electrons, it is diamagnetic. That is, it is repelled by external magnetic field. Sir, VBT says all atom make bonds to pair their unpaired electron. That means all molecule in nature must be having paired electrons. Like just for example, oxygen. Oxygen has how many unpaired electrons? 2. So it pairs with another oxygen. So at least O2 molecule must be diamagnetic. When we have gone to mother nature, oxygen gas became paramagnetic. It came out to be paramagnetic. So every VBT logic, hybridization logic was blown. So concept of molecular orbital theory came into picture, and they said no, atomic orbital don't participate in bonding, rather they have interference. They may be constructively interfered, they must be destructive interference take place, both takes place. Why? Because the number of participating atomic orbitals, whatever atomic orbital participate, equal number of molecular orbitals are formed. But now electrons will be filled in the molecular orbitals, not the atomic orbitals. For example, this is atomic orbital of first atom, this is of second atom. They are combining. Atomic orbitals linearly combine, so linear combination of atomic orbital, the Lacau takes place, and equal number of molecular orbitals are formed. Energy cannot be created nor can be destroyed. So let's say it is having 5 rupees. This atomic orbital is having 5 rupees. Example, this is also having 5 rupees. So how much money you have in total? 10 rupees. So let's say this will have 3 rupees and this will have 7 rupees. Ultimately, money cannot be created. So ultimately, over a money is 10 rupees only. But this is a bonding molecular orbital of lesser energy, so more stable. So this will be highly occupied molecular orbital, because electron will try to come to be filled here only. And of higher energy will be occupied later, so it will be least unoccupied molecular orbital. So these are also called HOMO and LUMO molecular orbitals. So this starts the molecular orbital theory. Whenever PP head-on overlapping takes place, molecular orbital are formed of this shape. So here similar shape represents that wave function are having constructive overlapping. This shows that they are having destructive overlapping. So constructive overlapping forms sigma 2p as in bonding molecular orbital. Destructive forms sigma estic 2p. Whatever be the molecular axis, generally as per NCERT we consider Z as the molecular axis. So when PP head-on overlapping takes place, bonding molecular orbital and anti-bonding molecular orbital are produced. These are the nodal planes. So bonding have 2, anti-bonding have 3 nodal planes, because they are getting farther from each other. Therefore, probability of finding electron is decreasing over here and increasing on that side. I hope these pictures are very useful for you. But yes, these logics are definitely going to help you. Beta, P block, Asif, you are coming from after long. See, just go to the recording which I have recently discussed. In all the topics of redox, periodic table, even this chemical bonding, I am including the block chemistry important topics in between. So there is no block chemistry separately, beta. It is even removed with NCERT. I have explained that previously also. So if you have gone somewhere, obviously for some dinner and all, then you can, after this live is ended, will end, you can watch the previous hour. You will definitely find in all the chapters, redox also, P block also, periodicity also, chemical bonding also, I have included all the block chemistry logic. So do not worry. You need to have a proper revision although. Now, formed now. Sidewise overlapping also can take place, like X and Y. So when constructive overlapping take place, bonding molecular orbital form pi 2px or pi 2py. This is bonding molecular orbital. When destructive happens, as in when plus is interacting with minus as an opposite wave notion, then they will get away from each other. So this forms pi estic 2p. So bonding molecular orbital, ND bonding molecular orbital. This bonding will have one nodal plane. This NT bonding will have two nodal planes. Very important point. Directly these nodal planes are also sometime asked. Now coming to for backlog beta you can see, but yes, patience and focus will definitely be required because this is an exhaustive session. I mean, you will not be completing this session with a smile on your face. Yes, a content will definitely come, a satisfaction will definitely come, a sense of winning will definitely come. But once you finish the complete session, if you're coming in between, then obviously because labor, hard work is always monotonous, hard work is always boring. So for all those people, hard work is always a boring thing to do, obviously. Now moving to the logic. Hydrogen, sir, that means hydrogen is having how many electrons? 2 electrons. But now electrons will be filled in the molecular orbital. So 1s will form sigma 1s and sigma asterisk 1s. How many electrons I have? 2. Where it will be filled? Sir, 1 and then 2. This is bonding, this is anti-bonding. Sir, now what to do? Conclusions. You can calculate bond order. How? Bonding minus anti-bonding electron upon 2. What else? You can find magnetic nature. If unpaired electron paramagnetic, if all paired diamagnetic. What else? You can even calculate magnetic moment. How? Under root n dash into n dash plus 2. What is n dash? Number of unpaired electrons. What else? If, sir, bond order is coming out to be 0 or negative, then molecule will not exist in nature. I hope we are clear. Now applying the same logic over here. Sir, this is hydrogen. How many? Sir, bond order 2, antibonding 0. So bond order is 2 minus 0 upon 2, as in bond order is 1. Sir, if it is forming H2 plus, then remove 1 electron. So 1 electron removed. So how many electron it is having? Total electrons it is having 2. It will have only 1. So this is 1 minus 0 upon 2, as in 0.5. What about H2 minus? 1 electron will be added over here. So it will have 3 unpaired electrons. So rather it will have 2 minus 1 upon 2. So again it is 0.5. So bond order is same for H2 plus also and H2 minus also. But who is having more energy? Sir, here in H2 minus, the third electron is acquiring high energy orbital. Sir, if energy increases, stability decreases. That means this molecule can be broken easily. That means the bond energy of this guy will be least and this guy will be maximum. Bond order, I can obviously see this is maximum and that is, so bond order is maximum, so bond energy is also maximum. Bond energy as in bond dissociation energy. Molecule is stable, you require more energy to dissociate bond because bond order is more. Now because bond order is more, so bond length will be less. It will have highest bond length because here energy is more energized, although bond order is same, but because of the presence of electron in the anti-bonding molecular orbital, energy will be increased. Now what about magnetic behavior, magnetic nature? Sir, H2 is diamagnetic, no unpaired electron, and while both of them are paramagnetic because both of them has one unpaired electron. I hope we are clear. Now this we have done. Obviously you can do for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, but till nitrogen you have different molecular orbital configuration, and after nitrogen you have different. For oxygen, fluorine and neon, the molecular orbital picture is first you fill sigma 1s, then you fill sigma asterisk 1s, then you fill sigma 2s, then you fill sigma asterisk 2s. After that, for oxygen you first fill sigma 2pz. So obviously sigma bond is the overlapped area is more, so because overlapped area is more, so bond formed will be strong. That means energy is less, that means energy this is less, so it will be filled first. And pi are weaker, so pi will be filled later. And obviously if destructive interference taking place, then I will not go bang or head on with plus will not go bang on with minus wave, because if you are doing head on overlapping as in sigma bond formation with electron wave having opposite motion, then they will directly cancel each other. So sigma asterisk will be highest and pi asterisk will come first and then sigma asterisk. So this molecular orbital electronic configuration is quite easy for us to understand. But what happens is, if the nucleus is quite lighter, not heavy, that is from nitrogen till lighter nucleuses, what happens is intermixing of 2s 2p takes place. As we know that for inert pair effect, we know as we move down the group, ns np energy difference increases. So inversely, if nucleus is very light, then energy of 2s and 2p is approximately same and they start intermixing. What does intermixing do? Energy of 2s gets reduced and energy of 2p gets increased. Energy of 2s, like I'll give you an example for this because no student understands this, they all learn it. I'm giving a trick, a common sense to learn this. Like for example, what is the electronic configuration that is very common for us? This. What I'm saying is, when nucleus is very light, not strong, like nitrogen and lighter nucleuses of diatomic molecule, then what happens is 2s 2p and they intermix. So energy of 2s decreases, energy of 2p increases. Like for example, this is 2s having 30 rupees, this is 2p having 90 rupees. I'm talking of molecular orbitals only. So energy, total money is 30 plus 90, as in 120 rupees. I hope you are clear. Now I am decreasing the energy of 2s. Let's say energy of 2s is becoming 15. So from 30 it has become 15. So how much money it has lost? 15 rupees. Okay, sir. Where 15? Sir, energy cannot be created nor can be destroyed. Add 15 rupees to this 90 rupees. So 50 plus 90 becomes, sir, 105. Now, my energy has reduced from 30 till 15, but still 15 is still higher than 10 rupees. 15 is still lesser than 60 rupees. 15 is still higher than 10 but lesser than 60, so its relative value will remain the same. But 1090 once become 105, 105 becomes higher than 100 rupees. 105 become higher than 100 rupees, and hence sigma 2pz is filled later while pi 2px and pi 2py are filled earlier. Therefore, this is called the intermixing. I hope with this money thing you are getting the idea that what actually intermixing mean. Now, point is, so whenever intermixing takes place, what is actually filled first? Sir, after sigma 2s, sigma asterisk 2s, this is the same, but after that pi 2p is filled and then sigma 2p. Why? Because of that intermixing thing, rest is all the same. Now, if we know this, can you tell me that what will be the, okay, the electronic configuration of C2 is homework for you. And yeah, after doing this, can you tell me what is the electronic configuration of, let me write homework over here. This is homework for you. Now, you will be getting, I mean, for those who are actually thoroughly watching this and actually want to do everything, so join us on our WhatsApp channel. These notes will be posted in the PW JEE English WhatsApp group once the live is done. Okay, now can you help me with this? Let's say just we'll do for nitrogen. Nitrogen is having 7, so N2 will have 14 electrons. So how to fill those 14 electrons? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. How to calculate bond order? Now I am giving you people Rato 5 so many formula. Why to Rato? So bonding, anti-bonding will be cancelled because bond order is NB minus NA. So cancel them. Anti-bonding here is not having, so how many bonding I'm having? 6. So 6 by 2 is 3. So bond order is 3. You can obviously calculate for plus, you can increase electron, decrease electron. So such variety of questions are very much possible for you. Hence I have written those data also. The basic structure I have given to you. Rest of the structure is obviously homework for you. Now, coming to after this energy level diagram, there is also now one more logic is very famous. People ask that, sir, halogens as an X2, they are diamagnetic. If you do their MOT, 9 for F2, let us do for F2. 9 and 9 is 18. if you have 18 electrons, 14 I have filled over here, 14 I have filled over here, 15, 16, 17, 18. Sir, 18, that means 18 will also be diamagnetic. Sir, you say if you are diamagnetic, generally you will not show any color. But if you have seen halogens, all halogens are colored. Fluorine is yellow, chlorine is green, bromine is reddish brown, iodine is violet. Why? So first point of difference is, we say that whenever we have unpaired electrons, generally you show color, because unpaired electron can easily undergo excitation. Once it undergoes excitation, it takes energy of visible radiation, and once it gains energy, remember the hydrogen spectrum, it gets excited and it gives back the energy and comes back to the ground state. So whatever energy I absorb and whatever energy I release are complementary. So there is a complementary color wagon wheel also, that if you absorb violet, you give away yellow. If you absorb red, you give green. If you absorb orange, you appear bluish, and vice versa. Like if you absorb blue, you give orange. So such wagon wheel is it is a general science, not an exact science, but yes, generally you can say that complementary colors are shown. And how to draw this wagon wheel? Just write violet over here and speak indigo, Vibgyor. Speak Vibgyor anyway, clockwise or anti-clockwise. So like here I have written anti-clockwise, so VIB, I and B, put it in the same group, VIB GYOR. So whatever lies opposite to each other are complementary colors of each other. This is a wagon wheel, which for some level of questions you should know this, that you absorb red, you appear green. You absorb green, you appear red. Now how does it helping us? It helps us in a very, this question was started by JEE Advanced. Now mains have also started inculcating. So if you are diamagnetic, then how come you are showing color? Ultimately excitation is taking place. Actually here excitation is taking place from, here excitation is taking place. See, if I am filling fluorine, electrons are filled till here. So for every halogen, it is filled till here. So this becomes their highly occupied molecular orbital, and this becomes their least unoccupied molecular orbital. This is highly occupied molecular orbital of halogen. This is least unoccupied molecular orbital of halogen. So although the electrons are paired, still some electrons can undergo excitation, because ultimately if you are showing color, electromagnetic transaction must be taking place. So these paired electrons also, under the influence of visible radiation for halogens, undergo excitation to where? To their highly occupied molecular orbital to least unoccupied molecular orbital. Now comparing the values also for you. So comparing values also, although this I have written, halogens are colored due to homo-LUMO transition. I have mentioned what are those homo-molecular orbital and LUMO-molecular orbital. So because of this homo and LUMO electronic transaction, you show color. Now can you explain this, that if you just observe, fluorine is showing yellow, general trend, iodine is showing violet. So just observe this wagon wheel. If somebody is absorbing yellow but showing violet, or rather if somebody is absorbing violet, so remember Vibgyor, who has highest frequency? Violet. So if somebody is absorbing violet, then it should show yellow. Who is showing yellow? Fluorine. That means it must be absorbing violet, which is highest energy. That means why fluorine is showing yellow color? Because of this observation, I'm saying the energy gap between highly occupied molecular orbital and least unoccupied molecular orbital in bonding molecular orbitals of fluorine is large, because this large gap can only be attained by an electromagnetic radiation of large energy. So highest frequency is violet, and as you are moving from F2 till fluorine, chlorine, bromine, iodine, the energy difference between HOMO and LUMO is decreasing. And why I'm saying it is decreasing? Because see, for iodine you are showing violet, you are showing a color which is having highest energy, that means you are absorbing a color which is having almost lesser energy. So the energy gap between HOMO and LUMO is getting shortened for the molecular orbitals. How we are predicting this? Using the wagon wheel complementary color explanation. A very important logic. Yes, this was an advanced question beta, but a highly probable question for JEE Mains. This was a statement based question. Sir, many of the students were saying, sir, statement based questions और करा दो. अरे करा दो means what? I will write those questions and will stand and will ultimately make you learn and see the theory. So rather I have chosen a path in IOC of making you all the comfortable logics of IOC, which are I feel are very relevant. Now, okay, so now some people are studying and okay. Sakshi Kale, thank you beta. Prashant Gupta, thank you beta. Study also. That will be a more gift, a better thanks from your side. You study, you go for your April exam, you attempt PYQs and then come in any of the maybe one shot or maybe live, and then comment and tell me what is your rank and how I have helped in the overall performance, because ultimately that is the goal. For that you have to keep working, guys, right? Now, sir, is this guys okay or more than necessary for NEET, sir? Beta, more than necessary. For NEET, if you need 40 rupees for NEET, then I may be giving 65 rupees. Yes, so matlab, if you want to study, because NEET also gradually every year they are increasing the level with which they are asking questions. So maybe yes. So now, for inorganic you should learn better. In fact, inorganic, I tell you one thing, coordination chemistry, I'll be teaching coordination. I am thinking that I'll be doing coordination also. Let me see, we'll be taking break because we have to extend, hai na? So point is, coordination, JTD, John Taylor distortion. The questions never has not came to JEE Mains, but NEET always asks John Taylor distortion. JTD, the trans effect in coordination complexes, NEET ask, JEE not ask. So in inorganic chemistry beta, I feel NEET is asking more questions. So we will not study JTD here in coordination complex, because JTD, no, I mean, one question came, that too, if you do not even know JTD, you can attempt that question. So for NEET, but it is coming prominently. The trans effect is also coming prominently. So yes, NEET, inorganic you should read. Now, coming to hetero. Now, actually, molecular orbital theory is valid for homonuclear diatomic molecules, not heteronuclear. So, for homonuclear diatomic molecules, you should know molecular orbital theory. It is only valid for that only. But what we do chori. We jabardasti apply, we any way apply molecular orbital theory for heteroatomic molecules. How? Through method of approximation. What we do is, what we say is that how many electrons nitrogen has? 14. So if we say if you have electrons more than 14, then you do electronic configuration like oxygen, as in sigma 2pz is filled first, then pi. Sigma 2pz is filled first, sigma 2pz is filled first. When to fill this first? When you have number of electrons greater than 14. So go for MOT of oxygen. And if you have number of electrons less than 14, then go for MOT of and if you have 14, then also go for nitrogen, as in pi 2px is filled, pi 2py is filled first, then sigma 2pz. That is you do for nitrogen. Now you calculate number of electrons, but still I'm giving you one trick also, that if you for bond order use MOT as I've explained, but for magnetic nature I rather suggest you still go with VBT. Why? For heteroatomic molecules, like for example, if I have HF, you tell me HF is heteroatomic. Yes. How many total electrons HF have? So fluorine has 9, hydrogen has 1, so 10. 10 is less than 14. Yes, so I'll fill till here. So 1 is sigma 1 is, sigma asterisk 1 is, sigma 2 is, sigma 8 gone. So therefore I have not written them. 8 gone. So 8 gone, 9, 10. They are cancelled also. So how many electrons you have over here? So 2. so 2 minus 0 upon 2, so bond order will be 1. But if you do this, you will say magnetic nature is paramagnetic, and actually the HF magnetic nature is diamagnetic. So how to do? That's what I'm saying. For heteroatomic molecules, if you are supposed to predict their magnetic behavior, then think of their magnetic behavior using VBT. Sir, how to VBT? You have FH, you have F. Why they are forming bond? To pair their unpaired electrons. So because their unpaired electrons are paired, so rather HF will be diamagnetic. So yes, it is diamagnetic, but it can be predicted once you give the magnetic nature of heteroatomic molecules using VBT. For bond order, you can apply MOT, like the number of electrons way, and these are some cases. You can obviously fill these columns, so this will be your homework rather than sir question though ABCD. Yes, we can do, but actually here this is more prominent. I hope we are clear. May reason I am joining Prayas only for you, sir. Oh ho, Sarvesh, thank you beta. I mean, you should apply, you should come for your betterment also, but thank you now, thank you beta. So at least we are having our prayas count, so let us increase that count, so that once we start meeting regularly, we will cherish every day and grow every day. Moving to for CO, I mean, this is a molecular orbit. Okay, this you can skip because we have already excluded time. This you can skip. You can obviously apply for a heteroatomic molecule what I have explained. This you can skip. Now coming to weak bonds. So weak bonds are van der Waals forces of attractions. So what are those? Van der Waals forces of attraction are nothing, but we know dipole by polarity plus minus attract each other. We know. So this is dipole attraction, but this is a weaker interval because this is not complete plus and complete minus. Partial plus and partial minus will have a force of attraction, but this force of attraction will be rather weak. The energy you can leave. That's why I have drawn that energy in a light, in a very lighter pen. So because I want that energy proportionality is valid, but what for advanced type of question. So you can leave that energy proportionality and just know that what are the weak forces. So these are physical forces which are responsible for making a molecule in solid or liquid or gaseous state. So dipole attraction, dipole and induced dipole. For example, this is non-polar molecule, but this minus will induce a plus. Yes, the magnitude of plus will be very less, but this dipole can induce a dipole in this non-polar molecule and have attraction known as van der Waals forces. What van der Waals force of attraction? Dipole, induced dipole force of attraction. Then you have instantaneous dipole attraction, and as in none of the molecule is polar, like no helium is polar, no oxygen is polar, but still they have nucleus and revolving electrons. So if in this instant electron is here, then it is not here, electron is here, then it is not here. So this instantaneous dipole will also have some attraction known as London dispersion force, again a weak force but a physical force of attraction. Then you have obviously an ion and dipole can attract each other because this is Coulombic force of attraction. Ion and induce, yes, an ion can also induce polarity in a non-polar molecule. So this again becomes the ion and induced dipole attraction. So this will also have some attraction forces, and these attraction forces are obviously weak bonds which are responsible for the boiling point, melting point and physical state. Like for example, I have ethyl bromides. So this is ethyl and this is bromide, and then I have hexyl, so I have 6 carbons. So although I know this is polar, plus minus, but the carbon chain is not polar. So who has, both have approximately dipole attraction, but who has higher dipole moment? Sir, this carbon chain will ultimately attract each other through London dispersion forces. So more be the surface area, more be the attraction force, and more be the attraction force, so difficult will be to bring them apart. So who will have higher boiling point? This. Generally we say higher mass, higher boiling point. What is the reason? The physical forces of attraction. Now once the compounds have same molecular mass, that means they are isomers. Like for example, I have N-butyl chloride as in this, or I have tertiary butyl chloride as in this, or I have isobutyl chloride as in this. So I know here surface area is more, here the compactness has increased, and here the It is in between. Here surface area more, here it is less, but this is more than this. So obviously this will have higher intermolecular force of attraction. So as branching, boiling point is inversely proportional to branching, because as branching is increasing, boiling point will decrease because the surface area will get reduced. So who will have highest boiling point? A. Post that, C, and least will be B. So how are we predicting this? By instantaneous dipole-dipole attraction. Now, one of the very famous instantaneous dipole-dipole, one of the very famous example of dipole-dipole attraction is hydrogen bond. Actually, hydrogen bond is also dipole-dipole attraction. But why it is not called dipole-dipole attraction? Because of the fact that this plus minus is not normal plus minus. The magnitude of plus minus is so large that it can't be referred as a dipole, because dipole is attracted by property of charge, plus and minus. And why this plus minus is so large? Because when hydrogen is connected with highest electronegative atoms like fluorine, oxygen, nitrogen, only in these cases, this plus minus is so large that now the same physical forces of attraction, the dipole-dipole attraction, the magnitude, the rassi, the rope has been made so strong that you can't compare it with a thread. Although a thread is also a rope, I mean, and a strong rope is also a rope. So the dipole-dipole attraction has become so strong that you call them hydrogen bond. Now, who has strongest hydrogen bond? Sir, HF. Less than them, HO. Less than them, HN. Why I'm saying less? Because, sir, fluorine is most electronegative. But so you know when dipole-dipole attraction can be called as hydrogen bond. But to hydrogen bond also we have two factors. One is extent and one is strength. Strength we have already seen. Whose strength is more? Sir, HF is more, then H2, then HO, then last is HN. But what is extent is your geometrically how many hydrogen bond you can make. Actually, what O bond H, as in water, can form 4 hydrogen bonds with another water molecules. HF can form only 2 hydrogen bonds. So this we have to know experimentally. Yes, because oxygen is tetrahedral, so it forms attraction also tetrahedrally. HF is linear, so it forms attractive forces also linearly. Ammonia, ammonia I'm not considering. Acha, that is H2O2. Okay, this is H2O2. So this H2O2 oxygen is also a tetrahedral, but 2 bonds it is already making. So every oxygen will have 2 H bonds. So I'm comparing HF and water also only, because a very famous example. Now, what I'm saying, who has stronger strength of hydrogen bond? HF. But like again, using money, everything becomes very easy. Let's say HF rope is strong because it has a strength of 20 rupees. Example. H2O, in H2O, hydrogen bond is HO. Let's say it is a strong rope, but rope is of 15 rupees of strength. Water, I'm saying, is making how many H bond? 4. But these H bonds are what? O bond H. So 4 into 15 is 15 into 4 is 60 rupees. HF individual rope is strong, but how many rope one molecule is making with another molecule? 2. Rope is strong. How many? How much? 20 rupee rope. But 20 to 20 is still 40, not 60. Therefore, if you compare the overall boiling point, this factor and this factor combined will give you the answer. And therefore, once you see the boiling point, even HF has a stronger H bond, but overall, who has a higher dipole moment? Water has, by boiling point, water has a higher boiling point than HF. Water has still higher boiling point than H2O2. An important conclusion and application of hydrogen bond. So at last, van der Waals force is weakest, then you have dipole-dipole attraction, and the strongest intermolecular force of attraction is H bond. This H bond is so strong that hydrogen bonding is even regarded as a chemical bond by some. So now, hydrogen bond can be hydrogen bond can be happening within a molecule, so intermolecular. And it can also be intermolecular but within different molecules. So this is heterointermolecular and this is homo, like HF having homo intermolecular. Water and alcohol, We know organic compounds are soluble in water. Why? Because they have hydrogen bond, but one molecule is having hydrogen bond with another molecule. So this is also intermolecular hydrogen bond. But intermolecular is also homo also, hetero also, and we have intramolecular hydrogen bond also. But intramolecular hydrogen bond only happens when you have a chelation effect, as in a ring formation effect. Like salicylaldehyde can form a ring, like orthonitrophenol can form a ring, like this if you have ortho and para isomer, then ortho will have intramolecular hydrogen bonding while para can't have. So para will have intermolecular will bring these molecules closer, so intermolecular will have high boiling point. If you have high boiling point, then you are called a low volatile substance. So this becomes less volatile because of intermolecular hydrogen bonding. This is more volatile because of intramolecular hydrogen bonding. A very famous and basic points which are asked now. uh, Obviously, the block chemistry logic somebody was asking. So see, I'm including every block chemistry logic. Sir, we know down the group mass increases, so boiling point, melting point all increases. So definitely if you compare it for hydride, so you can obviously see it is increasing. No doubt it is increasing, but it is increasing once you are not comparing NH3 and H2O, because NH3 and H2O will definitely have higher boiling point than you expect. Why? Because they do not attract each other with simple dipole-dipole attraction. Rather, they attract each other with strong hydrogen bond. This finally finishes our chemical bonding also. This I have reached to my last slide, you can see, and now we will start. We will take 20 minutes break, and we will start with D block and coordination. I guess it will take around 2 hours, so I have to take a break, and but we'll finish it. So it will further take 2 hours, coordination and D block. If we maintain a speed, then we can cover it in 1.52 hours we can cover. So because all the logics I've already discussed, so D block and coordination we can obviously do with a quicker time. So we'll meet after 20 minutes. So I just, maybe the screen will be going, but I'll be coming back. Okay. So we will meet at 11:50 p.m. Okay, guys, break. हेलो हेलो। हाँ स्टार्ट कर दीजिए। हाँ मैं सामने ही हूँ। यार अभी 2 घंटा लगेगा यार, मैं कोशिश करूंगा लेकिन मैं बंद खुद कर दूंगा, अब आप वेट मत करना, अब आप सो जाओ। हाँ बस आप शाहरुख का नंबर है ना, शाहरुख या सौम्या, या आप ग्रुप में हो? हाँ तो उनको बोल दीजिएगा, उनका नंबर है ना। हाँ तो सौम्या को बोल देना, और लाइव बंद करना पड़ेगा, 2 बजे तक करना है ना? स्टार्ट कर दो। Yes guys, so I am back. I was actually waiting for this. Teacher will be back soon to be removed, and it has been removed, so welcome back. Who all are waking up with me, or maybe you are waiting for the recorded version? I mean, you obviously recorded can also be helping few, because even I as a student, if you ask me, I like seeing stuff with a 2x speed, especially when I'm revising. So I'm having any friends who are watching me live, so you can obviously put a comment and say, sir, not sleeping. And because see, uh, we'll definitely take around 1.5 hours from now, because DNF block is a very important topic, and because P block and S block, the block chemistry has been removed from NCRT. Yes, Sailesh, perfect. So Sailesh, as I was saying, that because block chemistry is removed, so DNF and coordination, if you say January attempt, the questions from DNF block elements, I mean, we had uh, in on an average, you can obviously say 5 questions from DNF and coordination. So 5 question is a lot. So we have to respect the topic, and because it's a commitment that I'll be covering whole of inorganic, so let us finish with the commitment. So maybe another 2 hours, maybe I'll try to make it 1.5, because obviously I have included few of the good topics, but those topics from the January attempt paper also, we can definitely say that those topic can be skipped. So sir, why you have taken those topics? Because DNF is valid for advance also, and because I was preparing, whenever as a teacher you prepare your presentation, you always think of the maximum possible extent. So starting with the DNF block element, because the periodic table we have already seen that the 3D series, the 4D series, the 5D series and 6D series, they constitute the D block element. Lanthanum and actinium, although they are studied along with lanthanides and actinides, but if somebody is asking you to which block they belong, then they belong to D block element, because the last electron enters into D subshell. So they are not F block element, they are D block elements only. But yes, their properties are quite familiar with the lanthanoids and actinoids, therefore their chemistry is studied with lanthanoids and actinoids, but they are, at end of the day, they are D block elements. Now moving to okay, lanthanoids, actinides we have already seen. So this periodicity we have seen. Coming to the D block element, now old theory just said that because D block elements come in between S and P block element, so because they are lying between the representative elements, so they show a transition from of property from S block to P block. Like S block has as are highly reactive metals and they are least reactive metals. So the property has a periodicity, but the periodicity gradually undergoes a transition from the D block, and therefore D block are termed as transition metals. But the modern definition, the new theory of transition metals is, what are D block elements? When the last electron enters D subshell, then you are a D block element. What all D block elements can be termed as transition elements? Who have empty d orbitals or who have partially filled d orbitals in their d subshell so that they can take part in bonding, then the d block element is termed as a transition element, otherwise not. So sir, there are some transition elements which are not regarded as, there are some d block elements which are not regarded as transition elements. Yes. Who are them? Zinc, cadmium and mercury. The group 12 elements are d block elements, but they are not transition elements. Why? Because of the reason they do not have any partially filled d subshell, d orbital in any of their oxidation state. They show +2 oxidation state. So even after showing +2 oxidation state, they have n-1 d10 configuration. So they are d block, but they are not transition. Such questions are asked by JEE, that choose the correct option of the following which have D10 configuration. So who all have D10 configuration? With D10 electronic configuration. So copper has D10, yes. Zinc has D10, yes. Zinc, cadmium, mercury. So cadmium also has D10. Now just copper, silver, gold. So copper and silver will have D subshell that is completely filled. So your answer will be beautifully option 2. I hope we are clear with this. Now, moving to the another question. The question says, Mn+2 compounds are more stable than Fe+2 compounds towards oxidation in their +3 oxidation state because. Now, if we see, we have already seen electronic configuration. So Mn is nothing but 4s2 and 3d5. Once it attains Mn in +2 oxidation state, what electron is removed? The valence shell. So 4s electron will be gone. So they'll have a stable 3d5 half-filled configuration. But if you see Fe+2 compounds, so Fe+2, Fe has electronic configuration of 4s2 3d6. So rather, if you have Fe+2, so 4s electrons will be gone. It will be left with 3d6, which is not having any great stability. Any great? Yes. So obviously the answer will be 3d5 configuration is more stable than 3d6. 3d5 configuration is less stable. So Mn+2 compounds are more stable because 3d configuration is more stable than 3d6. Therefore, Mn+2 compounds are more stable. I hope we are clear with this. Now, sir, you will teach all physical, inorganic or organic just in this live? Yes. Today we are finishing inorganic chemistry. In the next live, we'll be discussing organic, and post that we'll be discussing the last day 3 live. We'll be discussing physical chemistry, all the physical chemistry logics. Physical chemistry 3 chapters I've taken with the inorganic only. That's why I guess it has taken more time, or else it will be covered in 8 hours. I mean, a job, but it can be covered. Huh? Moving to the next question. The next question says total number of ions. Now in D block, I'm starting with questions only. Now why? Because all the logics we already have. So we are directly applying those logics, and smaller things will be asked from D block which are requiring some of the block chemistry logic of D block. So the total number of ions from the following with noble gas electronic configuration. Now noble gas electronic configuration, who can have? If we are talking of D block element, then sir, the terminal elements, for example, strontium, sir, strontium is alkaline. Kash, beta mange car scooter. So obviously this will have inert electronic configuration. So 1. Cesium +1 will also have, because it is alkali, it will also have inert electronic configuration. So 2. Lanthanum has 6s2 5d1, so its +2 will still have 1 unpaired electron, therefore it will not have inert electronic configuration. Similarly, Pb+2 we have already seen. See, now things are becoming easy. It will have a not, it is a stable electronic configuration, but due to inert pair effect, it will not have a noble gas configuration. So this is also cancelled. Now Y symbol is known because YB. How you now? Where is YB? It is atomic number 70. So atomic number 70 YB. You can go with the periodic classification. So YB, where you find YB? YB you can find here. Sir, how to remember this YB? Like the rhyme. That's why I've given the rhyme. Rhyme you should learn by heart. What is rhyme for the lanthanoids? सीना पार नदियां PM की समाई, यूं गदगद तब दिल ये हुआ, अरे तुम ये भी YB लूट लो. So YB will have what electronic configuration? Sir, 6s2, the sixth period, then 5d1, and after that this is 4f13. Now definitely because it is 4f13, so we know that that exceptional electronic configuration, that this 1 will be coming over here. So this will be actually 6s2 and 4f14. Actually this is not an exception. If you go by Aufbau rule, what has to be filled first? 6s. After that 5d will be filled later. After that 4f should be filled, but only one, which is lanthanum and actinium, they are filled. So in fact their filling is not in accordance with Aufbau. So actually this is the probable electronic configuration, not a exception rather, if you just go by Aufbau principle. So this should be its electronic configuration. So if you take YB plus 2, then 2 electrons will be gone, and if 2 electrons are gone, then what electronic configuration you have? 4f14. And this 4f14 will give you a stable electronic configuration, although it is not inert, because the inert gas will be lanthanum giving 3 electrons and forming the inert configuration. This will be a pseudo inert configuration, not the noble configuration. So obviously if you know that configuration logic of periodicity, then you can obviously say yes sir, YB is also not inert configuration, and obviously iron is not. So how many inert configurations I have? Only 2. So I hope we are clear with this also. Now coming to the theory, the theoretical part. Now such questions, I have taken few questions, but that conceptualization is happening with too many questions. So logic you know, and then you apply that logic in whatever questions. You will definitely find some questions, all the questions of these format only. Sir, tomorrow is maths class. Yes beta, tomorrow is maths live, and after that physics, then after that again I'll be coming. Now talking about the physical properties, so first point is nearly all transition, they have metallic properties. So what properties metal have? High melting point, high boiling point, tensile strength, ductility, malleability. So all the properties of metal. So these transition metals are also typical metals, showing all the metallic properties. Yes, with an exception of zinc, cadmium, mercury, and one more element, which is manganese. Why manganese? Because of stable half-filled configuration. These 4 elements, they have one or more typical metallic structures at normal temperature. All the elements actually, if you take these transition metals and see their atomic structure, see their molecular structure, then they correspond to a structure of a crystalline solid. Although solid state is removed from syllabus of JEE Mains, but it is there in advanced syllabus. That close pack structures are simple, cubic, BCC, body centered, face centered. So all these transition metals have those close pack structures, while with the exception of the zinc, cadmium, mercury, and manganese, all of them have, but because they are actually not regarded as transition, these three, manganese is a transition metal, but they also show a normality. Like other transition metals, they do not have that similar close pack structures. Now next thing is D block metals, with exception of zinc, cadmium, mercury, are very much hard and have low volatility. Their melting point or boiling point are high. Now why the zinc, cadmium, mercury? Obviously because you already know they are highly volatile. They can be easily the temperature, their boiling point, melting point is low. Now why? Actually, for D block elements, the melting point and boiling point largely depends upon the number of unpaired electrons. Why? Suppose you are a atom. Why you form bond with another atom? To pair your unpaired electrons. So when a metal pair its unpaired electrons, then whatever bond it is forming, the same attraction of a covalent compound is attained when by a metal is termed as the metallic bond. So who all transition metals can form? Okay, Prince, I can't, because you can't, because you have your paper on the month of April. So I can't, and even you should not. Then sir, what about polonium for more structures? What about polonium for more structures? See beta, whatever transition and inner transition metals we have, because they are lying in between, so obviously they make a transition in their properties. You cannot find exact periodicity in them. Then sir, why do we read periodicity? Because some of the properties can be easily periodicity based properties can be found and extracted out of them, and questions. There may be crores of exceptions. Obviously there may be crores of properties which will not find the periodic arrangement in our NCRT. But yes, in applied science, all these things are obviously studied, and you make lot of discovery out of them. But obviously as per NCRT, we try and find out questions and logic only on those area which can be related to chemical bonding. That's why, do not, there may be so many exceptions, but those exceptions are not loved by even NCRT and even JEE. They usually focus on the periodic trends, and if the periodic trend is not followed by some and provided that those details in NCRT, then we obviously discuss, like we will discuss some exceptions, but some exceptions, not all. Right now, hi sir, I'm back. Okay, Dubeji, perfect. Now, so the ability to form metallic bond increases when number of unpaired electron increases. So let us see the 3D series, because 3D series is the most famous, most asked. Now, as we move from scandium, which is having 1 unpaired electron, till chromium, which is having 6 unpaired electrons, so number of unpaired electrons increases from silicon to from scandium till chromium. Post that it decreases, because then D starts pairing up. So similarly, the ability to form more metallic bonds first increases till middle, and post that it decreases, and so will be the trend of the melting point of transition metals. First it will increase, later it will decrease. See, the periodicity here also, it is not continuous for the whole series. It is increasing till between, and after that it is decreasing. Why? Because of the presence of unpaired electrons. I hope we are clear with that. Now, moving to the actual melting point trends, obviously I have told you that first it increases and then it decreases. So this is regarding the 3D series. Yes, this is regarding the 3D series. So let me write it. This is 3D, this is 4D, and this is 5D. Sir, why the melting point is increasing down the group? Melting point is increasing down the group because number of metallic bonds are same. But as you move down the group in a D block, we definitely know Z effective increases. What is Z effective? Z effective is Z minus sigma. So when you go from 3D to 4D, number of protons are increasing, electrons are added up, but they are added in D subshell, the inner D subshell, and inner D and F has poor shielding. Therefore, Z effective is increased. If you talk of 5D, then Z effective is increased to the more largest extent. Why? Because now the lanthanoids are also filled. So 14 extra proton filled, 14 extra electrons also filled, but they are filled in F, which is having more poorer shielding. Therefore, Z effective increases. So the same atom has a stronger nucleus, which will now allow the formation of a more stronger metallic bond. So if I held the another atom of my type with a stronger force of attraction, then the metallic bond will be more stronger. As a result, it will be more difficult to break the bond. Therefore, down the group, melting point is increasing, but the trend is same, increasing till the middle portion, and post that it decreases. Yes, you will definitely find a dip. Like for example, melting point is increasing till chromium, and you find a dip in manganese. After that, Shakti Walker, Man, then again Fe, and then it is gradually decreasing. Similarly, you find a dip, you find increment till beneath chromium, you find molybdenum. Yes, and again you find a dip like manganese, then again it is gradually increasing. Although, I mean, this is God's grace that no exceptional dip is seen in case of 5D series. Sir, why there now? What is the famous question? Why there is a dip in manganese? So why this manganese is having a dip? Again, we know manganese has what electronic configuration? 3d5. Similarly, molybdenum. After molybdenum, what will come? Yari zara si nibha maut tak. So this is TC. So TC will also have stable half-filled electronic configuration. Now because of the stable half-filled electronic configuration, because of the stable half-filled electronic configuration of this manganese and technetium, TC, half-filled electronic configuration will allow their electrons to be stabilized in themselves. So why will they start to behave as a atom who will try to find a metallic bond with another because I am happy within myself? So therefore you find a dip in manganese and TC because their half-filled configuration allow the electrons to stay in their position and they have lesser tendency to form metallic bond because they are happy within themselves. That is what the actual meaning of stability. Stability means you are stable within yourself and you will have lesser affinity to interact with the outside environment. I hope we are explaining that dip properly, guys. So again, coming back to this now if what is another question that is formed out of this logic is who has the minimum boiling point? So obviously we know those who have no D, those who have all 3D10 configuration or 3D10, 4D10, 5D10 are nothing but copper, silver and gold and zinc, cadmium, mercury. Sir, why not zinc, cadmium, mercury taken? Because they are not even considered as transition elements. So I have taken copper, silver and gold because they are obviously zinc will have even lesser, but zinc, this coinage metals I have taken deliberately because ultimately if you see that among copper, silver and gold, who is having highest melting point? Copper. Post that you have gold and minimum melting point is attained by silver. So this copper, silver, gold trend, that who is having highest melting point? Copper, then gold, then silver. So this is 3D, 5D and 4D. And once you talk of zinc, cadmium, mercury, although they also in their respective period, they have minimum melting point. But what about their relative values? Zinc has, so this is 3D, this is 4D and this is 5D. So this is a gradual anomaly, although we definitely know mercury in room temperature is also liquid. So obviously its melting point will be lowest. But there is an anomaly with copper, silver and gold also, that gold has higher melting point than silver, a point which is also mentioned as a structure, as a graphical structure in NCERT, and I feel it is a point to note. Moving to atomization. Now what is atomization? Actually beta, atomization is also if I have a solid metal and that solid metal is converted to a gaseous metal, then the amount of enthalpy change required for such process can be also termed as enthalpy of sublimation, but technically it is also termed as enthalpy of atomization. So this enthalpy of atomization will also depend on what? Sir, if you are having a stronger metallic bond, then your enthalpy of atomization will be large, and therefore enthalpy of atomization will also follow the same trend as in it will increase till the middle and post that it decreases. Now a point to note over here is the value of for 3D series increases till vanadium. So who has the highest value of enthalpy of atomization in 3D? Not chromium, not manganese, rather vanadium. This is an exception which you should learn, and obviously post that decreases. So who has the minimum? Zinc. So actually zinc is many times asked by NTA, but yes, highest in 3D series is vanadium, not chromium. Sir, why? Actually this is just a physical fact as per the value of enthalpy of atomization. So this is rather a thing that you can say ki sir yaad karna padta. Yes, certain things are important. So as you move along the period, it should increase, but it increases, the enthalpy of atomization increases till vanadium, not chromium. Reason I've already given you. More be the number of unpaired electrons, more will be the metallic bond, more metallic bond, so more melting point, so atomization will also be larger. I hope it is clear. Now, talking about the periodicity of atomic size. Now, here also there is no proper periodicity. Why there is no proper periodicity? Because as we know, along the period size decreases. Size decreases. Why? Because Z nuclear charge increase and sigma decrease, so nuclear Z effective becomes strong, and Z effective becomes strong, so size decreases. But it decreases till middle. It decreases till middle. Post that it becomes almost constant. Why? Because we definitely know Z effective is Z minus sigma. So once we are moving along the period, Z is increasing, Z effective is increasing, and shielding is very poor. Agreed. Shielding is very poor, as in I am giving a punch with 1 rupee force. As you come in middle, the number of d electrons who are applying 1 rupee force, at least they are also increasing. So if I punch a person with a 1 rupee force, if I'm accompanied by 6 or 7 friends of mine, they will also punch with 1 rupee. So ultimately I'm punching with 7 rupees. So once you move along the period, the shielding, although poor, but shielding start increasing so that it compensates the increase in Z, and therefore the size almost becomes equal. And once you go to the end, that is till zinc, copper and zinc, the whole d electrons are filled, so now they overcompensate the increase in Z, and now the shielding dominates. So shielding will shield attraction between nucleus and valence electron, and therefore you see an increase in size for zinc and copper. So what is the periodicity? It decreases along the period. In between, in the middle, it becomes constant, and at the last, with D10 configuration, it increases. I hope we are clear with that also. Now, talking down the group for atomic size, down the group size should increase. So from 3D till 4D, you find an increase in size with the same periodicity. But size of 4D and 5D are same, which we have already discussed, is because of the lanthanide contraction. Because after filling of lanthanum, the 14 electrons are filled in lanthanoids. So Z effective is increased tremendously, and therefore the size of 4D and 5D are approximately same. A very important point, that is the lanthanoid contraction. I hope we are clear with this. Now, let me read some of the students who are waiting with me, who are learning with me. Shivansh is saying, sir, I got 92.48 percentile in first session. Will I be able to score? Yes, definitely, beta. You will be. What you have to do is, these live sessions, practice PYQ, not 99, more than 99. But yes, do that religiously, and whatever you read, revise it properly. Revise it the next day, so that whatever things you are learning, they should be kept with you in your head. And to organize in your head, revision, proper revision is always required, beta. Sir, how do enthalpy of atomization differ from ionization enthalpy? Enthalpy of atomization is nothing but enthalpy of sublimation. So it is changing a solid metal into a gaseous, not ionizing. Ionization is removing electron. It is just changing its physical state. So enthalpy of atomization is more or less a physical change producing property, while ionization is a chemical change inducing property. Videsh, I hope it is clear. Now, moving to this, we have already seen. So for 3D series, 4D series, 5D series, we know 3D, 4D size is more, 4D and 5D have equal size. Now, again, some questions. The element which shows only one oxidation state. So who shows only one oxidation state? Scandium. Why? Because only +3, then it attains inert configurations. Then why it will show any other configuration? Why other d block elements show variety of oxidation state? Because they have variety of d electrons in them. Scandium only has one, so it cannot show variable oxidation state. The transition metal has lowest enthalpy of atomization. So who has lowest enthalpy of atomization? The one that is having no unpaired electrons, that is D10 configuration, so zinc. Now such easy questions are coming for your D block elements. Now arrange the following elements in order of increasing number of unpaired electrons attained by them. So scandium has how many unpaired electrons? 1. Chromium has 6. Vanadium has Shakti Walker. Okay, so this has Shakti Walker Man Fe Ko Ni. Okay, so this is 1, 2, 3, then this is 6, then this is 5, then this is 4, then this is 3, then this is 2. So chromium is 6, vanadium is 3, titanium is 2, manganese is 5. So highest is chromium as in B, highest is B, and lowest is titanium as in no, lowest is scandium as in A. Then you have D, then you have C, then you have E. So obviously option 4. So these are some questions. Yeah, perfect, Shivansh, perfect. Now moving to the next question. Now density periodicity is very common. Why? Because density is mass upon volume, mass, nuclear charge is increasing, so mass is increasing along the period. What about volume? Sir, in general, along the period, size is decreasing. So volume is decreasing. So ratio is density. So numerator increases, ratio increases. Denominator decreases, ratio again increases. So density gradually increases along the period. And the decrease in metallic radius coupled with increasing atomic mass results in the general increase in density of these elements. Thus, titanium to copper, yes, have significant increase. If you can observe, I'm writing till copper because all the periodicity happens till copper, because zinc, cadmium, mercury are not regarded as transition metal. In fact, zinc has the lowest density because see, its size is also increased. So because size is increased, so volume increases by a factor of, volume is 4 by 3 pi r cube. So volume increases by a factor of cubic unit. And therefore for zinc actually it is having the least density. Important point to note. And obviously that was a JEE question also, that who is having correct order. So we definitely have Shakti Walker, Manfe Koni, Sujan. So this is right, but zinc should be lowest. So answer will definitely be option 1. I hope we are clear with this. Now talking about ionization. Now somebody was talking of ionization, so what to say about ionization enthalpy? Although because this is D block, so there will be no specific periodicity, but yes, you can obviously generalize with the statement that once you move along the period, we know in general atomic size is getting decreased. Yes, I know after that it becomes constant and after that it increases, but this is in general. Atomic size decreases. So because atomic size decreases, therefore I can say ionization, that is amount of energy required to remove electron because size is getting smaller, so it should definitely increase. And what can you say down the group for ionization? Sir, for down the group atomic size, what can we say? So 3D and 4D. So size of 4D is higher, is larger. So 3D, 4D. So size is increasing, but 4D and 5D has same size, and although its Z effective is very increased. So as size increases, this should decrease, and it decreases also. But from 4D to 5D, it increases. Why it increases? Sir, because Z effective is increased to a very large extent. So what is the general idea for ionization? General idea is along the period it should increase gradually, with some exceptions, but in general it increases. But down the group, actually this fifth 5D series has highest ionization. Why? Because Z effective is increased. So it becomes so large that it almost supersedes value of 3D also. Post that you should have 3D and lowest will be 4D. So this is the generalized. I'm not saying here also you will find some exceptions, but this is the general idea of ionization enthalpy down the group and along the period. I hope we are clear with this. Now, if we are clear with this knowledge, sir, tell us some exceptions, because these exceptions are good. Scandium, ytterbium, as in the third group, they are just starting the D block, so they have not got that huge Z effective. It is just starting, so they should follow the same periodicity for ionization. So what is the periodicity of ionization? That down the group ionization enthalpy should decrease, and it decreases for them. Although for the general trend we have seen it's an exception, because the general trend is this: 5D should have highest, then 3D, then 4D. But for scandium, because they are just starting, so they are not having any Z effective advantage, Z effective increased advantage, therefore they will show normal periodicity. Now another exception is this: some people learn it by 5, 6 and 10, the group number 5, 6 and 10. Some learn it with a rhyme VCN, that the V vanadium, C chromium, N nickel, these groups also have exception from that general trend of ionization. And what is the exception? That this value increases. If somebody is putting hands on your neck, no, no, give me some reason, then obviously you can say, then obviously you are expecting, we are expecting 5D to be highest. 5D is highest only, but there is anomaly between these two. We are 3D should be more and 4D should be less. So we definitely know what is the electronic configuration of palladium. So this is 5s0 and 4d10. What is this? This is 4s2. Okay, this is 0, I'm sorry. This is 4s2 3d8. So because it has a stable electronic configuration, so amount of energy required to remove this fully filled electron will be higher. So if somebody is putting neck on your shoulder, on your neck, that no, give me a reason, then obviously you can also rectify and conceptualize this exception. The exception, the general that we have made, it is simply increasing down the group because of such reason. I hope we are clear with this. Now moving to some type of questions for D block elements, like these are the questions which is asked. Now chromium and copper have high value of second ionization enthalpy. Why? Sir, high value of second ionization, sir, this is very easy. Chromium has electronic configuration of 4s1 3d5. So chromium plus will have 3d5, which is stable half filled. Similarly, copper has electronic configuration of 4s1 3d10. So copper plus will have electronic configuration of 3d10. So this stable half filled and this stable fully filled will obviously require more energy. So the second ionization enthalpy will be much larger. I hope we are clear with this. So these logical and simple questions are dealt in D block elements. Now manganese, zinc have high value of delta IE3. Now this is also very easy. Manganese and zinc, post removal of 2 electrons, manganese plus 2 will be 3d5 half filled, zinc plus 2 will be 3d10 fully filled. So I mean the similar explanation is happening again and again. Moving to next slide, which says +3 oxidation state is not shown by copper and zinc due to high value. Yes, because after +2 their electronic configuration becomes stable, very stable. Although for copper, after +2, copper +2 have 3d9 electronic configuration. But what about the third ionization energy? The third ionization energy value for copper also and for zinc also becomes so large. What is the actual reason behind that? One reason is their experimental data, and second reason is, sir, obviously we know successive value of ionization increases. So for them it increases to such a large extent that they do not show +3 oxidation state. A simple explanation. Now, sir, what is the correct order of ionization? Sir, we have already conceptualized that along the period ionization should increase. So let us see where we are seeing those exceptions. So this is increasing, good. I have an exception for vanadium, it is decreasing, then again increasing again. For cobalt and nickel I have an exception, then again it is increasing. So exception is happening in vanadium and cobalt and nickel. Actually, if somebody is asking you that why it is an exception, although this is as per the data, so there is no periodicity as such in the atomic size also, therefore certain variations are seen. But again, if somebody is putting a statement based questions in front of you, that is grabbing your neck. So how to accommodate that explanation? Now we have definitely known the concept of exchange energy. Let me help you with that concept. Like for example, I have vanadium. So vanadium has electronic configuration 4s2 3d3. Now once you find vanadium plus, what is electronic configuration? What is electronic configuration for vanadium plus? For vanadium plus, electronic configuration is 4s1 3d3. Now as soon as it becomes 4s1, we definitely have this idea that this s can migrate. So this x actually migrates and become 3d4. As soon as it becomes 3d4, you have 1 2 3 4. And if we just see this 3d3 configuration, this is, now what is exchange energy? Sir, all the d electrons, they if they are present in degenerate orbital as an orbital having same energy, then they can have exchanges. Like this guy can exchange with this one and this one because energy is same. So you are living in a township where you are having different bungalows and all bungalows belong to you, so you can sleep sometime here, sometime here, so you can always have an exchange because they are your only, they are degenerate only, they are similar energized only. This guy can exchange only with this because that exchange I have already counted. So what are the total exchanges I'm having in 3d3 configuration? 3. Once vanadium plus is formed, what is the total number of exchanges? This exchange with 1 2 3. This guy exchange with 1 2. So here 3 exchanges, here 2 exchanges, and this guy can exchange with this. So here 1 exchanges. So total exchanges over here has been doubled. During these exchanges, when electrons are moving, they will release energy because of the movement. Energy getting released. Energy getting released, that means system getting stable. For example, let's say with every exchange 10 rupees is released. Example. So here how much energy is released? 30 joule. What about here? Sir, here 60 joule of energy is released. So what I'm saying is that converting vanadium to vanadium plus may be requiring 100 rupees. Maybe amount of energy required to ionize is 100 rupees. But here you do not have to supply 100 rupees. Why? Because 60 rupees is given out by the exchange energy. So 100 minus 60, I just have to supply that extra 40 rupees. So it will just take that 40 rupees and will get ionized. Hence, it has a lesser value of ionization. So why it has a lesser value of ionization? Because the number of exchange, the amount of exchange energy released more than compensates for the amount of energy required for ionization. So this emphasizes the concept of exchange energy in d block elements. I hope we are clear with this also. Moving forward now, certain such questions are asked that the transition metal having third highest ionization. So after +2 you should have a stable configuration. So who has the most stable +2? Sir, manganese has the most stable +2. So removing third electron will be very difficult. So answer will be manganese. Simple. Now a transition metal M among scandium, titanium, vanadium, chromium, manganese have highest second ionization. So who has highest second? After removing first electron, you should have a stable electronic configuration, which is clearly of chromium, because after removing one electron, it will attain 3d5. So it will have highest ionization energy. What ionization energy? Second. That means we are talking of chromium. The question is not directly telling you chromium. With theory, it is giving you chromium. Now, the spin only magnetic moment value of Mn plus is, now if I'm having chromium plus, then I'm having 5 unpaired electrons. So value of magnetic moment will be under root of n into n plus 2, as in 7 5s are 35. So under root of 35, which is 5 point something, close to 6. So your answer will be 6 Bohr magneton. Easy. But yes, not easy because it is a statement based question. So here you have to read and analyze and then conceptualize your answer. So theory is also important, and then basic mathematics. Now, what about oxidation state, sir? You already know, we already know that for D block element, why they have tendency to show variable oxidation state? Because they have variable valence shell electrons. For them, Ns is the valence shell. For them, Ns is the valence shell. But N-1 D electrons also behave as valence shell electron because D has no penetration. D is more and more associated to the outside world. Therefore, both Ns and N-1 D electrons can participate in bonding. So when only Ns participates, some other oxidation states, when they also start participating, so tendency to show variable oxidation state is a property of D block elements. I hope it is clear. Now, if you move down the group, like for example, they all have a tendency to show variable oxidation state, but for P block element down the group, what we used to say, that down the group stability of group oxidation state -2 increases, the inert pair effect that we have done. But for the D block elements, as you move down the group, Z effective increases. And because Z effective increases, so they can have even more polarization power, those cations. Therefore, for D block elements, as you move down the group, their stability of showing the maximum oxidation state increases. So ultimately, if you talk of, let's say, if I'm talking of chromium only, so chromium, molybdenum and tungsten. So if we are moving down the group, then let's say I'm talking of +6 oxidation state. So who has the most stable positive oxidation state? Tungsten. So stability of highest oxidation state increases down the group. And why does it increase? Because Z effective is highest. So this is just opposite of inert pair effect, which used to happen in P block elements, because for them inert pair effect used to play effect, which says stability of lower oxidation state increases down the group, but not the other way around over here. Some statement based, some factual based questions are RU and OS in fact have a tendency to show the highest oxidation state, which is +8, which you can leave also, but yes, it is a factual NCERT fact as per the compounds that are formed in nature. Now, this table, we can obviously feel the tendency to variable oxidation state increases till manganese because unpaired electrons increases, and post that it decreases. Scandium and zinc are the 3D series element which show only one oxidation state, rest show variable oxidation state. Now this chromium, molybdenum and tungsten thing I've already written, so this I've already explained. So oxidation state is the more positive oxidation state is shown by elements down the group, not in the 3D series. Now, sir, what is this crystal field stabilization? Why? Because I'm mixing coordination chemistry also. Suppose a D block element is using its empty d orbital to form a complex. What is a complex? I am a metal having empty orbital. That means I can accommodate electron, I can receive electron, so I can behave as an acid. Or rather, I can behave as a positive center. Metals are forming positive oxidation state, so plus. Now, there are ligands. Ligands are like bases which are having excess of electrons, so they can coordinate that their excess of electron, and those are termed as ligands. So when metal ion and ligands, they attract each other, this is basically a plus-minus attraction. Because of this plus-minus attraction, whenever you have that plus-minus attraction, it is approaching the central metal cation, which is the D block cation. Now, D block cation has how many d orbitals? 5, and they all are degenerate. So let's say the D block cations have 5 degenerate orbitals, dxy, dyz, dzx, dx2y2 and dz square. When they are approached by ligands, generally what is the shape that they acquire? Sir, a central atom can be accommodated, can be approached by how many combining atoms? 6. Why? Because octahedral is the most stable three-dimensional polyhedron structure. So the central atom will allow 6 combining ligands to approach it, as in plus will attract minus. Now, what is octahedral shape? So ligands are approaching from positive x, negative x. I'm forming an octahedron. So from positive y, negative y, and from positive z, negative z. So ultimately, my electrons are present where? So they are present in orbitals. What are the shape of my orbitals? If you see dx2 y2 and dz square, then the orbital of dx2 y2 and dz square also lie along the coordinate axes. So if octahedral structure is going to be formed by the central metal atom or ion, what electrons will feel higher repulsion? The orbitals which are present along the coordinate axes. Therefore, once metal ion is approached by a ligand, splitting of degeneracy takes place because they are not encountering symmetrical charges around them. Charges are not symmetrical because orbitals are not similar shaped around the central atom. So whatever orbitals of mine are lying along the coordinate axes will feel more repulsion. So they have to be vacated so that the incoming ligand can come. In order to vacate themselves, we have to provide them energy to excite them. Energy cannot be created nor can be destroyed. So we split the degeneracy of d subshell. For example, let's say all the d electrons are having, when they were degenerate, they were having 20 rupees each. So total how much money they were having? 100 rupees. Because money cannot be created nor can be destroyed, so these three, what three? T2G set. What are T2G set? dxy, dyz and dzx, because their lobes are lying in between the coordinate axes, so they are not feeling that much of repulsion. Therefore they will provide energy, so their energy will decrease. So hence this is the barycenter of the average energy, so their energy is decreased. And who has taken their energy? The two orbitals whose orbitals are lying along the coordinate axes. So dx2 y2 and dz square becomes the EG set. dx2 y2 and dz square becomes the EG set of orbitals, and this causes the octahedral splitting. Because of this octahedral splitting, now again according to Aufbau rule, where you will fill the first electron? Sir, that first electron will be filled definitely in the orbital which is having lowest energy, that is over here. Second will be coming over here, third will be coming over here. Now what about the fourth electron? If this splitting is large enough, which is called octahedral splitting, then reaching the other subshell will be difficult. So rather I will pair. So fourth electron will go to the T2G set when the splitting is large. Now the amount of splitting that happens depends upon 1, the ligand that are coming, 2, on the metal cation. So speaking of the metal cation only over here, because ligands we will be discussing in coordination chemistry, which cation will create highest splitting? So that cation which will create highest splitting, which will have more polarization power, which will be having a stronger positivity. So who has stronger positivity? Sir, we already know. Down the group, ability to show higher oxidation state increases. So who will have higher polarization power? Cations down the group. That's why if you have 5D like platinum cations, then platinum cations always forms a complex with higher splitting. Why? Because for them they do not even depend upon the ligand. The cation itself is creating so much of splitting that this electron filling takes place. So this electron filling is why not traditional, because if you do not know this, then you know that subshell is degenerate. So how you are supposed to fill the 4 electrons, sir? 1, 2, 3, 4. So you will see that there are 4 unpaired electrons, but ultimately there are only 2 unpaired electrons. So splitting is created. Sir, this splitting, that means energy will be released, and that energy is known as crystal field stabilization energy. More amount of energy released, then the complex formed will be more stable. So this is called crystal field splitting theory. Now, sir, why you have explained crystal field splitting theory, that is crystal field stabilization over here? Because in D block also you should know that for chromium, I'm not saying for all. Okay, after that I'm directly coming over here. Yeah, so let me just finish that crystal field stabilization for you. Why I have discussed that theory is because of the fact that, yeah, I'll only over here only I'll write. If somebody is asking you about chromium plus 3, so rather if you know just this, not crystal field stabilization, then you will say chromium plus 3 has an electronic configuration of 3d3. So if 3d3 is filled, then 3d3 will have no extra stability. I mean, if you just see this, what is extra stable in it? Nothing. But actually with chromium plus 3, even water behaves as a ligand. Water also has lone pair. I'm sorry. Water, H2O, also has lone pair. So it can also act as a ligand. So with chromium plus 3 formed in water, even with water as a ligand, the splitting happens. Because the splitting happens, the actual electronic configuration is T2G and EG. And if you fill these 3 electrons, so it will be stable T2G3 configuration, which is nothing but stable half filled. So therefore, whenever chromium reacts, chromium plus 3 is formed, because chromium after reaction will form what oxidation state? The oxidation state which is more stable. And why chromium plus 3 is stable? Because for chromium plus 3, even water behaves as a ligand which creates the splitting. And T2G3 for chromium, not for all. For 3D series, I'm just speaking for chromium in water. For chromium, 3D3 configuration is even considered as stable, because splitting of degeneracy takes place for chromium plus 3. I hope we are clear with this. Point charge degeneracy, strong weak metal excess. Yes, beta. So coordination chemistry, I'll be discussing more about ligands, but metal, atom and ion I'm discussing here only. Hope it is clear. Now, moving to some properties of D block element, which you can obviously, I mean, they are just statement based one-liners. So you should at least just know this, that transition metals also have a capacity to form alloy. Why they have a property to form alloy? Because we definitely know their size is approximately same. Although we say it decreases, but we have seen the periodicity, it decreases gradually, very small decrement. After that, it almost becomes constant, and post that it increases. So ultimately, by the end of the 10 elements, you get almost approximately same size. So how alloys can be formed? When constituent solids have almost equal size, 15% difference, then any atom can replace any atom. So alloy formation for transition metals are very common, and these are some famous alloys. If possible, have a view on them and learn them, else you can leave that. I mean, not very much asked, but yes, have been asked a few times. Now, they also have, now for complex, I have already said how complex is formed. When ligand gives electron, they have empty d orbital, so they can take electrons, so they have complex formation tendency also. They can also form interstitial compounds, a very important property. Why they can form? Because we have already said that they form close packed structures, so they form solid. How a solid is formed? Constituent atoms touching each other forms a solid, but still after touching each other, there some empty spaces will be left, which are called interstitial sites. In those interstitial sites, who can come? These smaller elements like carbon, hydrogen, nitrogen. And once they acquire the empty position, the solid become more closely packed. So interstitial compounds have more higher density than the parent metal. Why? Because the voids are also filled in interstitial compounds, so they have a tendency to form interstitial compounds. These interstitial compounds, the stoichiometry is sometimes not followed. Why? Because let's say you have 100 places of this vanadium. all the voids will not be filled. If you have 100 places of vanadium, then hydrogen will occupy only 56 places. I mean, these sites, some sites can be occupied by hydrogen, some sites cannot be. So the law of multiple proportion, the law of definite proportion is not validated because of such compounds existing in nature. So they have a property to show interstitial compounds as well. Now interstitial compounds have some property which I've already said, that they have higher melting point than those of pure metal because the voids are also filled. Hardness, melting point, boiling point, interstitial compound has more than the pure version. But yes, ductility and malleability, pure version has are more ductile and more malleable because they can be tampered easily because the voids are there, so they can be drawn into wires and broken down into sheets because they are less hard. I hope this point is clear. Sir, for this, I think we splitting ligand power series ranging from sulfur. Beta. That is called spectrochemical series. Spectrochemical series we will do in coordination chemistry, not the complete series. I'll give you a trick for spectrochemical series. That the trick almost almost helps on all the mains level of questions. So do not worry. Now, moving forward. Okay, moving forward, what about trend in electrode potential, that is from M+2 to M? What is electrode potential? Sir, if I take electron from +2 to M, the electrode potential, as in that the reduction potential value, has to be compared. Now, if you are comparing the electrode potential, then you should know the Haber cycle, how it is happening. So let's say I have a solid metal. The solid metal has to form a aqueous cation in +2 oxidation state. So how does this happen? First, the solid metal has to get atomized, as in you have to convert solid to gas. After that, remove one electron and the second electron, so ionization 1 plus ionization energy 2. Then ionization do not take place in air, you have to take the transaction in a medium, which is water. So then the gaseous ion needs to be hydrated. That means enthalpy of hydration. So overall, what are the steps involved? Atomization, ionization, and then hydration. Why I have taken different colors? Because these are endothermic process and this is an exothermic process. So overall, we definitely know that along the period, what happens? Sir, along the period, ionization increases. So if along the period ionization increases, that means along the period, the investment is increasing. So investment is increasing. That means what? That means this process will become more and more difficult once we move along the period. If this process becomes difficult, that means spontaneity, as in delta G of this process, will be positive. That means spontaneity of the opposite process will be negative. That means from +2 to 0, as you move along the period, the getting from +2 to 0, the ability starts to increase. So point is, the trend is, as we know, ionization increases along the period generally. Therefore, electrode potential, that is reaching from +2 to 0, opposite, that becomes more and more easy, that becomes more and more convenient. How does this convenience will be represented? Sir, the value of electrode potential along the period will increase. And why will it increase? Because +2 wants to go to 0, because 0 forming +2 is difficult. So other way around, it will be easy. I hope we are clear with this. Now, again giving you the basic idea that if from 0 to +2, that is, I'm oxidizing itself, these are the favorable conditions, then I am just looking at this value, that ionization is increasing along the period. And because ionization is increasing, so getting from 0 to +2 is becoming difficult. Therefore, reverse process becomes easy. Therefore, reduction potential increases along the period. Now, this is a general trend, but one of the very famous factor here is hydration also. What is hydration? a cation can be hydrated because of its charge density. Charge density is a property of charge. More be the charge, easily it will get hydrate. Smaller is the size, easily it get hydrated. We definitely know, we have summarized this, that from +2 to 0 becomes very easy along the period. That means electrode potential increases. But if you plot and experimentally see, the trend is same. The electrode potential is increasing, no doubt. But if you observe, there is a dip for zinc. There are some dips over here also. So how to explain this dip? And one very important point is, for copper, the electrode potential is in fact positive. For all other 3D series, the electrode potential is negative. Only for copper it is positive. Who is having zero electrode potential? Sir, zero electrode potential is acquired by hydrogen. That means E naught of reduction potential, that is from that is from plus to 0. That is H plus to H2 is 0. So whoever has lesser electrode potential than hydrogen, those things, those acid, like for example, I'm taking, let's say, iron. So iron reacting with HCl forms FeCl2 or FeCl3, and hydrogen gas is released. We definitely know from class 10th, metal plus acid forms salt plus hydrogen gas. So all the metal can do that, but only those metal can do that. Now we can understand that which have lesser reduction potential than hydrogen, because hydrogen has higher reduction potential, so hydrogen will reduce. That means hydrogen will change its oxidation state from +1 to 0. But copper is having more reduction potential. So copper, if reacts with HCl, then you do not find such reactions, that salt plus hydrogen gas, because copper rather has a positive value of electrode potential. I hope we are clear. Here is so much peace. Okay. I hope we are clear with this. So what is the trend? It increases. But why it is decreasing down the group? Because for zinc, we definitely know zinc wants to go to Zn+2, because Zn+2 has stable 3d10 configuration. So because zinc wants to be in this oxidation state, therefore opposite it will not favor. Opposite reaction, as in reduction of +2 to 0, why will zinc want to reduce itself? That's why we have seen a dip in case of zinc. I hope we are clear with this. Yes. There is one, although you can, these are some, as I said, you can read them, but the basic I have already iterated. Certain points I have taken with a frame that complete details can be mentioned, but if you talk of just mains level of questions, then you can skip those points. Moving forward, rest I have explained. Now this also I have said that copper cannot liberate hydrogen, so this is also done. Yeah, high energy to transform copper to copper +2 is not balanced by its hydration. This is also a theoretical explanation that why copper is having positive oxidation state. That means copper +2 wants to go to copper. That's why its E naught is positive. How it is explaining this? The theory also sometimes say that if you compare the experimental value, this process takes place when copper solid gets hydrated. So if you compare the hydration enthalpy of copper, then if you compare it with the peers, their hydration enthalpy is quite large. But for copper +2, hydration is not that large. So it is saying that copper can't go from copper to copper +2. Therefore, opposite reaction will be more favorable. Because it is more favorable, so its E naught will be positive. And copper +2 is having very less hydration enthalpy because of the fact that its size increases. Because along the period size decreases, then it becomes constant and then it increases. So because of the increase in size and because of the factual reason that hydration, if you compare hydration of Cu plus 2 with other plus 2 cations of 3D, they have relatively high hydration, and copper plus 2 have lesser hydration, not with respect to everybody, because with respect to plus 1 I'll say the other way thing. So that's why I'm repeating it again, that copper plus 2 has lower hydration enthalpy with respect to other peers, other 3D series plus 2 cations. Now, so if you talk about plus 3 to plus 2 oxidation state, you need not know the periodicity, you just need to know some electronic configuration basics, like if from plus 3 to plus 2 E0 value is positive, let's say E0 value for some cation is positive from plus 2 to plus 3, that means what? That means the plus 3 of that cation wants to become plus 2. So if I want to become plus 2, that means I'll be feeling much more comfortable in plus 2 oxidation state. So for them, plus 2 oxidation state will be more stable. You do electronic configuration and you can generalize. Similarly, if plus 3, okay, now if this is the case that plus 3 to plus 2 is positive, then theoretically you can say that Mn plus 3 will be a good oxidizing agent. Why? Because it wants to reduce itself. So if I reduce myself, I will oxidize you. So I will act as a good oxidizing agent. So when can you say this? When E0 from plus 3 to plus 2 is positive for any particular cation. How can you say this? Just through the electronic configuration value you can understand. Similarly, speaking the other way around, if from plus 3 to plus 2 E0 is negative, let's say for any species it is negative, that means I do not wish to go from plus 3 to plus 2. That means my plus 3 is stable. That means my plus 3 is stable. So if my plus 3 is stable, that means plus 2 will want to get oxidized. So plus 2 will be a good reducing agent, as in plus 2 wants to become plus 3 because my plus 3 will be more stable in that case. So if plus 2 wants to become plus 3, so plus 2 will oxidize itself. If I oxidize myself, then I will reduce you. Then plus 2 will be a good reducing agent. These are some theoretical questions. I hope we are clear with this. Okay, IIT Delhi is saying, sir, PDF kahan milega? Beta, in WhatsApp channel, PWJ English. Post the live is complete, you will get the PDF in your PWJ English WhatsApp channel. Moving forward. Now, so see, these are the questions that you get from plus 3. The low value of scandium reflect the stability of scandium plus 3, as in scandium plus 3 to scandium plus 2. It is saying E0 value is very low. Question is why? Sir, scandium plus 3 is stable inert gas configuration. So if I'm stable inert gas configuration, why will I disturb that configuration? So I will never want to go from plus 3 to plus 2. So my E0 value will be less. A simple theoretical explanation. The highest value of zinc is due to removal of electron from, okay, it is saying Zn plus 2 to Zn plus 3, or inversely, because I'm talking of reduction potential. So getting, although this is a hypothetical question because we know zinc do not show plus 3 oxidation state. So it is saying that zinc getting from plus 3 to plus 2, the value of reduction potential is not high. It is saying it is highest. Why? Because for zinc, plus 2 is more stable. So for this guy, plus 3 is more stable. For this guy, plus 2 is more stable. So just as per the electronic configuration logic, you can explain many of such questions, because statement based questions will be getting from this side. I hope we are clear. Now, this I have already explained, so not the stable electronic configuration for chromium T2G I have already explained. So I've explained, although these are there in the slide because I wanted to give more, although I'll be skipping such slides because I've almost explained all the topics in concise way. Moving forward. Similarly, you can explain this also. I'm moving. This you can leave, it is a good topic. Now, if this is a question that arrange the stability of Cr plus 3, Fe plus 3 and Mn plus 3, then sir, Cr plus 3 we know this is stable T2G, so this is most stable. Fe plus 3 is, Fe is 4s2 3d6, so Fe plus 3 will be 3d5. So this is also stable, but we know that with chromium, water do the splitting, so that crystal field stabilization gives more stability to chromium plus 3. So chromium plus 3 stable T2G half filled. Fe plus 3 is also stable electronic configuration, but simple degenerate. There is no crystal field stabilization energy that has been released. Therefore, more stable is chromium plus 3. Then you have Fe plus 2. Mn plus 3 is not even formed, so it will have the least stability because Mn plus 2 is stable. I hope we are clear with this. So this completes this explanation. Now, in general, stability of plus 2 and plus 3 oxidation state decreases. Why? Because we know that electrode potential, even from plus 2 to 0 or even from plus 3 to plus 2, both value along the period increases. I mean, this I'm speaking in general. So what does this tell you? That plus 2, because the value is increasing, so plus 2 wants to go to 0, or rather plus 3 wants to go to plus 2. That means along the period, plus 2 is not feeling good. That's why it is going to 0. Along the period, plus 3 is not feeling good. That's why it is reducing. So along the period, stability of plus 2 and plus 3 oxidation state is decreasing. That's why you are trying to reduce yourself. So because E0 value is increasing, this signifies a theoretical statement that stability of plus 2 and plus 3 decreases along the period. I hope we are clear. Now, leaving this question for you as homework, because this we have already explained. Now, copper thing is important. Now, many copper compounds are stable in aqueous solution and undergo disproportionation, because you should know copper plus 1 in solution is not stable. Why? Sir, copper plus 1 has 3d10 configuration. Still you are saying it is unstable? Yes, because in water copper plus 1 is not stable, copper plus 2 is stable. Why, sir? Electronic hydration enthalpy. I told you copper plus 2 is having lesser hydration than other 3D series plus 2 state. But if you compare copper plus 1 hydration, copper plus 2 hydration, then copper from plus 1 to plus 2 requires more ionization, because copper plus 1 has 3D10 configuration. But that high ionization is more than compensated by the hydration, because copper plus 2 aqueous is more hydrated. Not with respect to all, with respect to its copper plus 1 counterpart. So in water, copper plus 1 compounds are not shown. Rather, if you have copper plus 1 in aqueous solution, then it undergoes disproportionation. From plus 1 to plus 2, it is oxidation. From plus 1 to 0, it is reduction. So a very important point, you should note this. And this already, I mean, this is the reason, I mean, which I've already explained. The reason is also written over here. So done. Now, formation of colored ions. Now, what are these colored ions? Sir, colored ions, we definitely know that because of the splitting of D, because of the splitting of D, the unpaired electrons can easily undergo excitation. How? By receiving energy from visible light. Once it undergoes excitation, it gives back the extra energy and comes back to the ground state. So this is my absorbed light. This is my emitted radiation. Remember the Vibgyor wagon, we'll draw it anyway, right? Violet, indigo blue, VIB, G, Y, O, R. So complementary colors. So these D block cations show color. Why they show color? Because of the splitting of the D subshell, they can be easily excited by visible light. Once they come back, they give back the electromagnetic radiation of visible range, because the range is visible, so you can see the beautiful colors shown by them. What is the general idea for them to show color? If they have unpaired electrons, these unpaired electrons can easily undergo excitation. So paramagnetic species will be colorful. Rather, if you have diamagnetic species, then diamagnetic species will be colorless, because paired electrons are not supposed to get excited very easily with visible light. I hope we are clear with this. Therefore, they form colored ions. Now, I have mentioned some of the colors, although these colors you should learn for advanced level of questions or for good questions, because NCRT, these are NCRT facts, but obviously you can leave them if obviously with this amount of time that we are taking, so even I'm leaving them for now, but these notes will be there, so those of you who want to still revise and learn them, so I mean you will be getting these notes also moving forward. Now, because D block cation have a tendency to show variable oxidation state, so this allows them to have catalytic action also. Like for example, if we have iodide ion reacting with this peroxo disulfate ion, then it forms I2 and sulfate ion. This redox reaction rather takes place very slowly. This is a very slow process. Who catalyzes the reaction? Ferric ion. How does it do it? First, ferric ion reduces itself and oxidizes I minus, so half job is done. And once you have ferrous ion, those ferrous ion reacts with the other reactant, which is peroxo disulfate, and itself it oxidizes itself and then forces the reduction. So ultimately Fe plus 3 is used and it is again given back, so it is a catalyst, but while doing so it increases the rate of reaction. So therefore, because of the property of showing this variable oxidation state, the D block cations, because of the property of showing variable oxidation state, these D block cations have catalytic action. Moving forward, these are some famous catalysts and the processes which you should learn. Some students were saying, sir, block chemistry chhodni hai kya? So these are some block chemistry data which are important, but yes, for if you are having less amount of time, you can leave them. So you can leave learning them, but yes, for good level of questions, you should know them. Now, talking about the oxides and oxy acids of D block elements, so this we have done in coordination in chemical bonding. We know whose oxides are acidic, so non-metal form acidic oxide, metal form basic oxide, neutral oxides are water, nitrous, nitric and carbon monoxide, and amphoteric oxide we have this rhyme Suno Janabe Ali already done in chemical bonding. Now, one thing that I'm adding in D block element, that generally metal forms basic oxide, but if metal have very high oxidation state, then the high plus will allow the metal cations to have high polarization power, and that higher polarization power will now start attracting electrons. So metals with high oxidation state can also show acidic behavior. So D block cations having high oxidation state becomes acidic in nature. I hope we are clear with this. Some examples like Mn2O7 forms an acid which is called permanganic acid. CrO3 forms an acid which is called chromic acid. It also forms dichromic acid, some famous acidic oxides of D block elements. V2, this you can leave. These are meant for good questions, so these you can leave. If you want to, then obviously it is there, but you can leave. Like you have this question, this is a physical property which you should know. This is a JEE Mains question, that Mn2O7 is a oil. What is a oil at room temperature? This is a physical property of Mn2O7 which you should know. This is true. And V2O5 does not react with acid. No, V2O5 is an amphoteric oxide, we definitely know. So this is wrong. Let me see what is its. Actually, I have 2 is your answer. Okay. So actually, see, which of the following is correct? So this is obviously correct. V2O4, I have already told you to leave it. Also, V2O4 reacts with acid. V2O4 dissolves in acid to form VO2 plus. Is a actual fact. And over here it is written VO2 plus. Actually, it forms VO plus, not VO2 plus. So rather, if it would have VO plus, then it would be correct. Here it is wrong. And CrO3 is basic. We know now. This we know that Cr plus 3 is amphoteric. So Cr plus 2 wants to become Cr plus 3. Cr plus 3 is stable T2G half filled. So Cr plus 2 wants to become Cr plus 3. So plus 2 becoming C plus 3 will be giving electron. So if I give electron, how will I behave? I will behave as a basic oxide. So A and C are correct. So option 2 is your right answer. A good question, but yes, some physical knowledge also it is requiring through option A. I hope we are clear now. D block compound, what theory, what theoretical knowledge you should not miss, sir? Okay. Notes, Yash, I've already told. PWJ English WhatsApp channel, once we are done with the live, notes will be posted. Maybe not today because team must have gone to bed. So tomorrow morning you will be getting these notes in WhatsApp channel PWJ English. Now moving forward, potassium permanganate and K2Cr2O7 are the two compounds which are highly loved by mains, advanced, everybody. So learning about them properly. So potassium permanganate is nothing but KMnO4. How it is formed? It is formed using an ore which is called pyrolusite having formula MnO2. What we do is we take this ore where manganese lies in +4 oxidation state. We treat it with any basic medium. It can be KOH, it can be potassium carbonate, any basic medium you take, and then oxidize it using oxidizing agent. You can either use excess of oxygen or use oxidizing agent like KNO3. So the ore gets oxidized to a green color solution of K2MnO4 called potassium manganate, not permanganate, because over here oxidation state is +6. So after formation of this green colored, if you heat and remove the solution, so you get a crystal. So after forming these green color potassium manganate, my next job is to convert manganate into permanganate. Now these green color permanganate is further treated in acidic medium. Acidic medium can be created either using acid or using CO2, because CO2 is also an acidic oxide. It will oxidize the manganate ion to purple color permanganate ion. This is one of the way. We have other way also. This is first way, A. What is not good in this method is we are obtaining permanganate, but apart from that we are also having MnO2, which will be acting as a impurity. If we want to create pure permanganate, then here permanganate is not pure. Here you are having manganese in +4 oxidation state also. So this is not a method to prepare pure version. So rather what we do industrially is we take the manganate ion and we put it into electrolysis. So post electrolysis in basic medium, what happens is you get anode, you get permanganate at anode and hydrogen gas at cathode. So electrolysis of the manganate ion produces permanganate is the second step of undergoing this oxidation. I hope we are clear. Sir, live is much long. Please reduce the time. Beta, I understand, but I'm completing complete inorganic along with physical 3 chapters. So allow me few more time. I'll be just finishing it now. I hope we are done with this now. One more method of converting manganate into permanganate is using this green color manganate ion, subjecting it to good oxidizing agents like ozone and chlorine. They both act as good oxidizing agent for manganate ion and they oxidize them to permanganate ion and reduces themselves. If you take chlorine, it becomes Cl minus chloride ion. If you take oxygen, it reduces itself to oxygen. I hope we are clear with this now. Post this, what are the properties of KMnO4? The major property of KMnO4 which you should learn is that it is stable only in strongly basic medium. If you have acidic medium or neutral medium, it will rather break and convert again to the manganate ion. I'm sorry, I'm talking of the manganate ion, not permanganate one. The manganate ion through which you have formed permanganate, this manganate ion is only stable in strongly basic medium, not other way around. It is only stable in strongly basic medium, not other way around. Now, this is extra beta. This you can leave. This I have already explained. A very important point. This slide, important, very important. Comparing manganate ion with permanganate ion. This is MnO4 minus the permanganate ion, which is yellow in, which is purple in color, and the green colored manganate ion, which is having chromium in +6 oxidation state. Here chromium is in +7 oxidation state. Because it is +7 oxidation state, so this is 3d0. That means this is diamagnetic, but still it is having no unpaired electron. But how it is showing color? Because we definitely know this is purple colored compound, because here the charge transfer takes place, the electron transaction takes place between ligand, which is the oxide ion with which is surrounding the manganese +7 cation. So electron from the oxide migrates and make a transition to the empty orbital of manganese +7 ion. So metal to ligand charge transfer responsible for the color, not the unpaired electrons. So that's why I say generally the cations who are having no unpaired electron can also show color. Why? Because of other reasons. One of the other reason is metal to ligand charge transfer. Similarly, if you see the structure, so it is obviously tetrahedral, and all Mn, if you draw the resonating structure, this minus can go here, so minus will be here also. This can also take minus, this can also take minus, so we'll draw the average resonance hybrid, and through that we can see that all the Mn bond O bond length are equal. Similarly, here it is in +6 oxidation state, so here we definitely have this unpaired electron, so its showing color is probable also because unpaired electron is present. It is also tetrahedral, and here also all the Mn bond O bond length is same because minus can go to any of the oxygen. So average resonance hybrid will tell you that all Mn bond O bond lengths are perfectly equal. Moving forward, now this you can leave. This is not required. This is a famous point. This is a block chemistry logic also, that KMnO4, when thermally decomposed, it stabilizes itself to form manganate, MnO2, and releases oxygen. So it is a method of preparation for preparing oxygen also. It is a powerful oxidizing agent in both acidic, basic, and neutral medium. We have already done this in redox. In acidic mediums, Mn+2, basic medium, strongly basic medium. Now we know that in strongly basic medium this is stable. What is stable? Manganate ion, the +6 oxidation state, and in neutral you have MnO2. We have already done it. So it oxidizes other and reduces itself. Reduces to what form? We have seen what are the oxidizing reactions. Ferrous become ferric, oxalate become CO2, iodide become I2, sulfide become sulfate, nitrite become nitrate, Pb and tin from +2 to become +4, sulfide becomes elemental sulfur. This is important, and elemental sulfur is reduced, is precipitated. H2O2 becomes oxygen. Now, one of the famous discussion point is, we know that with I minus in acidic medium, I minus is oxidized to I2. Agreed. But I minus gets oxidized to a different version in neutral or basic medium. In neutral or basic medium, I minus, although it undergoes oxidation also, but after oxidation it forms not iodine, it forms iodate ion. An important point, that in basic medium and acidic medium, the level by which iodide ion oxidizes itself is also different. So again, a block chemistry logic, but a famous one. Point to be noted. I hope I'm clear. Now, this I can leave. Coming to K2Cr2O7. Now discussing about K2Cr2O7, what we can say is how it is prepared. K2Cr2O7 is prepared from this chromite ore. What is this chromite ore? Chromite ore is nothing but mixed oxide of ferrous oxide and chromium oxide. Chromium is present in oxidation state +3. So what we do, we treat this chromite ore with sodium carbonate and oxidize this chromite ore. After oxidation, I get a yellow colored sodium chromate with formula Na2Cr O4, where chromium reaches +6 oxidation state. Now, with this yellow color sodium chromate, if I take it in acidic medium created by sulfuric acid, the sodium chromate converts into sodium dichromate. So that yellow solution becomes orange solution. Color are very important over here. post you get this orange solution, now my next step is to convert sodium dichromate into potassium dichromate. So there a physical application helps. What is that physical application? This sodium dichromate converts to potassium dichromate. And how this conversion takes place? Because sodium carbonate is more soluble than potassium carbonate. So if we react with KCl, then crystals of potassium carbonate gets precipitated, therefore shifts the equilibrium to forward direction. So if we treat this orange color solution with KCl, and orange color crystals of potassium dichromate is produced. This is the way. Okay, thank you. So this is the way how you produce potassium dichromate. I hope we are clear. So point of huge importance is solubility product of sodium dichromate is more. That means because it is more soluble, therefore it gets dissolved and crystals of potassium dichromate is produced. Point number 1. Point number 2, effect of pH. If you make the solution basic, then dichromate, orange color dichromate converts to yellow color chromate. If you again make the medium acidic, so dichromate again forms. That means K2Cr2O7 can only function in acidic medium. So thank God KMnO4 was oxidizing agent in all the medium, but this is oxidizing agent only in acidic medium, because it can only exist in acidic medium. In basic medium it transforms to chromate ion. Both of them has +6 oxidation state, chromate and dichromate. Both have electronic configuration which is stable inert gas, and if they have stable inert gas configuration, then how come sir color is seen? So for them also ligand to metal charge transfer takes place because of the what they form their color. Now just like KMnO4, if you heat KMnO4, it used to decompose. This also, if you subject to high temperature, this decomposes to potassium chromate, chromic oxide, and here also this is also a method of preparation of oxygen. So point to be noted. The melting point, boiling point, this you can leave. This is a heating effect is an important point. Now just like KMnO4, K2Cr2O7 is also a strong oxidizing agent. So it also oxidizes other and reduces itself. It only acts as oxidizing agent in acidic medium. So it converts into Cr+3 and oxidizes others. These oxidation reaction are same as that of KMnO4. I hope we are done. Now properties, the very famous property beta. This is also test of chloride ion. So when K2Cr2O7 in acidic medium takes any chloride salt, reddish vapors of chromyl chloride CrO2Cl2. The number of times the same reaction has been asked. So the reddish brown vapors of CrO2Cl2 is produced with this chromyl chloride test for detection of chloride ions. Now with hydrogen peroxide in acidic medium, K2Cr2O7 forms a deep blue color compound. This is CrO5 having the same famous butterfly structure. We have done it redox reaction. Although this is not stable, if you allow the solution to stand, it will convert into green color Cr2O3, because chromium stabilizes itself in +3 oxidation state. So this +6 oxidation state butterfly structure, if you allow it to stand, it converts into green color. But yes, if you do the reaction, you found this deep blue colored compound, which is the butterfly structure of chromium pentoxide. Chromium pentoxide is only stable if you want to keep this chromium pentoxide, then on standing it will decompose. So if you want to keep this CrO5, then you have to create a medium which is either organic by in ether. You have to use ether as solvent and then put chromium pentoxide, or pyridine. So in that solution this CrO5 can stabilize itself, else it cannot. Important point. Now quickly finishing F block elements. F block, mostly you find question in D block only. So what are F block elements? Definitely we know the lanthanoids and actinoids. Lanthanum is a D block element, not an F block element. Similarly, actinium is a D block element, not an F block element, but their property resembles. So their chemistry is studied with D block elements, with F block element, but they are specifically lanthanum and actinium are D block element because their last electron goes to D subshell. Now Again, the electronic configuration for lanthanoids, what are the because as per Aufbau rule, 6s must be filled, then 4f, and then at last 5d. But this 5d is filled. Whenever it is filled, we say it is an exceptional electronic configuration. So it happens for cerium, it happens for gadolinium. Why? You can obviously observe this through their electronic configuration. Cerium has some exception. GD has an exception because before that European have this 4f7, which is half filled. So because it is half filled, so one electron you will try to give to 5d. Why? Because why disturb that half filled configuration? So at least I have an option of attaining 5d1 configuration. Therefore this and this, only these three has this exceptional electronic configuration. Rest is strictly following the Aufbau rule. Point number one. Point number two is obviously along the period size should decrease, and for them Z effective is so large, so for them all the atomic size and ionic size has a gradual decrement, no problem. Lanthanide contraction is also valid for them, that we have already done. Just one point that you have to remember, that because of stable electronic configuration of uranium, stable full half filled 4f and fully filled 6s, because of the stable electronic configuration, just like manganese, whenever in between you get a stable electronic configuration, the size drastically increases because the species stabilized in itself, it will not interact with outside world. Therefore only a normality in atomic size, although it is gradually decreasing, but only a normality is present in europium, where you have stable electronic configuration. Now these are the 2 points which you have to keep in mind for lanthanoids. Rest, atomic size gradually decrease, that we already know. They largely exist in +3 oxidation state because for them 6s and 5d are the actual valence electron, so they show just the same reactions as like aluminium, because aluminium also show +3 oxidation state, they also show +3 oxidation state. If at all they are acquiring stable electronic configuration, maybe half filled or fully filled, then only they can form +2 or +4 oxidation state. But those +2 and +4 oxidation state will also try to again become +3. So when they will show +2 and +4, if at all by attaining +2 or +4 electronic configuration, they are acquiring some stable half filled or fully filled electronic configuration, then only they will attain that +2 and +4 oxidation state, else they won't. And even if they exist in +2 and +4 oxidation state, they will again try. So +2 state will try to become +3. So if +2 try to become +3, it will oxidize itself. Because it tries to oxidize itself, it will reduce others, so they will act as reducing agent. Similarly, +4 will try to reduce itself to +3, so they will reduce itself and oxidize others, so they will act as an oxidizing agent. So such questions will also be very famous. If you talk of that why they show +3 oxidation state, then going from, obviously we know successive ionization increases, so going from +2 to +3 requires high energy, but going from +2 to +3 requires very less increase in energy. Why? Because for them +3 is very stable. How you can do this explanation also? This is also attributed to the exchange energy that is released. So the number of exchanges increases, and therefore what oxidation state all the lanthanoids predominantly exist in? They exist in +3 oxidation state. This oxidation state I have already mentioned, so you can leave this slide, although it is giving some point, but you can leave this slide. This is the point that I'm making, like what type of questions you get, like ytterbium, its ground state is this, its +2 state is fully filled. Although because of this fully filled configuration, it will exist in nature, but not freely. It will also try to convert to +3. Europium +2 can exist, but it will also change to +3. Terbium +4 exists, but this +4 will also change to +3. So this you can leave, and this I have already explained. So IE3 of EU and YB is quite large. So why IE3 for them? Although for every lanthanide, what is the most stable oxidation state? +3. But still, if you compare their value from going to +2 to +3, other lanthanoids go very fast. They they also go to +3, but the as per their peer, as per the other lanthanoids, if you compare third ionization for europium and ytterbium, why it is large? Because europium +2 is half filled, ytterbium +2 is fully filled. So converting from fully filled and half filled to +3, where this configuration will be disturbed, will require more energy, but still their most stable oxidation state will be +3 only. But sir, here electronic configuration is more stable. No. What is their family? Their family shows +3 oxidation state. So all these elements also are stabilized in +3 oxidation state, whatever be its electronic configuration. And because they show only +3 oxidation state, so their reactions are also just like reaction of aluminium. Like aluminium react with acid, metal plus acid forms salt plus hydrogen gas. Okay, let me not disturb the beauty of the slide because these notes will be given to you. Aluminium react with oxygen to form aluminum oxide. So just think of them as aluminium. So aluminum oxide, aluminium hydride, aluminium chloride, aluminium sulfide. Yes, with carbon you should learn that they form carbide of the form LnC2 and Ln2C3. This you have to learn. With nitrogen it forms aluminium nitride, with hydrogen it forms aluminium hydroxide. So all the reactions, I'm deliberately saying aluminium because think of aluminium and make the reactions. Now another one important question will also come is the comparison of basic nature. From cerium till lutetium, if you move along the period, what can you say about basic nature? Because they can form hydroxide, we know. So what about basic nature? So that is also easy. How? As you move along the period, size decreases. That means bond length between lanthanoid and oxygen decreases. So as bond length decreases, it becomes difficult to break the metal bond, OH bond. That means release of OH becomes difficult. Therefore, who releases OH minus easily? The elements which are present initially, and as you move along the period, basic nature reduces. So basic nature decreases along the period with just atomic size. Sir, how long have you been teaching, sir? I guess you have placed that comment right now. I'm just finishing beta, just finishing this TNF block now. I hope we are done. Now actinoids, we do not have to worry about them because they all are radioactive post atomic number 92. In fact, all the actinoids are termed as trans-uranium elements or trans-uranic. Point to be note. Their electronic configuration you can leave, but yes, what is the trend that they should follow? First 5s should be filled, then 4f, then 5f, and then 6d. Yes, this 6d is filled, but only for actinium. Post that 5f should be filled. So whenever 6d is filled, that should be actually the conflicted electronic configurations, although I have circled them. But yes, for mains level of questions you can leave them. Moving forward, yes, for them also the size gradually decreases. If somebody asks you, then obviously you will have like lanthanoid contraction, actinoid contraction, because actinoid contraction will have more strong Z effective. So if somebody is asking you which contraction is dominant, so obviously actinoid contraction are stronger than lanthanoid contraction because here Z effective is more large. Talking about the actinoids, so just like 3D, if you say lanthanoids only show +3 oxidation state. Few can show +2, +4, but for them they work like 3D series because they have variable oxidation state. The electrons are belonging to very outermost shell, so they also have a property to show variable oxidation state. That also increases till, just like 3D series, increases till between, and after that it decreases. Now, yeah, this is the last slide for DNF block element. And what does this last slide is, in my mock test, the salt analysis students find very difficult. So what I'm suggesting you for salt analysis, do not do everything, just do this. What is this? The categorization of cations. What cations? The cations that can be precipitated. So they are categorized as per increasing value of solubility constant. The group 1 cations are precipitated easily. The group 6 cation is precipitated at the end. So these are becomes group 6. They become group 1. The group reagent, the reagent you should know, and what are the cations you should know, and they are precipitated in what form you should know. So whoever is willing to devote time in order to learn salt analysis, then at least do this cationic analysis of all the cations. I hope we are clear with this. Now let me just quickly, I will just take another 15-20 minutes, because after doing D block it will be quite simple to complete coordination. So I'll be giving you the coordination notes, but this is done. Let me quickly move to coordination chemistry, because coordination chemistry is what are the probable questions, because already most of the things of coordination compounds also we have done. So coordination complexes are those where we see these important terms. Addition compounds are double salt, which completely dissociate in water. Complex salt retain their complex identity, they do not show their complex identity, that's why we write them in square bracket. Central, they are constituted, first you have a central atom or ion, you have a central atom or ion which is acting as a positive point charge and attracting the ligands towards itself. The ligands are those species which are having excess of electron. They may be neutral, they may be positively charged, they may be negatively charged. So but at end of the day they are having excess of electrons which can be donated to the empty d orbitals of the metal atom or ion. The species written in the square bracket is known as coordination sphere, and what structure the coordination compound, the species, what structure it acquire can be decided by the VSEPR theory that we have already done in chemical bonding. If the ligands attached are same, then it is termed as homoleptic. If their ligands are different, then it is termed as heteroleptic. The number of ligands attached decides the coordination number of the complex, and complex when formed can obviously give electrons. So the oxidation state of the metal cation decides the way it is going to split the degeneracy of the d orbital. So oxidation number of the metal atom or ion, that calculation is also important. Now sir, can you give me, this is a slide which is good, but for mains level of question you can leave it, but I would rather say this is a general categorization that what is the coordination number, as in how many ligands generally what cation in what oxidation state takes. But yes, this you can leave for good question. So for time being I'm saying you can leave the slide. Now how these ligands are classified, these ligands are first classified on the basis of charge, positive, negatively charged or neutral. Then on the basis of their denticity, they can be monodentate, bidentate, polydentate. And lastly, the bidentate or polydentate ligands, what you have, why they form more stable complex is because they can form a ring formation with the complex. Ring formation is generally a stabilizing effect and is termed as chelation effect. Whenever a complex is making bond with a bidentate ligand, then with respect to metal atom or ion, the bidentate ligand or the polydentate ligand forms a ring which gives stability to the complex. So rather such complexes are stable in aqueous solution till very heavy extent. So chelation is a synonym for stabilization effect. And then you should know how to name a complex. So how we name a complex, we will understand that directly through example. So let us practice some questions. So okay, in these which of the following is a represent a homoleptic. So homoleptic, let us do with an example. So when all the ligands are same, so obviously first one is a homoleptic, rest are heteroleptic because different ligands are used. This N, so this is trimethyl amine, this is trimethyl phosphine, can act as ligand. Yes, definitely, because nitrogen is also having lone pair, phosphorus is also having lone pair, so yes, they can act as ligand. So this is true. As nitrogen and phosphorus forms are same group, the nature of bonding is always same. No, why? Sir, because their basic nature is different. Nitrogen has different electronegativity, different hybridization state. Although hybridization state, the Drago's rule. Remember that Drago's rule also. But obviously their basic nature is different. So the way with which they are going to give electron will not be same. So statement 2 becomes false. So 1 is true and 1 is true. 1 is correct but 2 is incorrect. So option, yeah, let me just check because this is correct. So moving to so option 2 is your right answer. Okay, I'm sorry, option 2 is your right answer. Moving forward, the coordination environment of Ca+2 ion and complex EDTA. Yeah, now EDTA, a very famous ligand. EDTA is ethylene diamine tetraacetate having 4 minus charge. How does this ligand ethylene diamine tetraacetate, as in ethane as in 2 carbons, diamine as in 2 nitrogen, so both these nitrogen can also ligate. So this is denticity 1 and 2, but every nitrogen is further having acetic acid group, so CH3 COO minus. This is also having CH2 COO minus. This is also having CH2 COO minus. This is also having CH2 COO minus. So total charge is -4. And what is the denticity? It can ligate, it can give and donate electron through these 2 nitrogens. So denticity 2. And with these 3, with these 4 O minus. So what is its denticity? Its denticity is 6, as in 1 EDTA can form 6 bond. So if 1 EDTA can form 6 bonds, so what it is going to form? It is going to form an octahedral complex. So this octahedral complex looks like what? So 4 bonds in the same plane, 1 bond up, 1 bond down. So what is the structure with 6 coordination number? So structure becomes octahedral. I hope we are clear with this. Now, next question says, dimethyloxime, a very famous complex, is formed with dimethylglyoxime complex with Ni+2. What happens is, this Ni+2 as a metal cation reacts with dimethylglyoxime, the coordination, the compound formed by coordination, carbonyl compounds, the oximes. But this reaction takes place in basic medium, and usually this dimethylglyoxime 2-DMG, 2-dimethylglyoxime ligands are ligated to nickel+2, but because of the formation of intramolecular hydrogen bonding, they come in a same plane. So how is the complex? What is the structure of this complex? Not tetrahedral, because when Ni+2 is coordinated from 4 side, coordination number is 4, but because of the formation of intramolecular hydrogen bonding, it rather occupies a square planar arrangement. So point number 1, this is a square planar arrangement, and the complex which is formed is a precipitate, and it looks like a cherry red PPT. So it becomes a very important confirmation test. So this complex of nickel, now this complex is having these ring. It is a 5-membered ring, because this is not considered as a ring because this ring is hydrogen bonded. This is the covalently bonded ring. In the question, it was a JEE Mains question, and it specifically asked dimethylglyoxime forms a 6-membered covalent chelation. No, this is a 1, 2, 3, 4, 5-membered covalent chelation. The 6-membered covalent chelation happens, but it is through hydrogen bonding, not covalent bond. So what covalent bond is formed? A 5-membered ring. So statement 1 is incorrect, and statement 2 says Prussian blue PPT contains both +2 and +3 oxidation state for iron. This is also a GOC logic. So what is the actual GOC logic? Actual GOC logic is when you are going to test the nitrogen present in organic compound, what we do, we convert it into a sodium cyanide complex, a sodium lesagnase extract, the NaCN. When the Cn minus is treated with ferrous salt in acidic medium, it forms FeCN6 complex. That in the presence of acidic medium, phi of the ferrous ion is oxidized to ferric ion. So those ferric ions react with the ferrous ions that are formed with the cyanide complex, and it ultimately give rise to the complex which is ferric ferrocyanide with the formula Fe4 FeCN6 thrice. Now this Fe is in +3 oxidation state, hence the name ferric, and this Fe is in +2 oxidation state inside the coordination side, hence the name ferro. So the general name becomes ferric ferrocyanide. I hope we are clear. I hope we are clear. Now just beta, I mean, I'll be just taking 10 more minutes and I'll be finishing this. Now then you, as per ligands, you should know what are ambidentate ligands. So ambidentate ligands are those which can ligate through two different sides. So what are those ambidentate ligands? Sir, the famous example of an ambidentate ligand is these. I've given you a list. These are the famous 3 ions making 6 ligands, that if NO2 minus can ligate from nitrogen also, from oxygen also. If it is ligating through nitrogen, it is called nitrito N or simply nitrito. If it is ligating through O, it is called nitrito O or iso. Actually this name is more prevalent, nitrito N and nitrito O. Now as cyanide, you can ligate through C minus also, and you can ligate through lone pair of nitrogen also. So if you are ligating through C, the ligand is called cyano C or simply cyano. If you are ligating through N, you are cyano N, or you can either be named as isocyano. If SCN minus is ligating through sulfur, it is called thiocyanato S or simply thiocyanato. If it is ligating through N, it is called isothiocyanato. Now these are the famous 3 ambidentate ligand. What is an ambidentate ligand? Which has a tendency to ligate through different donor sites. Moving forward, coming to IUPAC naming, as if you just, sir, how many solvation isomer opla chromium? Okay, beta, isomerism I'm just coming to. Let me do few examples of IUPAC. So K2MnO4, sir, this is a complex. So first name the cation K2, potassium, and what is the complex now? Sir, MnO4 with a charge 2 minus. So potassium, how you name a salt? Cation, then an ion. So cation is simple, so potassium. What about this? First you name the ligand. Who is the ligand? Sir, oxide ion. How many oxide you have? 4. So after potassium I have tetra. Now tetra what? It is oxido. So oxido, this is oxo gone, this is oxido. So ligand O2 minus is termed as oxido, because if you have O2 minus, that means you are negatively charged ligand. A negatively charged ligand are supposed to be named with a suffix O, either O or IDO. So this is oxido. So oxido, how many oxido? Tetra oxido. After that mangan, this is manganese. But when a complex is formed with a metal that is forming a negatively charged complex, then the name is even suffixed with the word which is ATE. So instead of manganese, I will name it as manganate with the suffix ATE whenever the complex formed is a negatively charged complex. So it is called manganate. And after writing manganate, you should write the oxidation state of the metal. What is the oxidation state of the metal? Let's say it is X. So -8 equals -2. So its oxidation state will be +6. So +6, manganate +6. So option 2 will be your right answer. Now, because now even I feel that I have all these D block logics for you with few selected questions also, the coordination logics, because we have already discussed crystal field theory because we have already discussed crystal field theory. So crystal field theory for octahedral complexes we know, crystal field theory for square planar complex and tetrahedral complex. For tetrahedral complex it becomes opposite, and for and for square planar complexes actually you first go to octahedral complexes and then you remove the ligands from z axis. So what happens is further splitting takes place. So crystal field splitting of octahedral is more, tetrahedral is less, but for square planar it is even more than octahedral complexes. So all the slides are definitely there for coordination compounds, but yes, because we are actually super exceeded with the time, and even I am now feeling, although I wanted to finish, but yes, I know that those who must be seeing it live will be exhausted. Do not worry, because work sometimes is quite exhausting, but do not worry. If you find any doubt, I will be giving these lecture notes also. So but I would rather suggest that whoever is reading it religiously, please go through these coordination notes also. If you find any problem, you can always comment in the comment section. I'll be coming back with the discussion of the day 2. Then I'll be discussing some of the slides to which you will say, sir, I am having doubt in this topic. So I hope we can end this. So best of luck, beta. Work to the best of your efficiency. Good night and take care of yourself. Bye bye.